Yeah, hi everyone, welcome to PrepFusion. So now we are going to see the video solution of whatever that was conducted. Our All India mock test BoosterX was conducted, and then now we will see the solution of all 65 questions. What was the level of the examination? I do not know. As per me, I have set it to be moderate. Okay, I have set it to be on the moderate side. Now I will see the response of the student when I am recording this particular video. At this time, it is not conducted yet. Okay, when I am recording this particular video, as of now, the test is not conducted. Tomorrow the test will be conducted. So I would see the score of all those people, and then based on that I can make a slide that yes, this much marks you can expect. What was the marks of topper? I will not reveal the name. I will just tell them what was the marks of topper and how much are the safe marks, and based on your score, where do you stand and what kind of paper level it was. So based on that I will frame a particular slide. Same goes for electrical as well, and we will be coming live at 6:30 p.m. Whatever the analysis that we did for Killer X, the same analysis we are going to do for Booster X as well. So complete discussion would be there at 6:30 p.m. tonight. Okay, this video is being uploaded at 1:30 p.m. or 2 p.m. Then at 6:30 p.m. today, not tonight, I would say today's evening, we will be coming live and we will do the complete discussion. And whatever the queries that you are having, you can ask that particular query as well. Okay, so let's see the solutions. One by one, we will see the solution, and I want you to spend at least 3 to 4 hours on this particular video so that you can learn something good. Surely you are going to learn a lot of new concepts, and those concepts would be introduced in your examination as well. So let's get started with the solution of aptitude. Let's see the first question. Yeah, so let's see the solution of this one. I will read the line. I know that, sir, I don't know the meaning of this particular thing. What is this written? I don't know the meaning. Exacerbate. Okay, but I can read the statement. I would get to know that yes, I can get the correct answer. During the design of high-speed digital circuits, engineer must carefully manage the signal integrity issue. Improper termination can reflections on the transmission line. What do you think? What it would do? Improper termination would, what it would do? It would increase, right? It would increase the reflection on transmission line, leading to the timing error and the degraded system performance. Like, sir, even if I don't know, sir, what will improper termination would do, then also you can understand. No, from the sense of the meaning that you need to take care of something. You need to take care of something, otherwise something would happen. Right? Are you able to understand this point? You need to take care of something, otherwise something would happen. You need to take care of health, otherwise you will not be able to study. So there will be a sense of negation. And what is the negation? Reflection coefficient will be increased. So intensify. That's it. I don't even know the meaning of this alleviate as well. Post one I know suppress, Post one will not be there, but I can understand that surely it will be intensify. The reflection coefficient will be intensified. That's why the answer would be 2. Okay. Let's go to the next. Yeah, so here the decreasing order of intensity is given. Okay, terrified, like very much terrified or very much afraid, then uneasy. I am feeling uneasy, right? You know the meaning of everything. Hot, warm, then what should come? You don't know the meaning of this tepid, right? You know the meaning of mild. Mild means lesser warm only, so this would not come. You might have heard the word scorching, like there is a scorching heat in Rajasthan. At 12 p.m. in the noon there will be scorching heat. So that you might have heard, right? Scorching. So that means very hot, very much hot actually. So scorching would come. Okay, and lukewarm means lesser than warm. Here lukewarm would come. Like very much less warm. Lukewarm. Okay, so this would also not come. Scorching would be the answer. Yeah, let's see this one, very straightforward. How many marbles Z is having? Let's just say Z is having P number of marbles. So how much Y is having? Y is having P plus 10. So how much X is having? X is having 1/3 of the total number of marbles with the others. So others are having 2P plus 10. So he is having 2P plus 10 divided by 3. So this much marble X is having. You know that total number of marbles are 120. How many marbles Z is having, that you need to find out. So P plus 10 plus 2P plus 10 divided by 3. That is equals to 120. Now it depends on your calculation. So this is 2P. So this would become 6P plus 30 plus 2P plus 10. That is equals to 360. 360 minus 40, 320. 320, 8P equals to 320. 40. Okay, so that's the answer. Yeah, so how do you solve these kind of problems? Everyone has some different technique. If you are having some different technique, then don't change it for me. Okay, if you have studied from me, then solve with my technique only. So how many people are there? There are 6 men who are working at their own efficiency for 10 days. 6 men having efficiency of M, working for 10 days, plus 8 women having efficiency of W working for 10 days will get your work done. Work is X. This is your work. So to get your work done, you need 6 men having efficiency of M working for 10 days. 8 women having efficiency of W working for 10 days will get your work done. Similarly, other thing is also given that 26 men having a efficiency of M. Efficiency of man I am saying, what is that? Efficiency of man is M. Efficiency of one man is efficiency of a man, that is M. Efficiency of a woman I am calling as W. Okay, so 6M into 10 plus AW into 10 equals to X. Now 26 men with the efficiency of M are working for 2 days, and 48 women with the efficiency of W is also working for 2 days. They will get their work done. Now we can compare now from here we will get the relation between the efficiency of man and efficiency of woman. What I can do is that 60M plus 80W, 52M plus 96W. So what we are getting, 8M equals to 16W. So it is given that one man is twice efficient of a woman. This is just given in the problem. I am not saying it. Okay, this is just given in the problem, so please don't be offended. Even a woman can be 3 times efficient of man, or even a man can also be 3 times efficient of woman, but this question is saying that man is twice efficient of a woman. Okay, so this is what this question is saying. So now you need to do the X task only, but how much days it would take. So you are having 15 men and 20 women. This is the scenario you are having. Both will work for X days, right? Now just let me know one thing. 15 men, 20 women. Is it equivalent to 25 men? Because 20 women will be equivalent to 10 men. As per the given question, not according to me. As per the given question, 20 women would be equal to 10 men, because 2 women would make 1 man. 20 women would make 10 men. So this is equal to 25 men. So it's like 25 men working to do the task. Right? So how many days they would take? So if I come here in this scenario, so just let me know in this particular scenario, how many men were there? 26 men were there. And how many women were there? 48 women were there. What does that mean? 24 men? Say yes or no? 48 women means 24 men. Like, read this line now. 26 men and 48 women can complete the task in 2 days. What does that mean? 48 women means 24 men. So 24 men plus 26 men, that means 50 men. So 50 men are doing the work in 2 days. So how much time one man would do? How much time one man would take? 100 days. 50 men are taking 20 days, so one man would take 2 into 50, 100 days. So how much time 25 men would take? So 25 men would take 100 by 25. 4 days. That's it. So some people apply some formula and everything, but I don't believe in formula in aptitude. So this is how I solve it. Okay. Just people, their efficiency, multiply with number of days will be your work done. That's it. And then simple thing is there. Okay. Let's go to the. Yeah, this is very tough to solve. When I saw this question for the first time, actually this question is framed by Anish sir. Okay. He framed it. But when I saw it for the first time, I was not able to solve it. What I thought, first let me tell the answer. So answer is, this is 13 square minus 1, and this is your 11 square minus 1. And how you can get 11? You can get 11, 5 plus 1 plus 2 plus 3. How you can get 13? 6 plus 2 plus 3 plus 2. That is 13. So here what you will do? 5 plus 3, 8, 12, 14. 14 square. What is 14 square? 196. So 196 minus 1, that would be 195. This is the answer. But would it click to you? Is it that easy? No. Right? It is not very easy. So it might happen that sometimes these kind of questions are not clicking, then just simply drop it. If I had been a student, I would have spent 1 or 2 minutes and then I would have dropped it. It would be a heavy heart that I am not able to solve an aptitude problem, but still drop it. Okay, because it is not very straightforward that it would click to you. 13 square, 11 square, 14 square. Okay. What I thought was like how I proceed. Just as I saw 120 and I saw 5 as well, then what would click to me? 24 5s are 120. This is something that would click to me. 24 can be written as 8 into 3. So 2 to the power 3 into 3 into 5. So this was clicking to me. So what I thought is that 2 to the power 3 into 3 multiply with 5. So similarly 3 to the power 2 into 2 multiply with 6 and then multiply with 1 as well. So I tried different combination, but I was not getting answers. Okay, because that's not the approach. Okay, so I tried everything, but I was not getting the answer. In the examination, I would have simply dropped it. This is what I would have proceeded. Okay, in the examination, I would have surely dropped it. But it is very tough to get these kind of questions correct in the examination. Let's go to the next one. Yeah, this is a very standard PNC problem. Very standard. These kind of questions have been asked a lot of times in the GATE examination, and like these are very standard as well. If you have studied PNC, then surely it would be there in your class notes as well. Number. So how we will be starting in the dictionary? First we will be start like what is the order? B is the smallest, then A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X. In that manner, 6 numbers. So first we will be starting with B. How many spots would be there? 5 more spots would be there. Then next we will be starting with E. The next we will be starting with N, M, and then we will be starting with N. So all these spots, what that would be equivalent to 5 factorial into 3. So all these spots would be filled, then N would come up. Now, just as N comes up, what will be the next word? Sorry, not word. What will be the next letter? That would be B. N, B. Then rest of the letter would come. That means 4 letter would come. Now after B, whose turn it would be? After B, who would come? E would come. Then again 4 space would be there. Now after E, who will be having the term? M. So in that manner, first B, then E, then M, and then R. So M will have the term and then R will have the term. Right? These 4 guys will be having their terms. So 4 factorial, 4 factorial. So this was the first scenario, 5 factorial into 3. Now the second scenario is 4 factorial into 4, because after this what would come up? After this U would come up. So after U, then what would come up? B would come up. N, U, B. So after that, how much space is there? 3 space is there. So 3 factorial. After B, who would come up? E would come up. N, U, E. How much space is there? 3 factorial. After that, M would come up. Okay. After that, B would come up. After that, E would only come up. And after that, who would come up? N would come up. I'm sorry, N is already there. So who would come up? R would come up. Yeah. So that's the next one. Look, if you don't know what I am doing here, that means you need to study this concept. I cannot give the whole concept in this particular solution video, no? So you need to study this concept, that how to get the rank of a particular number in the dictionary. So answer is 5 factorial into 3 plus 4 factorial into 4 plus 3 factorial into 2 plus 1. So let's do this calculation. 120 into 3, 360 plus 64, not 64, 24 into 4, what that would be? 24 into 4, 48, 96, 12 plus 1, 9, 6 and 4, 469 is the answer. Okay, well and good. Let's go to the next. Yeah, so this is also a very standard type of pattern. These kind of questions were there in our elementary classes as well, right? So what we need to do, we need to cover a distance of 21.5 meter, and what monkey is doing, we need to cover a distance of 21.5 meter. What monkey is doing, he will go for 2 meter, he will go for 2 meter and then fall back for 0.5 meter. What does that mean? In 2 minutes, he is covering 1.5 meter. So 21.5 meter, how much time he would take? Will I simply divide it? No. Like, will I do this particular thing? 21.5 divided by 1.5 into 2. That would be wrong. Why is that so? So let's reach as near as we can. Let's say that let's do 12 times of this. That means in 24 minutes, how much distance he would cover? 12 times of this we are doing. Here we have done that 12 times of this. So here also we will do that 12 times of this. So how much distance we are getting? 12, 6, 18. 18 meter he would cover. After that, what he will do? Make a jump of 2. That means he will go to 20 meter. Then fall back. He will come to 19.5 meter. That means this much process would have taken him 2 minutes. After that, what he would do? 2 minutes. After that, what he would do? He would again make a jump of 2.1 meter. Sorry, he would again take a jump of 2 meter. That means he will reach at 21.5 meter, right? Yes. So how much time this would take him? 1 minute. So for 24 minutes plus 3 more minutes it is taking. That means 27 minutes it would take him. That's it. This is the answer. Okay. Let's go to the next. Yeah, that's a good question. I would say time taking, not good. It would be taking some time. So scenario is, okay, I don't have any other page, so I need to add a page. So angle of depression, you would know. Angle of depression is social media actually, but here it is something else. Angle of depression is 60 degree. So this angle is 60 degree. This height, let's just say this is h. It needs to cover a distance of let's just say x. So starting from here till the point that angle of depression is becoming 30 degree, till that particular point he has taken some particular time. How much time he has taken? To cover this much of distance, let's just say this distance is y. So to cover the distance of y, he has taken 10 minutes, right? So what we can do is that we can see that tan 60 equals to x by h, and tan 30 is equals to y minus x by h, right? What we need to find? We need to find the distance, x distance we need to find. In terms of y, if I find it, my job would be done, because I know that y, to cover the distance of y I need 10 minutes. So to cover the distance of 2y, how much time I would take? 20 minutes, right? To cover the distance of 1.5y, how much time I would take? 15 minutes, right? So I need to find out x in terms of y. That's it. This is my target now. X in terms of y. That's my target. So from here I can sense that x is coming out to be under root 3h, and y minus x is coming out to be h by under root 3. So what will be h? H will be x by under root 3, right? What will be h? H will be x by under root 3. From here h will be x by under root 3. So this would become x by 3. So y would become 2x by 3. So what x would become? X in terms of y, that would be 1.5y. That's it. Job done now. If for covering the distance of y you are taking 10 minutes, so covering the distance of 3y to y, how much time you would take? 15 minutes. That's it. So you read the statement carefully. The boat will reach the shore from the point where angle of depression is 60 degree in minutes. So from this particular scenario to here, how much time it would take? So 10 minutes here and 5 minutes here. So answer would be 15 minutes. Let's go to the next one. Again, very straightforward. Who is consuming the most of the energy? Electrical. Okay. Electrical or EC. Electrical guys would consume most of the energy. So electrical department shows a constant increase in the consumption over 3 years. Yes. It is not consistent. Okay. It is constant. Like here, if it was 140, would you click on this answer? In place of 135, if it was 140, would you click on this particular option? No. Constant, not consistent. Consistent means, yeah, there will be increase. Like Virat, today he is scoring 50 runs, then he is scoring 60 runs, then he is scoring 70 runs, some day he is scoring 200 runs, some day he is scoring 45 runs. So we will say that he is consistent. Or let's just say here he is scoring 210 runs. So we will say that he is consistently improving, right? But if he is scoring 50, 60, 70, 80, 90, 100, then we will say that increase is constant. Okay, so just take care of this thing. This could have been a very good question if it was 140 here. If it is 135 only, that means constant increase is there. 15, 15. And you guys would be thinking that, sir, MSQ. You see the pattern of GATE question paper, nowhere it is written that in aptitude there could not be MSQ. Although in the previous year, always MCQ has come in aptitude, but MSQ can also come. Okay, so just we are taking a guess. Who knows, it may come. So just I put this particular question as MSQ. Computer science department has the highest percentage increase. From here to here you need to go, no? From 21 to 23. 21 to 23. So they are increasing by 70 by 90. Like I am having 20 rupees now. Tomorrow I am having 30 rupees. So how much increase is there? 50%. So how would I find out this for 50%? 30 minus 20 divided by 20. So similarly, from 90 to 160 I am going. So how would I find out the increase? 70 divided by 90. So that would be 70 by 9. $700 by 9. So whatever the answer you are getting, 70 point something, whatever that you are getting. So that is very high. You can see that here the gap is 25 by 80. 25 by 80. Surely this would be higher only. You can see here the gap is 40 by 100. Here the gap is 30 by 120. That is 25% only. So surely where is the highest? In the computer science department. The total energy of consumption of all departments in 2022 is greater than 2023. No. Surely this guy is more. Like here you are increasing only. In everywhere it is increasing only. That means in 2022 it is lesser than 2023. The mechanicals department's energy consumption increased by 40% from 21 to 23. From 21 to 23. Mechanical 21 to 23. 40 by 100. Yes sir. 40% increase is there. 140 minus 100 divided by 100. So 40% increase is there. Yes. So 1, 2, 4. That's the answer. Let's go to the next. Yeah, so it is not based on sampling or anything. Okay, even if you don't know sampling and all, still you would be able to solve it. Like in the gate examination, these sampling and all these things will not come in aptitude. They will frame a generalized paragraph, but still, if I want to make a bit tougher, then I would frame it in this manner. But again, you don't need any knowledge. You just need to read it and then you need to understand. So what you can understand, modern communication system increasingly relying on digital signal processing to improve reliability and efficiency, while higher sampling rates can capture more signal detail. Higher sampling rate means more details, more signal detail. But there is some issue as well. They also increase computational load and power consumption. So power consumption, increasing the power consumption, that is an issue, and computational load, that is also an issue. So while means जबकि ऐसा हो रहा है, ये भी हो रहा है. Like something is happening good, but like while I get some enjoyment watching cricket, I am losing some time as well. Like I will feel good when I watch cricket, but I will lose some time as well. So that's the thing here. While means it is giving the sense of negation. Okay. Engineer therefore often choose sampling rates that balance performance requirement with hardware limitations rather than simply maximizing their resolution. So basically we need to have a trade-off. We need to maintain an equilibrium. There will be a trade-off between the performance and the sampling rate. You cannot increase sampling rate very drastically and you cannot decrease it very drastically as well. So there has to be some equilibrium. So this is what this paragraph is saying. Increasing the sampling rate always leads to better overall system performance. No. Overall system performance, no. If you increase it, then there are some issue as well that more power consumption would be there, computational load will also be there. Power consumption in digital system is independent of the sampling rate, no. Sampling rate higher power consumption. Practical system design involves trade-off between the signal quality and implementation constant, yes. So constant was that you cannot increase sampling rate drastically. So yeah, there is a trade-off. Hardware limitation completely prevent the use of high sampling rates in communication system, no. You cannot, it is not saying that you cannot use sampling rate, higher sampling rate. We can use higher sampling rate, but there has to be some limitation. Okay then? Yeah. So third would be the correct one. Let's go to the next one. Now we will start the technical part. Yeah, so this one is based on AC analysis. Again, you cannot drop these kind of questions. In EC, very simple AC analysis question would come up, and this is very simple only. What do you know? That this 5 ampere current, this 5 ampere current, this 5 ampere current, that would be equals to IR square plus IC square under root, right? Because you know that both of them are having the same voltage. Both of them are having the same voltage. If they are having the same voltage, then here the current would be leading, because this would provide an impedance of 1 by j omega c. Right? That means voltage divided by the impedance 1 by j omega c. That will be the current in the collector. Sorry, current in the capacitor. So what that would be? J omega c b. So current would be leading the voltage by 90 degree. So this would provide a leading current. This would have a zero phase, right? The current would be zero. Sorry, the current phase of the current would be zero. So basically here you can write down, if I write down in the phasor form, then IR plus JIC, that would be the total current. That would be the total current here. This would be, let's just say this current is I1. So this would be the scenario, right? And if you just take the magnitude, all these are magnitudes shown. This would be written as well. Phasor current magnitudes are shown. So from here you can see that IR value is coming out to be, so this is 925 4 ampere. So here there is 4 ampere current. 4 ampere current is here, 3 ampere current is here. So total 5 ampere current is here. Now from here there is 5 ampere current. Now this is the total current, right? All the elements are having the same voltage. Same voltage, what does that mean? That means the current would be somewhat like this, that this current would be lagging in the phase, right? So total current would be nothing but resistor current plus current in the capacitor is leading, current in the inductor will lag, right? So what will be the total current you are getting? Sir, I total square we are getting as IR square plus IC minus IL square, right? So I know the value of I total 25 minus 9, that would be IC minus IL square. Now IC minus IL is coming out to be, sorry, this was 4, no, this would be 16, sorry guys, this would be 16. So this is coming out to be plus minus 3. Either it can be plus 3 or it can be minus 3. If it is plus 3, then IC is already 3, IL has to be 0. So will IL be 0? No. Why is that so? Because note that none of the element is providing infinite impedance. If it is not providing infinite impedance, what does that mean? It can never be 0. It will be some finite value. So if it would be some non-zero value. So other value would be what? If this is 3, then this has to be 6. That's it. Okay. So the current has to be 6. 6 minus 3, what that would be? 3. 3 square will be 9. 9 plus 16, 25. 25 and would be 5. So answer would be 4 and 6 ampere. Okay. So what is the value of IR? IR is 4 ampere, IL is 6 ampere. Well and good. Very straightforward. Okay. So these kind of straightforward questions you cannot drop. Let's go to the next. And this is again based on a transmission line. Very straightforward. L by 4 impedance will be inverted. Z naught square by ZL. Right. 4 lambda by 4. That means it is equivalent to lambda only. I deliberately put 4 lambda by 4 here. Because someone would say that, okay, lambda by 4 multiple. Then he would again apply Z naught square by ZL. This is the multiple of lambda, no? Right? Here for lambda by 4 you need odd multiple. This is the odd multiple of lambda by 4. Right? This is the odd multiple of lambda by 4. So in case of lambda by 4 we need the odd multiple, because at lambda by 4 whatever that happens, the same thing will happen at 3 lambda by 4 as well. After a gap of lambda by 2 everything repeats. Right? So same would happen at 7 lambda by 4 as well. So this is equivalent to lambda by 4 only. So here what will be the impedance? Here the impedance would be Z naught square 75 square divided by ZL. Now this is lambda only, so here also the same thing would take place, because after every lambda by 2 the same thing would repeat. So lambda by 2 plus lambda by 2, that means same thing would repeat. So here as well the impedance would be 75 square divided by 30 minus J20. And here what would happen? The impedance would, let's just call this impedance as at ZA. So here the impedance would be 50 square divided by ZA. So what is the value of ZA you are getting? I am getting as 50 square divided by ZA, which is 75 square into 30 minus J20. So this calculation was not very complex. I know a lot of students would have been involved in the needless calculation. So this whole question paper is not lengthy. Okay. The whole question paper is not lengthy, but a lot of people will complain that, sir, it was lengthy. I'm pretty sure. But you would see the solution. The whole question paper is just very straightforward, not lengthy at all. 13.33 and so first one we are getting as 13.33 minus J 8.88. So this would be the answer. Okay. So the whole question paper is like this only. It is not lengthy. You would see it.
A semiconductor memory is organized as a matrix of rows and columns. Each memory location stores 4 bits of data. If the memory has 3 address lines, calculate the total memory size. So basically a memory, generally we know it, right? Memory is organized as a matrix only. So I will have rows and columns. Do you remember what does column represent? So column, right, if you remember, we represent as data. So all this will be data and this will be my address lines. So I'll just give you a brief example, right? Let's say my size of address is 2 bits, right? 0001 1011, and the size of data, let's assume that each address, right, can contain 4 bits of data. I'm just taking a very basic example, right? So 4 bits of data, right? And if I say that each particular element will contain each bit, right? So there will be 4 columns, 1 2 3 4, and I will have 4 rows, right? Now what is the total size? So what is the total data size that this total semiconductor memory can hold? So 4 bits, right? 4 bits, and I have 4 rows. Each row can store 4 bits. So 4 rows can store 16 bits, right? Bits. And what about bytes? So bytes would be, because 8 bits is 1 byte, so bytes would be 2 byte, right? Although this is not practical, right? I'm just giving you an example. This is not practical, we don't do it, okay? Telling you at the starting itself. So I'm just giving you an example, okay? That is how we organize the memory, and that is how we calculate the size of the memory. Now let's come back to our question. They're telling me that each memory location stores 4 bits of data. Okay, so this example actually works here. We store 4 bits of data, and if the memory has 3 address lines, so basically memory has 3 address lines, right? So line can either be 0 or 1, right? 0 or 1, 0 or 1. So essentially I have 3 bits in the address. That is what they mean by 3 address lines. That they're technically telling me that I have 3 bits, right? 3 address lines basically means that I will have 3 lines that will choose these 3 bits. Either it will be 0 or 0 or 1, depending on the values of the wire, right? So to how many total number of addresses I have? It will be 2 raised to the power of 3, right? It will be 2 raised to the power of number of address lines, 2 raised to the power of number of address lines into the data stored in each address line, right? Data stored in each address line. So data in each address line. Okay, let me write it properly. Data stored in each address line, right? This is a simple, like, this is the formula that you will use obviously, and in most of the places they will directly say you this is the formula, but I'm explaining you what is happening. So I have 3 address lines, and in each address line I have 4 bits of data, and this formula will also be divided by 8, right? If the data stored in each address is in bits, right? Because we have to convert bits into bytes. Ultimately we think about bytes. So this will be 4 divided by 8, right? Bits. So it will be technically 4 bytes. So overall the memory, semiconductor memory, will store 4 bytes of data, although we'll never practically use this, but this is just a question for your understanding of semiconductor memories. So answer of the question would be 4 bytes.
Yeah, let's solve this question. How would you solve these kind of problems? Here it is written, no, that this kind of input is applied, then this kind of output you will be getting. If you apply RT, then you are getting CT output. If you are applying DRT by DT, then you are getting YT output. In these kind of problems, you always should make the system. That's why there is a system. When I am applying the input to be something, I am getting some output. Then sir, again the same system is there. When I am applying some input, I am getting some output. Right? Now what they are asking, they are asking the value of CT at t equals to 0 seconds. So let's see what is happening here. Sir, when I applied DRT by DT, this is the first statement that is written. Or can I start from RT? Because this is also written. No? When you apply RT, you are getting CT. When you apply RT, you are getting CT. And then sir, when I apply DRT by DT, what I am getting? YT. Right? Causal LTI system it is. Do you know one property? If you differentiate the input, output should also be differentiated. So when you are applying RT, output is CT. When I am applying the differentiated input, I will get that differentiated output as well. What does that mean? YT is nothing but a dCT by dt. There you go. So in place of YT, you can simply put dCT by dt. And then it would become what it would become? It would simply become a differential equation. So the equation is coming out to be dCT by dt plus 2CT equals to 3 e to the power minus t ut. Since it is a causal LTI system, you don't need to care about the initial conditions. So s plus 2 into C of s 1 upon s plus 3. Yeah. So 1 upon C of s would come out to be 1 upon s plus 3 into 1 upon s plus 2. So s plus 2 minus 1 upon s plus 3. Okay. So Ct would come out to be e to the power minus 2t e to the power minus 3t ut. There you go. So at 0.2 second they are asking. So if you put e to the power minus 0.4 e to the power minus 0.6. So 0.6 plus minus e to the power minus 0.4 plus minus e to the power 0.121. Rounded off to 2 decimal places, that means 0.12. That's the answer. Okay, well and good. Let's go to the next. Yeah, so we need to find out the entropy. Entropy of x. This is something that we need to find out. What is x? X is a random variable which tells the number of attempts to get first tell. So if I toss the coin for 1 time, then also I can get a tell. If I toss it for 2 times, then also I can get a tell. 3 times, 4 times. So x can take any kind of value. What will be the probability such that x is taking value 1? What is the probability such that you get a tell when you toss the coin 1 time only? Or that would be 1 by 2. Probability x equals to 2. You need to get only 1 tell until the first tell appears. You will keep on tossing that coin until the first tell would appear. Right? So first time I tossed, I got head. Second time I tossed, I got tail. So what will be the probability? This will be the probability. X equals to 3. First time got head. Second time also got head. Third time I got the tail. 1 by 8 and so on. So when we find out the entropy, who matters? Only the probabilities matter. Minus sign outside. 1 by 2 log 2 probability plus 1 by 2, sorry 1 by 4 probability log 2 probability plus probability log 2 probability and so on. This would keep on going. I need to add a page. So this is h of x, let's call it s. So minus s is coming out to be, minus sign I am taking this side, or I don't need to take it actually, because minus sign would be eaten up, no? So let's call it s only. So s is coming out to be, this is 2 to the power minus 1, minus sign goes there, so this become 1 by 2. This would also become 2 by 4. This would become 3 by 8, right? 2 to the power 3 is there, no? So this would become 3 would go outside, 3 by 8, and negative sign would cancel out. So what you are getting here, 1 plus 2 by 4 plus 3 by 8, and next would be 1 by 16, right? Next probability will be 1 by 16. So that would become 4 by 16. So next term would be 4 by 16 and so on. And here what was the scenario? It was 1 by 2, not 2 by 4. It was 1 by 2. What I can do now? I can multiply. Now I need to solve this particular thing. This is mathematics now. So what I did was, I multiplied this s with 1 by 2. So what I am getting? If I multiply this 1 by 2, what you will get? 1 by 4. If you multiply this one with 1 by 2, what you will get? 2 by 8. If you multiply this with 1 by 2, what you get? 3 by 16 and so on. Now simply subtract both of the equations. S by 2 is coming out to be 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16. So s by 2 is coming out to be 1 by 2 plus 1 by 4, that is equals to 1 only. Okay, 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16. This much part was 1 and this part is 1. 1 plus 1 equals to 2. A upon 1 minus r, you can simply apply a upon 1 minus r. What you are getting? Sorry, r is 1 by 2. So what you are getting? 1 only. Okay, or you can simply remember it as well. So what is the value of s, which was our entropy? That came out to be 2 bits per symbol. Okay, that's it. This is the answer. Let's go to the next one. What did you do here? So two networks in between, say there is some resistance. Always put I2 equals to 0. If you do this thing, that means your concepts are not clear. Okay, always go by the current. what I would say is that this can drive some current, this can also drive some current. If this 6 volt is driving some current, let's just say this is I current, then here also there will be I current, here also there will be I current, there is no doubt about it. Here also there will be I current. But now at this node, I current is also coming and I2 current is also coming. Now I cannot command that what will be the current here. But I can also say that this current is I and this current would also be I. So from this node to this particular node, till this point I can say the current would be I, right? But rest of the things I don't know. Here, let's just say this current is I1, I2 is already given, I3. So this current would also be I3. But at this node, two currents are there. I2 is also there and I3 is also coming from here. Then I will not comment here. But I can also say that this current is also I3. Say yes or no. Right? What about the potentials? I know that this potential is 0. This potential will be 4 for sure. I don't know the potential here. This potential is 0. I don't know the potential here. This potential is also surely 0. If this is 0, this will be surely 6. Now you notice one thing. Very good thing you can always, if this kind of question is coming, always see the current and potential. Whatever the comments you can make, those comments you make. And only the current that you will assume, those will be from the batteries. That's it. Now what comment I can see? This is 6, 2 ohm and 4 ohm. So 2 ohm and 4 ohm are in series. Right? Both are having the same current. No, this current is I, this current is also I. And they are divided into, this is your 6 potential and this potential is 0. This is 2 ohm and this current is 4 ohm. Sorry, this resistance is 4 ohm. So 6 volt between 6 ohm. That means this will drive here 1 ampere current. So what did you understand? That this current came out to be 1 ampere. What really happened here was that, sir, I can remove all these things now. One good thing I got to know that these currents are 1 ampere. This much current is 1 ampere. Well and good. Now here there is a ground. Here there is a ground. I know this potential. I don't know this potential. Let's just say this potential is V. What is my target? My target is to find out this I2. Right. So what I can do is that V divided by 1 ohm plus V divided by 2 ohm plus V minus 4 divided by 2 ohm. That would be equals to 0. I just applied the nodal analysis here. V minus 0, V minus 0 divided by 2, V minus 0 divided by 1, V minus 4 divided by 2. So what I am getting? V equals to 2 volt. Not 2 volt. 2 equals to 2. That means V equals to 1 volt I am getting. So this potential has come out to be 1 volt. If this potential is 1 volt, this potential is 0. What does that mean? How much current would be flowing here? 1 ampere current would be flowing here. So what did you understand now? That, sir, 1 ampere current was here and 1 ampere current is coming from here as well. This is your 1 ampere current. So how much total current will be flowing here? That would be 2 ampere. Now I know that, sir, I don't know the current going downward, but I know the current going here. Because if this current is 1 ampere, this current will also be 1 ampere, this current will also be 1 ampere. So this current will also be 1 ampere. So at this node, 2 ampere current is coming, but 1 ampere current is going out. What does that mean? This current would have been 1 ampere. There you go. So this ground is taking 1 ampere current. Now this ground and this ground both are same, no? Both are same. I could have asked you what is this current going inside. That will also be 1 ampere only. 1 ampere current is going into this ground. You can check as well. How will you check? What you can see here is that, sir, I have got the value of this V. Right? I have got the value of this V. Sir, this potential is 1 volt. This potential is 1 volt. This potential is 1 volt. This potential is 4 volt. So 4 minus 1, 3 by 2, that would be 1.5 ampere. So, sir, I know that, sir, this current is 1.5 ampere. Now here 1.5 ampere current is coming, but only 1 ampere current is going here. What does that mean? 0.5 would have been gone here. Say yes or no? 1.5, 1 is going here, 0.5 would have gone here. This would also be 0.5. Right? This would also be 0.5. And if this is 1.5 ampere, that means this current is also 1.5 ampere, this current is also 1.5 ampere, this current is also 1.5 ampere. So here the scenario is this current is 0.5 ampere and this current is 1.5 ampere. What does that mean? 0.5 coming here, 1.5 going here. That means from the ground, 1 ampere current would have come. So ground is taking 1 ampere current, it is providing that 1 ampere current as well. So is that analysis clear to you? In concept X as well, I have framed the question from here. In our test series as well, I have framed the question. In our class notes as well, there are questions. In the gate examination as well, from this concept question have been asked. When this question was asked, the answer was 0. Okay, so people, I have seen a lot of solutions, people have just made an assumption. What they do is that one network would be there, other network would be there, whatever the current battery gives, it would take back the same current, whatever the current battery would give, it would take back the same current, so here the current would be 0. This kind of concept people have made, but they don't even know that ground can also take into action, ground can also make some decisions, because if here there is a ground, then the ground can also take up some current. No, it is true that whatever the current battery would give, it would take back the same current. But is it necessary that in all those elements the current would be same? It is not necessary. Here the current was 1 ampere, but here the current is 2 ampere. In the whole network current is 1 ampere. No. 1 ampere, 1 ampere, 1 ampere, 1 ampere, 1 ampere, 1 ampere, then 2 ampere. Here, what is the scenario? 1.5, 1.5, 1.5, 1.5, 0.5, 0.5, 0.5, 0.5, then 1.5. Okay, so have some good knowledge and have some good concepts as well. Okay, let's go to the next one. Yeah, so consider the following circuit, sir. This was a very lengthy question, sir. Was it lengthy? Am I asking you some expression like find out the voltage expression at some time t? What is the value of voltage? No. That means I am expecting something intuitive from your side, right? So is it a LTI system? Yes. So what you could have thought, a lot of approaches are there. So first approach could have been that, sir, this is a LTI system. Now I know that, sir, if in place of RT, if UT was there, then it would have been easy for me. In place of ramp function, if you have applied step function, then it would have been very easy for me. So what you do, sir, if I know that, sir, if I apply UT, I know a particular output. So what will be the output if you apply RT? That would be simply the integration of this output. That would be, integration of this output, because you know that if you integrate this UT, then what you get? RT. So whatever the output that you are getting, you integrate that output will be here. So can you directly write down the output V naught T if input is step? What will be the initial value? At 0 plus. So initially capacitors are having 0 voltage, but the whole circuit is shorted. If the whole circuit is shorted, that means, sir, there will be an impulsive current. If there is an impulsive current, then what would happen? Voltage will be simply divided. So if I am saying I am applying UT, then here voltage would come, that would be 0.5. At the steady state, what would happen? Both capacitor would be open circuited, so whole voltage would come up. So what will be the expression? 1 minus 0.5 e to the power minus t by 2. This will be the expression. Surely there will be UT as well, right? Then you simply integrate it. Now you don't need to integrate, just think about it. If I integrate, surely there will be a ramp function, no? Surely there will be a ramp function. And surely there will be some transient response as well. Because if you are integrating e to the power minus t by tau UT, some component of transient would also come up, and here purely UT is also there. What does that mean? Some component of a ramp would also come up. So from here only you can think that, sir, ramp and transient both would be there. So what is the first option saying? Contains only transient? No. Purely ramp? No. That means it will have both transient component and ramp component, and it will never settle down to a steady state value. Why is that so? Because ramp will never settle down to a steady state value, no? Ramp will always keep on increasing. So it will never settle down to a constant steady state value. So this option is correct. At 15 second, ramp component will dominate. What is the time constant of this circuit? Sir, 2 RC. RC value is 1 second. What does that mean? Time constant is 2 seconds. After 5 tau time, that means after 10 seconds, who will die out? Transient component will die out. So at 10 seconds, after 10 seconds, transient component will die out. So who will remain? Only the ramp component will remain. So what I am saying is that at 15 seconds, ramp component of V0 will be dominating the transient component. Yes. Or how one could have thought that, sir, at t equals to 0, it will have 0 voltage. But sir, at t equals to infinity, capacitor ideally should be open circuited. Like, what is the meaning of steady state? Steady state means capacitor will not be changing the current. Capacitor will not be changing the voltage. If they are not changing the current, then surely voltage will also not change. Right? This is the meaning of steady state. Right? What does that mean? Voltage should not be changing. Sorry. What is the meaning of steady state? The meaning of steady state is the voltage should not be changing. That means current has to be 0. So you can consider it as open circuit. If I consider this as open circuit and this as open circuit, then what will be the circuit? The circuit would be somewhat like this. This is resistance R. This is also grounded. This will be V0. So circuit is saying that complete input is exposed to V0 T. That means at the steady state, V0 T roughly you can write down as RT. At steady state. At steady state, your V0 T is roughly equals to RT only. That means as a steady state, only this component will be dominating, right? That means this option will be surely correct. That you would see that time constant is 10 seconds. That means this option will be surely correct. Now you know that I am applying a ramp. The input will be gradually increasing. That means capacitor will be gradually increasing its voltage. So surely some transient would come up, no? That's pretty obvious. It's not that, sir, just as I apply the input, directly the ramp signal will come up. At the steady state, it will be RT. So surely there has to be some transient that is dying out. So then this option would also be correct. That it will have both transient and ramp, and at the steady state, transient would die out and ramp would remain. Okay, so you don't need to apply Laplace transform and all these kind of things. I am not asking the V naught expression. I was just testing that how much do you know about transient. Okay, so that's it. Let's go to the next one.
For the control system with open loop transfer function as this, the root locus forms a circular pattern. What are the center and radius of the circle? So they're telling me that it forms a circular pattern. Let me verify whether it actually forms a circular pattern or not by plotting the root locus. So root locus of OLT is given, right? So if I mark the zeros and poles, so I have a pole at s equal to 0, I have a pole at s equal to -2, correct? And I have a 0 at s equals to -5. So how many poles I have? 2. How many zeros I have? 1. So what will be the number of branches? It will be the higher of the two, that is number of poles, that is 2. How many asymptotes I will have? That it is poles minus 0, that is 1. I will have one asymptote. What will be the value of the asymptote? That will be 180 by pole minus 0, that is 1 into 2n minus 1, because I will have only one asymptote. So here n will be 0. So this will be 180 degrees. So I will have asymptote at 180 degrees, that is exactly here. So basically I will have a virtual 0 at 180 degrees. So how will the root locus form? So basically we start where I have even number of poles or zeros. So in this whole region, I always have even number of poles and zeros on the right hand side. So I will have the root locus here, and there will be a break away point, and then again I have even odd number of, so not even, sorry, odd number of poles or zeros. So here I have odd number of poles or zeros. So again here I will have a break, sorry, this was a break away point, this will be a break in point. Sorry about that, this will be a break in point. Okay, so this will be my root locus, and of course, yes, it forms a circular pattern. So there is a shortcut, to remember this, that always the rightmost zero will be the center of the circle. What is the rightmost zero? -5. So -5 will be the center. Only one option has -5 as the center, so that will be my answer. But let us verify. How can I verify? We can verify by calculating the breakaway and breaking points. So if I say that -5 is my center, so the distance from this -5 to the break-in point and the distance from -5 to the breakaway point would be exactly same if -5 is my center. Although in the picture you're thinking, sir, this distance is higher than this one, but this picture is not according to scale. Okay, so we'll find out this distance A and we'll find out this distance B, and we'll see that both of them are coming exactly same. So hence -5 has to be the center. Okay, so how do I calculate the break away and break in point? For that I will write the characteristics equation. So 1 plus g of s into h of s equal to 0. So from this I can actually say what is my characteristics equation. So g of s, h of s is this value, right? So basically your k value will come out to be minus of s into s plus 2 upon s plus 5, right? Now for calculating breakaway and breaking point, what I will do, I'll just simply differentiate this with respect to s, and I will equate this equal to 0. That will be my breakaway and breaking point. So if I differentiate this particular thing with respect to s, right? So I can ignore the negative sign because anyways I'm equating with 0, so negative sign is just a constant that will go away, right? So I can just focus on the s square plus 2s term. Okay, so the differentiation would be, this will be 2s plus 2 into s plus 5 minus, this will be s square plus 2s into 1 basically upon this s plus 5 whole square which will, anyways, negative sign is there, this negative sign, and this also, oh no, this is correct. So automatically this will be equated to 0. So from this, if I solve this equation, right, this will be 2s square plus 10s plus 2s, that is 12s plus 10 minus s square minus 2s, okay, equal to 0. So it is s square plus 10s plus 10 equal to 0, right? So from this I can find out the break in and breakaway points, right? So here s will be minus 10 plus minus b square minus 4ac upon 2a. So this will be basically minus 5 plus minus under root of 15. Now if I check the points, what is under root of 15? So under root of 15 would be 3.8 something, right? So s will be equals to there will be 2 points. This will be minus 5. So one will be minus 1.127 and the other point would be hold on a second, this minus 5, yeah, minus 8.87. So the interesting fact is minus 8.87 will be lying somewhere here and minus 1.127 will be lying somewhere here. So these are all valid points. So one point will be my breakaway point, other point will be my break in point. Okay, so I got my breakaway and breaking point. Now one interesting fact I saw that the plus is the break-in point, plus is the break-in point, sorry, breakaway point, and minus is the breakaway point. So I see from minus 5, right? From minus 5, if I add plus under root 15, I reach my breakaway point. So this distance is basically under root 15. Similarly, from minus 5, if I subtract under root 15, I will reach my breakaway point. So this distance is also under root 15. So hence proved A equals to P. So the distances are same. Of course, minus 5 will be my center. You can observe from here as well, minus 5 is center, right? From minus 5, it is equidistance, plus under root 15, minus under root 15. Okay. And what is the radius? Radius would be this distance B, that is under root 15. So that's why option A will be your correct answer for this question. For the given linear time invariant system, determine which of the following statements are correct. Okay, the system is observable, controllable. So they're asking about controllability and observability. So I remember that for controllability, we used to make this matrix. So it's a 2 cross 2 matrix. So I will have A is the column, A is the, this will be AB. I will have first B, then I will have AB, right? That will be the controllability matrix for a 2 cross 2 system. Okay. If the determinant is not equal to 0, then we say that it is controllable. Otherwise, we say it is not controllable. Basically, it has to be a full rank matrix, right? Similarly, now for observability, how can I check for observability, right? So for observability, what we can do is, hold on a second, this is P, yes. For observability, we will do this. This will be QO, and we will form a matrix with C transpose, then C transpose, sorry, this will I think be, yeah, C transpose into A transpose. Okay, 2 cross 2, so not C transpose into A transpose, sorry, A transpose into C transpose. Correct? Yeah, that is correct. Okay, so yes, hold on, sorry, small mistake. Yeah, this is correct. Yeah, so we will make this matrix. So we will again check the determinant of this matrix. If this is non-zero, then we will say our system is observable. Okay, or we say if this matrix is full rank matrix, then we say system is completely observable. So let me find out the let me calculate the QC matrix. So it will be B would be 0 1 into A into B. A into B would be basically A into B would be, this is minus 1 0 0 2 into B, 0 1. So 0 0, this will be 0, this will be 0, this will be 2. So we say that the determinant is 0, right? Determinant is 0, QC is 0, so it is not controllable, it is not completely controllable. So option B is correct, it is not controllable. Let me check for observability. So observability, I will do C transpose. C transpose is this, right? So this is my A, B, C basically. C transpose would be 1 2. Okay, then A transpose into C transpose. So A transpose is -1 0 0 2 into C transpose. C transpose would be 1 2. Okay, so this will be -1 into 1, that is yeah, -1 into 1, that is 1. This is 0 0 4. Okay, so just hold on a second. So if I check the determinant of this, right, that is 4 plus 2, that is 6. So this determinant is definitely non-zero. 4, hold on a second, yeah, 4 plus 2, yeah, that is 6. This determinant is definitely non-zero, so my system will be completely observable. Correct, my system will be completely observable. So option C is correct, option B is correct. So B, C will be your answer for the question.
Yeah, so let's see the solution of this one. This is a good question. So I will tell the solution, but a lot of guys would have solved it and someone would have said that, sir, this would be the answer. 2 e to the power -1 and sine 1 radian. Did you pick this as your answer? Or someone would have said that, sir, maxima would occur at, where the maximum would occur? Maximum would occur at t equals to pi by 2. Because a sinusoid will give the maximum value at pi by 2, so maximum would occur at t equals to pi by 2. If you have done these two things, both are wrong. Okay? Where it is wrong, everything I tell you, let's get started with the solution of this particular problem now. So, input voltage is given, you need to determine the output voltage at t equals to 1 second. So, what will happen? Sir, first I need to draw the waveform of V in t. This is my first task, that waveform of V in t I need to draw. So, do you know how to draw the waveform of xt dot any sinusoid? Xt dot any sinusoid. It could be sinusoid, it could be cosinusoid as well. So, do you know how to draw the waveform of xt dot sin t? So, first what you need to do? You need to draw the waveform of xt. Let's just say this is your xt. Then what you need to do? This could be your xt as well. It could be in the negative hand side as well. Then what you need to do? Take its mirror image. Take its mirror image. So how would you do? How would you take the mirror image? This is how you would take the mirror image. Take its mirror image. Now in between you draw the sinusoid. So it's starting from 0. So this will be the waveform. Like this is just the envelope. This is not the actual. Like this is not the actual waveform. Actual waveform is this. Whatever the sinusoid that I have drawn, that is the actual waveform. So this is the actual waveform. So this is how the graph is going. So similarly, we need to draw the waveform of 2 e to the power minus t ut. This waveform we need to draw. So do you know how would the graph of e to the power minus t would look like? E to the power minus t ut. Basically, I can write down this particular waveform as 2 e to the power minus t ut dot sin t. So now you need to draw the graph of this one. So that will be your envelope. So at t equals to 0, it would throw the value 2, and at t equals to infinity, it will throw the value 0. So this is how the graph would go. Similarly, I need to take its mirror image. So this is how I will take the mirror image, right? And in between sinusoid would come. In between sinusoid would come. Okay, so you have understood the nature of the graph. I just need to erase this now. Just erase this one as well and erase this one as well. So this is how the graph would go. Now if this input, this is your V in T input, this input is applied here. So what will happen? How will the output go? Sir, initially capacitor is having 0 voltage, input is greater than 0. So what will happen is that, sir, diode will turn on. Just as the diode turns on, then this whatever the voltage is there, that will be exposed to the output V0. So output will follow the input V in. So it will keep on following until it reaches the maximum value. Now just as it has reached the maximum value, let's just say this maximum value is alpha. So capacitor has charged till alpha voltage. Now what will happen? The input will go below alpha. Input will go below alpha. Then what will happen? Diode will turn off. Now this diode will turn on only when input is going above alpha. Input is going above alpha? No. Input is never going above alpha. What does that mean? Diode will always be turned off. If diode is always turned off, then your capacitor will always hold this value. So your answer would be this particular thing. Now our task would be that, sir, when this maximum value would occur, it might happen that this maximum value is occurring before t equals to 1 second. Like let's just say if this time is 0.5 second, if this particular time is 0.5 second, then at t equals to 1 second, what will be the answer? This will be the answer. Now it might happen that, sir, this time is 1.5 second, then what will be the answer? Then this will be the answer at 1 second, which will be before. So now we need to check when this maxima is occurring and what is the maximum value of this maxima. What is our task? When this maxima is occurring, at what time this maxima is occurring, and what is the maximum value you are having. That is our task. So a lot of people, what they would have done is that, sir, we are multiplying this graph with sinusoid. So sir, this 2 to the power minus t graph goes something like this, and sinusoid graph goes something like this. So sir, sinusoid maxima would occur at this particular point. This maxima will be multiplied with the particular value, and we will get the maximum value. So this is the pi by 2 value. Sinusoid is maximum. That's fine. At pi by 2, sinusoid is maximum. But e to the power minus t is also decreasing. No, this particular graph is also decreasing. Are you able to understand this point? This graph is maximum at pi by 2, but this graph is also decreasing. No, at 0 it was having more value. At t equals to 0, this was having the highest value, but this particular graph was having the lowest value. So highest multiply with lowest, it turned out to be 0. There would be one point where this is also having good enough value, this is also having good enough value, that would throw the maximum value. So here you have to differentiate, you have to apply mathematics. Then you will get to know that what will be the value where maxima is occurring. Is that understandable to you? We have to apply mathematics here. So for finding out the maximum value, what we need to do? Sir, I need to assume a function ft, which is 2 e to the power minus t sin t ut. I need to find out its maxima. That I need to find out. So for that I will have to differentiate it. So I will assume this as my first function, this as my second function. So first as it is, differentiation of second, plus second as it is, differentiation of first. Differentiation of first. This is your first function. What will be the differentiation of this? So this is also u into v again. So here also first as it is, differentiation of second, plus second as it is, differentiation of first one. So differentiation of 2 e to the power minus t would be 2 e to the power minus t minus sine, and sine t as it is. I hope you have understood this particular thing. So this is the differentiation we are getting. This t equals to 0 will be put here, so this will be gone. So f dash t is coming out to be, ut is already there, 2 e to the power minus t you can take common, cos t minus sine t, and ut is already there, and that should be equivalent to 0. So at what point they will be 0? E to the power minus t. What this ut is saying that, sir, value of t should be greater than 0. This is what it is saying. So there is no meaning of this ut. It is just saying that value of t is greater than 0. 2 e to the power minus t. When it can be 0? 2 e to the power minus t. It can be 0 at t equals to infinity. Right? It can be 0 at t equals to infinity. But at t equals to infinity, like you would know, you wouldn't know that what value this sinusoid would throw. So we can drop this point. T equals to infinity is not a finite point, so we will not talk about it. Or basically, you know that at t equals to infinity, the value will be minimum. Basically, when you differentiate a function and then you put it equals to 0, then either you get maxima or you get minima, right? When you differentiate a particular function and you put it that equals to 0, then either you can get maxima or you can get minima. So when I am putting this equals to 0, when my 2 e to the power minus t is equals to 0, so value of t is coming out to be infinity, which is the point of minima actually. Minima means you are having minimum value. You know that at infinity this graph will decay down to 0, right? But you need to find out the point of maxima. So let's put this equals to 0. So cos t minus sin t equals to 0. What you are getting? Tan t equals to 1, right? Cos t goes here, sin t divided by cos t, tan t equals to 1. That means t has to be equals to pi by 4. Now if I put t equals to pi by 4 in this particular graph, so what I will be getting? Sin pi by 4. That will be under root 2 e to the power minus pi by 4, because sin pi by 4 is 1 by under root 2, so under root 2 e to the power minus pi by 4, which is surely a positive value, and it is surely the maximum value, maxima. And what is this time? Pi by 4. What is the value of pi by 4? Pi by 4 is surely less than 1. It is surely less than 1, because pi by 2 is 1.57. 1.57 divided by 2 Yeah, just 1 second, guys. Yeah. So what is the value of pi by 4? Pi by 4 is somewhat 0.78 second, right? So they are asking at 1 second, like this is your 0.78 second, but they are asking at 1 second. At 1 second, that means the peak value they are asking, right? Let's just say they would have asked at 0.5 second, then what you would have done? You would have simply put 0.5 second here. 2 to the power minus 0.5 sine 0.5. That would be your answer. But they are asking at 1 second, that means they are asking somewhere here. So what will be the value? Value will be alpha. Now what is the maximum value you are getting? This is the maximum value you are getting. That is under root 2 e to the power minus pi by 4. So if you calculate the value of pi by 4, then put e to the power and then put under root 2. So the answer you are getting is 0.6447. That means here 0.644, that is the answer. Okay, so this was a good question. You need to think here. Let's move to the next. Yeah, so did you find out this particular question lengthy? If you found it out lengthy, then you are missing out on something. Let me tell you one way. Look, this is A XOR B written, right? Do you know about A XOR B as well? Now, if I want to convert this dot into plus, then what I need to do? Basically, I want to convert this dot into plus. So what I need to do is that I will take out one bar outside. This dot will be converted into plus if you take out one bar outside. Okay. Similarly, this you would have seen. This relation you might have already seen, right? That both are equal. If you convert this dot into plus, what you would do? One dot has been converted into plus. That means bar outside I can take. Another dot you want to convert into plus. Another dot you want to convert into plus. That means another bar you will take outside. And bar will cancel out each other. What you are getting? A XOR B XOR C. Basically, if you want to convert one dot into plus, what you have to do? You have to take out bar on the whole function. Similarly, if this particular thing is written A XOR B, A XOR B XOR C XOR D XOR E XOR F. This is the scenario. So there are 3 dot. 1, 2, 3. If I take 3 dot outside, that means 3 bar would come. 2 bar will cancel out each other. So only 1 bar will be left. So if you want to convert this dot into plus, this dot into plus, this dot into plus. So if you want this particular scenario, that all the 3 dots have been converted into plus, that means 3 bar would come outward. 2 bar will cancel out each other. So one of the bar will be left. Now you know this property of XOR gate, that X XOR Y is there, then you can take bar on any of them. Like if this bar is connected, then what you can do? You can take bar on one of the signal or one of the what should you call it? One of the variable. You can take bar on one of the variable and other bar could be as it is. So I hope you know all these properties. A lot of people don't know this particular property, so I have explained it. That dot goes outside, you need to make it plus, then you can take bar on the whole function. Similar thing you can do with this plus as well. Like from the plus, if I need to take dot, from plus to dot I need to go. So what I would do? I would take bar again, like whatever that I explained, that is true in the opposite direction as well. What I mean to say is that, let's just say this particular thing is written. Now I need to convert this plus into dot. What I would do? This as it is, this as it is. I need to convert this plus into dot. So bar outside. Is that understandable to you? So now looking at all these scenarios, this is the scenario here. Here how many dots are there? 1 and 2. So if I take 2 dot outside, what will happen? 2 bar would come outside. 2 bar will cancel out each other. So what this is written as? A XOR B XOR C XOR D. So F is nothing but A XOR B XOR C XOR D. Is that understandable to you? Now there is a specific pattern of minterms and maxterms. If you don't remember it, then also it is fine. But there is surely a specific pattern for minterms and maxterm for ABCD, for XOR gate. In case of XOR gate, there is a specific pattern. Which pattern is there? Let's just say I talk about A XOR B. So can you draw the K-map? Yes, sir. This is how the K-map would look like. Sir, A XOR B is nothing but A bar B plus A B bar. So this would be A bar A B bar B. A bar B A B bar. This is the pattern you are getting. Now A XOR B XOR C I need to do. So what I can do, this is our A, this can be written as first one as it is, bar of the second one, bar of the first one, second one as it is. So A bar B plus A B bar, like in the theory itself we remember it, okay, but if you don't remember it then also it is fine. I am just proving it here for you. A bar B C bar plus A B bar C bar plus A bar B bar C plus ABC, right? So this is how we can open it up. So now what we need to do is that A bar A, B bar C bar, B bar C, B C, B C bar. Now A bar B C bar, A bar B C bar, A B bar C bar, A B bar C bar, A bar B bar C, A bar B bar C, and ABC and ABC. Do you see some specific pattern here? First one empty, then second one, then this one empty, then this one. Empty, one, empty, one, empty, one, empty, one. So similarly, can you make it for 4 variables? Let's make it for 4 variables. There you go. So ABCD would be there. Starting with the empty, then 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. So that's the specific pattern. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, sorry, 8, 9, 8, 9, 10, 11, 12, 13, 14, 15. So what you see, 1, 2, 4, 7, 1, 2, 4, 7, 8, 11, 13, 14, 8, 11, 13, 14, first one, there you go. And then just whatever the min terms are not present here, those will be the max terms. So 1 is not there, 0, 2 is there, then 3 is not there, then 5, 6 are not there, then 9, 10 are not there, then 12 is not there, and 15 are not there. So these two options are correct. Okay, so it was not lengthy, you just need to know the concept. If you knew this concept, then directly you would have done it. Then you would have just checked that for A XOR B, what is the scenario? For A XOR B XOR C, what is the scenario? Then what will be the scenario for this one? Ideally, student remember it, that for A XOR B, starting with nothing, then 1, 0, alternative, it would keep on coming. Starting with nothing, alternative, it would keep on coming. So starting with nothing, alternatively, it would keep on coming. So you don't need to remember the min terms, but you remember the pattern. Understandable? Well and good. Let's move to the next one. Again, very standard kind of question, but I have seen that a lot of people are confused in this kind of pattern. I don't know why they are confused. Let me give you the complete concept here. Okay. So what kind of counter it is? Up counter. This much you know, right? So it is nothing but up counter. People are always confused. Like someone would say that the mode value is x. Someone would say mode value is x, and someone would say that the mode value is x plus 1. They are always confused. So let me clear this particular confusion for you now. So what kind of counter it is? Up counter, right? Starting from 0, 0, 0, 0. So it will count up now. So it is counting up. Now when this clear input would be active. So sir, this is active low, active high, all these things you don't need to think. You can see bubble here. You can see bubble here as well. So both bubble will cancel out each other. So what does that mean? When the output of AND gate, when the output of AND gate is 1, not NAND gate, AND gate. Output of AND gate is 1, then your job would be done, then clear input will be active. Are you able to understand this point, what I am saying? Sir, there is NAND gate, but there is bubble here as well, there is bubble here as well. Both bubble can cancel out each other, no? Bubble means 2 inverter gate. 2 inverter gate means simple wire, right? So always like cancel out the bubbles. It's not that, sir, I will think, okay, it is active low, so output should be 0, then it will be active. Nothing like that. Output of AND gate should be 1. Now what is the input of this AND gate? That is Q3 and Q2. Q3, Q2 is the input. And what will be the LSB? This will be the LSB, right? This will be LSB. So input is Q3, Q2. That's the input. Then Q1, Q0 is there. So when both are 1, then it will be like, then clear input would come into action. But this is having a minute delay, no? In the examination, it might happen that, sir, they are not mentioning this particular delay. But by default, always you need to take that whatever the combination circuit is connected, that will have a very minute delay. Very minute delay. So now what will happen is that, sir, first 0, 0, 0 would come. Then, sir, 1 clock pulse would come. Then 0, 0, 0, 0, 1 would come. Then, sir, 0, 0, 1, 0. With the clock pulse, all these things will start happening, right? 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1. 1 0 0 1 0 0 1 1 0 1 0 then 1 0 1 1 then 1 1 0 0, and after that nothing would come, because just as 1 1 0 0 would come, then your clear input will come into action. But this is a synchronous clear input. Now what will happen? Sir, this clock came, this output came, then this clock came, this output came, it kept on coming. Now this clock came, then this output came. Now this output was fed to this particular NAND gate, clear was not active. Now just as this came, just as another clock pulse came, then this output came into action. Now 1 1 0 0 was fed to this particular NAND gate. So here there was 1 and here there was 1. Now this 1 1 was going into this particular NAND gate, output was 0, clear came into action. But it would take TD time, like just as the clock came, after TD time of this clock, this clear will get the input that now you need to clear everything. So how much time was there? At this particular time, clear was active. Now clear will say that I will again go here, right? Clear will reset everything. But after the clock edge, it got the message. Are you able to understand this point? After TD time, it got the message. Now the scenario is, this is synchronous clear input. What is the meaning of synchronous clear input? That it works only on the clock edge only. Like let's just say here the clock edge has occurred, and at this particular time I am calling the clear and I am saying that reset everything. What clear will say? I will not work. Clear will say that I will work only on the next clock edge. At any time window, here, 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 if you ask the clear to reset everything, clear will say that no, I will not reset everything. I need the clock edge. You have given me the signal, let the signal be there till the next clock edge. At next clock edge, I will take the decision and I will clear everything. So this 1 1 0 that came into action, and the message was that clear just reset everything. So clear said that I will reset everything, but at the next clock edge. That means this will also come into action, this will also come into action, this will also come into action, this, everything will come into action. All these things will come into action. And this will also come into action. And then again we will start from 0. Is that understandable to you or not? But if it was asynchronous, if this clear input was asynchronous, then what would have happened? What is the meaning of asynchronous clear input? Asynchronous clear input will say that, sir, I don't care about the clock edge. At whatever the time you say that clear it, I will clear it. I don't need clock edge. I don't even look at the clock. So this clear will say that, sir, at whatever the time you give me. Sir, if you say that here you clear it everything, I will clear it. Here you say clear everything, I will clear it. So there will be always a minute delay. Just after some time, the message is there that clear everything. So just as this came, in very minute time, in nanosecond of time, this became 0 0 0 0 0 0. So although it also comes into action, in your counter, in your clock, you would see that, sir, 0 1 3 0 1 2 3 4 5 6 7 8 9 10 11 12 will also be there, but 12 will be there only for a minute time. Let's just say this was there for 1 second, this was there for 1 second, all these were there for 1 second, but this will be there only for 1 nanosecond, which you will not be able to identify. So 1 2 3 4 all these come, 12 will also come, but just as 12 comes, it will be converted into 0. So in case of asynchronous, your 1 1 0 will not be counted, but in case of synchronous, this will be counted. So usually a lot of people just mug it up that in synchronous you need to mode value +1, and in asynchronous you do not need to increase it. So what they do is that they would see from here 1 1 0 0 is coming, that means they will cancel it out. Then they would see that, oh, okay, it is synchronous, that means we need to increase one mode value. But why do we do so? You can remember the method, but why do we do so? Is that clear to you? That clear input is synchronous, that means it will work at the next clock edge. He will wait for the next clock edge, that means this will be there for enough time, this will be there for 1 second. But if it is asynchronous, then immediately it will clear it. So it will be there for 1 nanosecond only, which will not be counted. Are you able to understand this point? So what is the mode of this particular counter? This is 12, so mode will be 13. Mode 1, mode 2, mode 3, mode 4, mode 5. In that manner, this will be mode 13 counter. So it is your mode 13 counter. Is that understandable to you? So this is the first question that can be asked. What is the mode of the counter? Yeah, sorry for the interruption, guys. Actually, I recorded this part, but some sound came into action. But yeah, the job is like this is our mode 13 counter we have got. Now what they are asking, what is the output at 43rd clock pulse? Although I recorded this part, but I have to record it again. So mode 13 you already know. 43rd clock pulse. So what you will do? 43 divided by 13, right? What is the remainder you will be getting? That would be 4. So whatever the output you are getting after fourth clock pulse, that would be the same output after 43rd clock pulse. So after first clock pulse, this was the output, second, third and fourth. So after fourth clock pulse, what is the output I am getting? 0, 1, 0, 0. So this will be the answer. 0, 1, 0, 0. Very straightforward, very simple question it was. Okay, it's just that people are confused in synchronous and asynchronous clear input. That's why I framed this particular scenario. Okay, now I hope you are completely comfortable with this asynchronous and synchronous clear input part. Okay, then yeah, let's go to the next one. Yeah, so let's see the solution of this one. This is lengthy. Okay, like I myself is saying that for the first question, I myself is saying that this is actually lengthy. And in the gate examination, if you see in the previous year, whatever the questions that are coming in quantization, those are lengthy only. Now, if someone is a good student who have studied quantization in a good manner, he would see that yes, sir, these questions are based on PYQs only. I would be able to solve it. Then he would go on solving this particular question, and it would take a lot of time. And it might happen that he has done some blunder, some minor mistake he might have done. So there he might mess it up. So whenever you see that, sir, I saw this particular question, I know that it would take a lot of time. So you need to drop it. I know your ego will not allow it. That, sir, I know the solution, I would solve it. I know ego would say that solve it, but you need to drop it. For once you say to yourself that I will again come back to it, it will take some time, I will drop it and proceed to the next one. Is that understandable to you? Okay. So these kind of questions should be solved in the last, where you already know that it would take a lot of time. Okay then, yeah. So, sir, here these values are not given. Is it incomplete? No, you need to find out those values on your own. So let's just say this value is A, this value is B, this value is A, this value is B. So I have already drawn it. This value is A, this value is B. One thing I know that this PDF is valid PDF. So the whole integration will throw the value to be 1. So what do I know? 18A plus 2B. Twice of 18A plus 2B would be equals to 1. So 18A plus 2B would be 0.5. This is the first equation. What else do we know? That here there are 8 levels. 8 level means 8 symbols it will generate, and midpoint quantization is there. So and decision boundaries are also given, which are -2, 0 and 2. So 3 decision boundaries are given, -2, 0 and +2, and it is midpoint quantizer. Is it written? Somewhere it would be written. Yeah, midpoint is chosen as a reconstruction level. So these are the symbols it will generate. It will generate the symbol to be -1. It will generate the symbol to be +1. So 6 more symbols it will generate. 2 symbols we have already understood. 6 more symbols it will generate. That means 6 more levels will be there. These are 2 levels. This is 1 level. This is another level. Another thing is given that entropy is maximum. If entropy is maximum, what does that mean? That these symbols will be equiprobable. So whatever the probability that you are getting here, the same probability you will get here as well. Along with that, whatever the level that you are going to choose, they will also give you the same probability. This is what it is saying. Is that understandable to you? So now this window is 18. This window is having a length of 18. And this window is also having a length of 18. 2 levels are already chosen. Total levels are 8. 2 are already chosen. How much are left? 3. So, sorry, how much are left? 6 are left. So 3 will be here. 3 levels will be here. And 3 levels will be here. And all the levels will be equiprobable. So you need to break this part between 2 to 20. You need to break this part in a manner that all the levels are equiprobable. Can you do it? Yes, sir. 18 should be broken into 3 parts. That means the length should be 6. So 2 plus 6, 8. 8 plus 6, 14. 14 plus 6, 20. Similar thing would happen here as well. So these are your decision boundaries. This is the first question that could be asked, that tell rest of the decision boundaries. You have told -2, 0, 2, 8, 14 and 20. -2, -8, -14, -20. These are your decision boundaries. Instead of asking decision boundaries, they can ask you what will be your symbol generated by the quantizer. So symbol generated would be midpoint. What will be the midpoint of 2 and 8? What that would be? 6 divided by root 5, right? Midpoint will be 5. It will be 11. And here it will be 17. So similar thing would happen in the negative hand side as well. These will be your midpoint. And all are equiprobable. Like what is the probability it will throw? It will throw the probability to be 6 into A. What probability it will throw? It will also throw the probability to be 6 into A. What it will throw? It will also throw the probability to be 6 into A. Now this 6 into A should be equal to this probability as well. This will throw the probability to be 2 into B. Is that understandable to you? Because all are equiprobable, no? So from here what you are getting to know? That 3A equals to B. So here you put 6A. All these questions should be solved with good amount of patience. Okay, again and again I say that if the question is coming lengthy on communication system, have some patience. Otherwise you will do some blunder. So have some patience and solve these kind of problems. 18A plus 2B. So in place of B here I will put 3A. So this will become 24A. 3A I will put 6A, 24A. So yeah, 24A is coming out to be 1 by 2. So what will be your A? A will be 1 by 48. Okay, so this is the value of A we are getting. Now what is the value of B? If this is 1 by 48, then the value of B is 3 by 48. So that would be 1 by 16. Right? 1 by 48, that is, no. They are talking about probability. They are not talking about value of A and B. So value of A is coming out to be 1 by 48, value of B is coming out to be 1 by 16. Now what they are saying, probability says that input is lying between 0 to 0.5 volt. What that would be? Input is lying from 0 to 0.5 volt. 0 to 0.5 volt. That probability will be 0.5 into B. Now what is the value of B? 1 by 16. So that probability will be 1 by 32. Yes, this is correct. Probability that it is lying between 2 and 4. Between 2 to 4. 2 to 4. What will be that probability? That probability 4 will be somewhere here. Between 2 to 4. So that probability will be 2A. 2 into A. Value of A is 48. 1 by 48. So that probability will be 1 by 24. So answer will be 1 by 24. This is wrong. Now you need to find out signal to quantization noise ratio. Okay. Both are actually time taking. What will be the signal power? First you need to find out signal power. So signal power will be nothing but minus infinity to infinity x square fx of x dot dx. Now you know that, sir, this and this both are even, so total signal is even. So how I can break it down? Between 0 to 20, twice of between 0 to 20. Say yes or no? Because whatever that is happening between 0 to 20, the same is happening from 0 to minus 20 as well, right? X square fx of x dot dx. Okay. Now how will you break it down? So graph is changing from 0 to 2, same graph is there. 2 to 20, same graph is there. So between 0 to 2, it is throwing the value of B. Between 0 to 2, it is throwing the value of B, which is 1 by 16. So between 0 to 2, it is throwing the value of B, which is 1 by 16. And between 2 to 20, it is throwing the value of A, which is 1 by 48. Right? So what you are getting? 1 by 16. Just solve it, no? Just solve it. I will pause the video and then I will solve it. Or should I solve it here only? Let's solve it here only. X cube by 3. Put the limit from 0 to 2 plus 1 by 48. X cube by 3. 2 to 20. 1 by 16. 8 by 3. Okay, yeah, plus 1 by 48. 20 cube. 20 cube. 1 by 48 and 3 can also go outside, no? So 48 into 3 is what? 48 into 3 is what? 144. Although this calculation could have been done without using the calculator, but I don't want to use my brain as of now. So 20 cube minus 2 cube. Okay. So now we need to solve this particular calculation. So first I will try to solve this particular calculation now. 20 cube minus 2 cube. 20 cube I can calculate, minus 2 cube will be 8 divided by 144 plus this is 1 by 6, right, and then everything multiply with 2. So this is your signal power is coming out to be 111.33 watt. Now quantization noise power. How will you calculate quantization noise power? What kind of PDF it is? Uniform. So I can apply the formula delta square by 12 multiply with the area, right? Delta square by 12 area, delta square by 12 area, A2 and so on. So what is the step size? Here the step size is 2. Here the step size is 2. Here the step size is 6. Here the step size is 6. And here the step size is 6. Is that understandable to you what I am saying? Step size 2, step size 6, step size 6, step size 6. Delta square by 12, delta square by 12, delta square by 12. I will apply the formula and multiply with the corresponding area. What is this area? This area is 2 into B. What is the value of B? 1 by 8. This area is also 1 by 8. How much is this area? 6 into A. 1 by A only. And it has to be similar as well. Why I am thinking so much? It has to be similar as well, no? 1 by 8, 1 by 8, 1 by 8. So all the areas will be 1 by 8, 1 by 8 only. It's just that the step size are different. Basically, this step size is different. So all the areas would add up to 1 only. But what about the step size? So step size of 2 will be multiplied twice. And step size of 6 will be multiplied 3 times here and 3 times here, 6 times. So what is the step size? Step size of 2 will be multiplied twice. And the step size of 6 will be multiplied 6 times. Is that understandable to you? Right? Okay. So this will be your quantization noise power. Now, how do we get this formula? All the derivation and everything I have explained in the class. This is just a way to solve it in a quicker manner. Otherwise, you would do x minus what is the quantized symbol, then you will put that symbol, then fx of x dot dx, then you will take the limit. In that manner, you can do. But for uniform PDF, we have built up a particular method. So that method I have explained here. So what it would become? 2 by 3 plus 6 by 2, 36 by 6 by 2, 18, yeah, 18 plus 2 by 3, 18.666, which was pretty obvious. I don't know why I did the calculation. Now what will be the SNR? 111.33 divided by 18.666. 5.96. Signal to noise ratio is coming out to be 5.96. Now in which of the option you are getting 5.96? 334 by 7. 47.7. There is some calculation error. I need to check that. Yeah, so there was the calculation error. Like these areas are same, but they will come out to be common. No, how I am adding up those areas? Basically, after all of this, area would come out to be common. A1, A2, all these will come out to be common. What that area would be 1 by 8. So everything will be multiplied with 1 by 8 as well. Is that understandable to you? So this answer would be 18.666 divided by 8. So 2. So that was a big blunder. I simply added them area. These area A1, A2, A2, all these are same 1 by 8. So they will come out to be common. 1 by 8 will come outside. It will not be 1. They will not be added. They will come out to be common. So this will be 1 by 8 here. So 2.333. So here you will be getting 2.333. $47.41. Okay, so when you solve this one, you are getting 47.41 only. Okay, this is nothing but 47.71. So 1 and 3 are the correct option. But this was a lengthy problem. I must say this was lengthy. Okay, let's go to the next one. Yeah, that's a very simple concept coming from most cap. Okay, so in the figure A, what is the direction of electric field? This is the direction of electric field. Right? In the figure A, what is the direction of electric field? This is the direction of electric field. What does that mean? This side would have been positive, this side would have been negative. That means semiconductor is positive and metal is negative. What does that mean? That means semiconductor is giving the electrons. Semiconductor is giving the electrons. Semiconductor giving electrons and this is taking electrons. This is your, this guy is taking electrons. What does that mean? That means Fermi level of semiconductor will be above than the Fermi level of, this will be the Fermi level of semiconductor and this will be the Fermi level of metal. If it is above, that means it is having, I should not write down silicon, although it is n-type semiconductor, no, so I can simply write down EFN. Okay, what does that mean? That is, this is having more electrons, this is having lesser electrons, so it is giving the electrons. If it is giving the electrons, this side has become positive, this side has become negative. So this is the direction of electric field. So direction of electric field I know. In the direction, how do I know the direction of electric field? The slope of energy band, the slope of conduction band will be positive in the direction of electric field. So slope is positive in this direction. So direction of electric field will be this, right? So I hope you know all these concepts. You should know how to read the energy band diagram. I cannot teach the full concept of energy band diagram in this particular solution video, but you know how to read the energy band diagrams. See the slope, where the slope is positive, in this direction slope is negative, in this direction, in this particular direction slope is positive. So in that direction of, in the positive direction of the slope, the direction of electric field will be there. Electric field will always be in the positive direction of the slope of conduction band. So this will be the direction of electric field. Okay, so this side is positive, this side is negative. That means this guy is giving the electrons. Giving the electrons means Fermi level will be above. That means it will be near to the conduction band. And now we assume a vacuum Fermi energy level. So this will be our vacuum. Now what does that mean? If it is your vacuum, that means this will be your metal work function and this will be your semiconductor work function. Okay, which is phi s. So who is more? This is more. So phi m is greater than phi s. This is complete opposite. What is the direction of electric field? This is the direction of electric field. What does that mean? This will be positive, this will be negative. What does that mean? This guy is delivering the electrons. What does that mean? Fermi level will be above and here Fermi level will be below. This is your vacuum, right? This is your phi m, this is your phi s. He is having more electrons, so it is delivering the electrons. If it is delivering the electrons, this guy became plus, this guy became negative. So what does that mean? Phi s is more than phi m. So phi s is more than phi m. That's it. Let's go to the next one. Yeah, so again based on Fermi levels only, what I feel is that this time in your gate examination you would at least see 1 or 2 energy band diagrams made, and you need to know how to read the energy band diagrams. So do you know how to read the energy band diagrams? What is the band gap that has been given here? 1.12 electron volt. What does that mean? That means this much length will be 0.56. If this length is 0.56, so how much will be this particular length? This will be 0.56 electron volt. So 0.35, right? And what about this one? This would be 0.38 electron volt, right? Now you need to find out built-in potential. So what is built-in potential? This is your built-in potential. This is your built-in potential. This much length is built-in potential, right? Initially they were at the equal-heights because we were using the same semiconductor. So they were at the equal height. Now what is the built-in potential? So this much length is same as this length, right? This length is same as this length. So this is your built-in potential. Now what is the built-in potential? Can you find out this length? This is 0.35 electron volt, 0.85 electron volt. But this is in energy. If I need to write down built-in potential, I will write it down in volt. So 0.35 plus 0.38. What will be the answer? 0.73 volt. That's it. What I need to find out? Doping concentration. Like what is the doping on p side and n side? So which one is p side? Which one is n side? Fermi level near to the valence band, p side. Which one is n side? This is your n side. Fermi level near to the conduction band, right? Now you know one thing, that EFN minus EFI, what that would be equals to? दिस इज राजस्थान. बहुत सारी मक्खियां हैं यहाँ पे यार. माई रूम इज कंप्लीटली क्लीन स्टिल. KTLN NDY NI. EFN minus EFI, this formula you already know. So EFN minus EFI, 0.35 electron volt, 0.0259 electron volt, ln ND by NI. NI value is also given 1.5 into 10 to the power 10. So what is the answer you are getting? 0.35 divided by 0.0259 e to the power into 1.5. So this is coming out to be 1, 2, 3, 4, 5, 6, 1.1. 1.1 into 10 to the power 16 centimeter cube inverse. So this is the answer. And what about P side? For P side also you know that EFN, EFP, sorry, EFI, this is your EFI. EFI minus EFP. What that would be? KTLN NA by NI. So this is 0.38, 0.0259 ln NA by NI. So NI value is 1.5 into 10 power 10. So 0.38 divided by 0.0259 e to the power NI 1.5 you multiply. So 3.53, 1, 2, 3, 4, 5, 6. Yeah. So it is coming out to be 3.53 into 10 to the power 16 centimeter cube inverse. So this is wrong. Okay. So A and C are correct. Well and good. Again, it was very straightforward. You just need to know how to read this kind of a diagram. Let's go to the next one.
Find the particular integral of the differential equation. So what is my particular integral? So pi, right, is equals to basically, so first of all let me write this down properly. This will be x cube into d cube plus 3x square into d square plus x into d plus 1 into y. Okay, I can convert this. So this is nothing but the Cauchy format, right? So I have to do this substitution. What kind of substitution? I can do z equals to e raised to power x, right? This is the amount of sorry, I will not do this. X equal to e raised to power z. This is the substitution that I will do. So then your d into x will be converted into dz basically. This will be dx, right? And your x square into d square will be converted into dz into dz minus 1. So all this I have taught in my full course, so I'm not explaining here much. Okay, so this will be, so now I have to find out pi would be what? Pi would be basically equals to, so let me replace this x is equals to e raised to power z, right? So this will be e raised to power z, like pi would be this function q upon this function, right? That is my pi. So q is x is e raised to power z, so this will be e raised to power z upon, hold on a second, x would be e raised to power z upon d, like for x cube into d cube I will replace dz into dz minus 1 into dz minus 2, okay, plus 3 into dz into dz minus 1 plus dz x into dz plus 1. That's it. Okay, that is what, at least what my pi would be. Okay, so let me first of all so what I can do, so if I have e raised to power a upon f of d, right, so I can replace d with a, that will be my pi basically. This I have taught in the full course. So here I will replace my, so e raised to power ax, sorry, e raised to power ax, this will be, I will replace my x with, I will replace my d with a basically, correct? So here it is e raised to power z, that is e raised to power z into 1. So everywhere I can replace my d with 1, everywhere. Okay, so if I replace my d with 1, this will be 0, right? This will be 0, this will be 1 plus 1, that is 2. So answer will be x by 2. So your particular integral would be x by 2. Okay. So if you are having doubts, you have to revise the differential equation. So with my RP by Q series, you can revise how am I doing all this, right? I will not explain here because this is just the solution of the question. If A is 3 cross 3 matrix with determinant of A is this, then the value of the determinant, determinant of adjoint of adjoint of adjoint of A inverse. Okay, do you remember what was the formula for adjoint of A determinant? It was basically determinant of A into raised to power n minus 1 whole square. So if I have 3 adjoints, then it will be determinant of A raised to the power n minus 1 whole cube. Okay, this determinant basically. Now here the interesting fact is it is A inverse. It is A inverse. So basically we know this will be changed, right? Your determinant of A, let me assume this to be another matrix B, right? B basically. Let me assume this to be B. And your B is A inverse, correct? So what will be your determinant of B? Determinant of B would be 1 by determinant of A, that is basically determinant of A raised to the power minus 1. Okay, so this will be basically A raised to the power minus 1 into n minus 1 whole cube, right? N is 3 in our, sorry, n is the order of the matrix, right? That is 3, yeah, that is 3 basically. So what is determinant of A? It is 2 raised to the power of minus 3 minus 1 whole cube, that is 2 cube, that is 2 raised to the power minus of 8, and 2 raised to the power 8 is nothing but 256, so it will be 1 by 256. This will be your answer for the question. The cumulative distribution function CDF of a Gaussian normal distribution has which of the following shapes? A horizontal shape. So they're talking about the CDF, right? So what is the PDF of a Gaussian function? Let's say a very basic with zero mean. The PDF is like this, right? CDF is nothing but the integration of PDF. So if I integrate this, slowly the area will increase, and at about the mean, the area will be maximum. Then what is happening? Here also we are adding up the area, but the rate at which I was adding, that will reduce, right? Because overall area whatever I'm adding, that is slowly reducing after every positive values of x. So it will be like this. The slope will reduce. That's all. Okay. So essentially, it is actually the shape is somewhat like this. So it's not like proper like this, but it is like a S shaped. Okay. So it is not obviously it is not a straight line. It is not a horizontal line. It is not a bell shaped curve. Bell shaped curve is the PDF, not the CDF. So it is a S shaped curve that is given here, right? So your option D will be the correct answer for this question.
Yeah, so which ADC is the fastest? Flash type, right? Which one is the slowest? Dual slope. Like what is the order? Flash, faster than SAR, faster than counter, and faster than dual slope, right? Now what all are the time taken? Ideally it would take 0 time, but for theoretical purpose we say T clock. Although there is no clock used here, ideally it will take 0 time, but still we say T clock. Here n T clock irrespective of any kind of input. Here maximum time it can take 2 to the power n minus 1 T clock. And here it would take 2 to the power n T clock plus some more time as well. This more time you can analyze, we don't remember it. So this is the scenario. Like this is not the time it would take for all kind of input, this is the maximum time it can take. And what is the minimum time? It can take minimum time to be T clock only. So it can never be faster than flash type, that's for sure. But when we take the average, if we take the average of this one, so average time taken by the counter type ADC, we write down 2 to the power n minus 1 T clock. This is what we write down. This is the average time we write down. Because if you take the average of both of them, then it would come out to be 2 to the power n minus 1 T clock. So which one is the fastest? Flash type. Okay, let's go to the next. Yeah, this is again formula weight equation only. Do you remember this property? Sorry, do you remember this formula? Ni square equals to A naught T to the power 3 e to the power minus Eg by kt. From where it came? It was actually NCNV e to the power minus Eg by kt. Right? So from there it came. Then you put down the expression of NCMV. Then here there will be a term of effective mass as well, T to the power 3 by 2 would come, that would become T to the power 3, then rest all the parts would be constant, right? And all the derivation also we have seen regarding this particular formula. What we need to do, everything is same. Along with that, what they are saying is that effective density of states are not changing. That means NC and NV value are not changing. Ideally, this is the formula, no? NC, NV, and then the same thing. So, with respect to the temperature, these things are not changing. With respect to the temperature, energy band gap is also not changing. This particular thing also changes with the temperature. What is that formula? Eg naught minus beta T. As the temperature increases, band gap reduces, right? So that thing also takes place, but nothing is happening here. Only thing is that they are having different band gap. That's it. So at 400 Kelvin, temperature is 400 Kelvin. So what will be the scenario? What will be the ratio of NIB divided by NIA? This is what they are asking. The temperature is 400 Kelvin, and they are asking the ratio. Okay, so let's get started. Let's try solving this problem. So what will be your Ni square B divided by Ni square A? Constant will get cancelled out. Temperature will also get cancelled out. 400 Kelvin, that will also get cancelled out. E to the power minus Eg of B, that is 1.1 divided by kT divided by 0.90 electron volt. Right? This is also electron volt. This is also electron volt divided by kT. Right? Now what you would do? What will be the value of kT you will pick? So basically, if I solve it, what I will get is that on the upper side it would become 0.2 divided by kT. If this goes upward, this will be a positive sign. 1.1 minus 0.9, that would be 0.2 electron volt divided by kT. What will be the value of kT you will pick? 0.0259. No. Temperature is 400 Kelvin, no? So what is the value of kT? kT is proportional to temperature. At 300 Kelvin, I know that value is 0.0259. So at 400 Kelvin, what will be the value? That would be 0.0259 into 400 divided by 300. So that value I will pick here. So that will be the ratio of Ni square B divided by Ni square A. So in place of kT, what I am going to put? This value I am going to put. So what I am going to do is that electron volt. Surely all the calculation in electron volt. So 0.0259 into 4 by 3. 0.0259 into 4 by 3. Then take the reciprocal into 0.2 plus minus e to the power. So it is coming out to be 0.003, and this was mentioned in one of the option as well. But the problem is you forgot to take the under root. So when I take the under root, it is coming out to be like you need to find out NIB divided by NIA. Then you need to take its under root as well, no? Whatever the answer you are getting, then you need to take its under root as well. So when you take the under root, it is coming out to be 0.055. So that's the correct answer. Let's go to the next one. Yeah, that's a good question. Normal incidence is taking place on XY plane. XY plane is there, normal incidence is taking place. If it is XY plane, what does that mean? That means that this would have been Z less than 0, this is Z greater than 0. Wave is traveling in positive Z direction, so this is how it is traveling, and it is striking at 90 degree or 0 degree, like making an angle of 0 degree with the perpendicular. Then what will happen? It will be reflected back. So this is the wave propagation direction. Electric field is having two components. One is dancing in X direction, other one is dancing in Y direction. X and Y. Which one is X, which one is Y? I don't care. Right? Now what they are asking, what is the wave polarization of incident wave, reflected wave, and the transmitted wave? This is what they are asking. So what do I do? First, for the incident wave, I can tell. If I write down the phasor form of incident wave, what that would be? E naught 1 e to the power minus beta z. Although I don't need to write it down, but still I am writing down. Plus E naught 2 e to the power minus j beta z, and it is leading by pi by 2. AY cap. It is leading by pi by 2. So which guy is leading? If I make the waveform, this is your, let's call this as X, this as Y. So where will be Z? Z will be coming towards me. X cross Y will be Z. Z will be coming towards me. So which one is leading? Y is leading. This guy is leading. Who is lagging? This guy is lagging. Would E naught 1 is equals to E naught 2? This would also be given. Yeah, this is also given that E naught 1 is equals to E naught 2. That means in place of that, I can simply write down E naught only. Phase difference of pi by 2. Both magnitude equal. What does that mean? What kind of polarization it is? Circular polarization. Right? It is circular polarization. Now next thing, whether it will be left hand circularly polarized or right hand circularly polarized. So I need to rotate my hand from lead to lag such that thumb is pointing towards the direction of propagation. So direction of propagation is towards me. I need to use my left hand, right? Lead to lag such that direction of propagation should be towards my thumb. So left hand circularly polarized. So it is LHCP. Other method also I have told, two methods I have told. From the other method also you can do it. From which method? That you sit at z equals to 0. This was the pure concept actually. You sit at z equals to 0 and then you put the values of t. When I put t equals to 0, what I was getting? When I put t equals to 0, I was sitting at z equals to 0. That means I was sitting on this particular plane. And wave was propagating like this. Right? Wave was coming like this. I was sitting on this particular plane. So what did I show? Wave is coming like this. Then what is the scenario? The scenario is this will become cos omega t and this will become cos omega t plus pi by 2. So at t equals to 0, what component I am having? Only ax cap component I am having. That means only in this component. And then when omega t is pi by 2, at that time I will have only y component but in the negative direction. Right? So this will be the scenario. This is how the wave will look like. It is rotating in clockwise direction. Rotating in clockwise direction and moving in positive z direction. Moving in positive z direction in this manner. Here it is moving, rotating in clockwise direction. So how it would look like? Just try imagining it from the left hand. Coming towards me, rotating in this direction. Clockwise coming towards me, left hand circularly polarized. So both of the methods I have told. Here you are not using your brain, here you are using a method, here brain is used. In the examination, brain doesn't work, method works. Sometimes brain works, sometimes method works. So you can go with the method. Incident wave is left hand circularly polarized. What about the reflected wave? So can you write down the equation of reflected wave? Surely I can write down. What I can do? I can find out the reflection coefficient. What that would be? Epsilon r1 minus epsilon r2, under root epsilon r1 minus under root epsilon r2 divided by addition of both of them. So under root epsilon r1 will be 2, 2 minus 1 divided by 2 plus 1. So that would be 1 by 3. So this is the reflection coefficient. What will be the transmission coefficient? That would be 4 by 3. So electric field is not changing the direction. Magnetic field is changing the direction. Along with that, reflected EM wave is also changing the direction. Right? Now the wave will be in negative z direction. So what will be the equation? The equation of electric field which is reflected. What that would be? Sir, magnitude will be multiplied with 1 by 3. So is the magnitude changing? Absolutely not. Magnitude, both of the magnitudes will be multiplied with 1 by 3. It is not changing. But the direction of propagation is changing for the EM wave. But electric field is dancing in the same direction. Electric field is dancing in the same direction. Just the direction of propagation has changed. So e to the power j pi by 2 ax cap. Now what is the scenario? Only one thing has changed. What is that? The thing that has changed is direction of propagation. So let's just say this is x, this is y, this is again lead only, this is lag only. Where will be z? Z will be coming towards me. This will be my z. But what is the direction of propagation this time? Direction of propagation is inside. So I will move my hand from lead to lag such that it should be pointing towards the direction of propagation. Left hand I need to use. Lead to lag moving such that in the direction of propagation which is inside. What does that mean? It is right hand circularly polarized. Okay, so it is right hand circularly polarized. That is reflected wave. Reflected wave is right hand circularly polarized. So this option is also gone. This option is correct. Reflected wave is right hand circularly polarized. What about transmitted wave? In the transmitted wave, sir, nothing is changing actually. Direction of propagation plus z. Phase difference pi by 2. It's just that magnitude will be changing. So if I write down the equation of a transmitted wave, so 4 e naught by 3 e to the power minus j beta z only plus 4 e naught by 3 e to the power minus j beta z only e to the power j pi by 2 ax cap. Sorry, this is not ax cap, this is ay cap. Ay cap. So who is in lead? Y is in lead. This guy is in lead. Again, he is leading, he is lagging. How would you move your hand? Move your hand in a manner that direction of propagation is, sorry, the thumb is pointing towards the direction of propagation. Again, the same scenario will take place. What does that mean? It will be also left hand circularly polarized only. So transmitted wave is right hand circularly polarized? No. It will also be left hand circularly polarized. So this was the case for normal incidence. The similar scenario could take place for oblique incidence as well, both in lossy and lossless medium. So complete scenario has been explained in this particular video. Please do watch this particular video. Surely it is coming in future. Surely it is coming. Okay, it's not that it was very tough. Even if you did not watch this particular video, still you will be able to solve it. by simple equations. But here we have made very good conclusions and very good observation also we have seen. So please do watch this particular video. This is very, 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 very important. I have taken it from NPTEL only, and in AIMT till now this is not introduced. So next day if they think that I need to frame something new question, some new question from the concept of oblique incidence or normal incidence, then this is where they will be framing the problem from. I am pretty sure about it. So please do watch this particular video. Okay, let's go to the next one. Yeah, so this is again based on EM wave only. We need to find out total power crossing. So what will be the total power? First I will find out time average Poynting vector, and then I will multiply with the surface area. So I will get my total power, right? So how will you find out my time average Poynting vector? That is half of real part of ES cross HS conjugate. Can I find out the ES value? Yes sir, that would be 20 e to the power minus beta z AX cap. Take care of the unit, it is going in volt per meter. What about HS? So it would be 0.05 e to the power minus j beta z AX AY cap, which is pretty obvious, it has to be AY only. So ES cross HS, what it would become? HS conjugate, first let me know what is HS conjugate. So that would be 0.05. If you take the conjugate, this will become e to the power plus j beta z AY cap. So ES cross HS, what that would become? Sir, it would become 5 by 100 1. So it is simply becoming AX cross AY, that is AZ cap. So it is nothing but AZ cap only, right? 20 into 0.05, what that would be? 1 only if you multiply both of them. E to the power minus j beta z will be cancelled with e to the power plus j beta z. AX cross AY, that is AZ cap. So what you are getting? AZ cap divided by 2. What will be the total power now? So now what is the surface here? What will be the perpendicular vector? What will be your ds vector? Ds vector will be, sir, magnitude is 14.14, and what will be the direction? Direction will be AX cap plus AZ cap divided by under root 2, right? Simply I have taken the gradient, AX cap plus AZ cap divided by under root 2. Okay, so this is your ds vector. So here I will write down AZ cap divided by 2 into 14.14. 14.14 I can write down in this manner, under 2 into 10. But take care of this thing, centimeter square. This is coming in volt into ampere watt per meter square, and this is in centimeter square. So I will have to multiply with, this is my 14.14, that means it is under root 2 into 10. Multiply with 10 to the power minus 4 as well, because I need to convert it into centimeter. From centimeter I need to convert it into meter. So this will become 10 to the power minus 4. Is that understandable to you? So this was a good thing here. Yeah, so this is the P average, this is the ds vector under 2, 10, well and good. Say yes or no. Right, that's it, dx dy. So basically what I am doing is that I have just written it down in a quicker manner, in a much quicker manner. If I write down in a correct manner P total, what that would be? Sir, P average is coming out to be AZ cap divided by 2 dot ds. What will be ds? Ds will be, sir, ds will be this much, not this much, like this is the complete ds I have written. So let's write it down completely only. 14.14 AX cap plus AZ cap divided by under root 2, but 10 to the power minus 4 also you need to do. Is that understandable to you? Okay, basically this came from dx dot dy, right? This is the value of dx dot dy because this is the total surface area. So if you just simply solve it, what you are going to get? AZ cap divided by 2, AZ cap divided by under root 2. This will throw 1 by 2 under root 2. And AZ cap divided by 2, AX cap divided by under root 2, this will throw 0. So from here 1 by under root 2 is coming, from here 14.14 is coming, 1 by 2 is already there, and 10 to the power minus 4. This is the scenario, this is the total answer we are getting. So 14.14 divided by 2 divided by 2 under root, then 10 to the power minus 4. So 10 to the power minus 1 I can take aside, so it would come out to be 0.5 milliwatt. That's the answer. So what is the answer? 0.5 milliwatt. Okay, well and good. Let's go to the next one. I hope you already know this kind of concept. These are very standard questions. They are in your class note itself. Okay, so that's why I did this calculation in a much faster manner here. Okay, you write down the ds vector first, you write down the unit vector, then you write down the ds vector, then you would see what will be your surface area, right? Then you would know that the surface area would come out to be 14.14 only, 14.14 centimeter square. Then you would multiply here, then 14.14 divided by 2 under root 2 you will be getting, and then this would be the answer. Okay, so in a quicker manner I have done it, but I hope you are comfortable with this kind of concept. Let's go to the next one. Yeah, ft is a even and periodic signal. Okay, a signal xt is defined as f of t u of t, and what is your yt? Yt is nothing but f of minus t u of minus t. Ft is even as well, so can I write it down in this manner? Yt is nothing but f of t u of minus t. So this is your ft, which is periodic, and it is even as well, so this is how your ft is going. Okay, now what is your xt? Xt is this much, it is periodic as well, so this is your xt and this is your yt, and so on. This is your yt and this is your xt. This is periodic in the left hand side, periodic in the right hand side, sorry, this is periodic in the right hand side. What does that mean? Its ROC will be real part of s should be greater than 0, and what about this? Its ROC would be real part of s less than 0. Why is that? So what is the meaning of ROC? Meaning of ROC is that your signal should be multiplied with e to the power minus sigma t such that xt dot e to the power minus sigma t becomes absolutely integrable. So if I multiply with e to the power minus sigma t, so if I say sigma is less than 0, that means let's say sigma is 1. So what it would become? E to the power t. So what will be the graph of e to the power t? Somewhat like this. So if this particular graph is multiplied with this graph, what will happen? The values will keep on increasing like this. That means it will not be absolutely integrable. If I put sigma should be less than 0, what will happen? If I put sigma less than 0, sorry, if I put sigma greater than 0, let us say sigma is 1. So what will happen? xt e to the power minus t. So this particular graph will be multiplied with e to the power minus t. What does that mean? The values will keep on decreasing and it will go to 0. That means now it will become absolutely integrable. So if there is a signal which is looking towards right hand side and it is periodic, then its ROC will be real part of s greater than 0. If there is a signal which is looking towards left hand side and it is periodic, then its ROC will be real part of s less than 0. Is that understandable to you? Okay. So from here what do you see? That your x of s will converge for everything where real part of s is greater than 0. Real part of s is greater than 0? Yes. Real part of s is greater than 0? No. And your y of s will converge everything where real part of s is less than 0. It is less than 0? No. It is less than 0? Yes. There you go. Okay, so this is again coming from the concept of ROC. This here surely one question is coming from the concept of ROC. There is no doubt about it. Okay, let's go to the next one. And again, it has been explained on YouTube only in the last Killer X solution as well. I recommended to watch that particular video. I hope you have watched it. Let's move to the next one. Yeah, let's see this question. Sir, I saw this particular question, but I felt that this is incomplete. You have given incomplete information. Is that so? Let's check that out. Sir, you did not even mention about ROC. So let's see why I did not mention about ROC. Because there is something interesting in this particular form. Z to the power 6, Z minus 2. Where are the poles? Poles. Z equals to 2 is a pole. Sir, if I put Z equals to 2 here, that is a pole? No. If you put Z equals to 2, H of Z at Z equals to 2, what you are getting? Sir, 2 to the power 7 minus 2 to the power 7, that would be 0. 2 here, 2 minus 2, that would also be 0. Indeterminate form. What does that mean? I need to apply L'Hopital rule. How would I apply L'Hopital rule? So what I would do is that upper side and downward side differentiated. What I am doing? Limit Z tending to 2. Limit Z tending to 2. Upper side and downward side differentiated. So let's open it up so that I can do the derivation. I can do the differentiation in an easier manner. So this will become Z to the power 7 minus 2 Z to the power 6. So if I differentiate it, 7 Z to the power 6 minus 12 Z to the power 5. Now put 2 here. This will become 2 to the power 6. Just you put here, you can get to know that it is not coming out to be infinity for sure. Say yes or no. Right? You put 2 here, some value you will get. You put 2 here, 2 to the power 6 into 7, 2 to the power 5 into 12. Both are not equal. This is not coming out to be 0. That means it is not coming out to be infinity. What does that mean? Not a pole. It is not a pole. Now, this was pretty obvious. Now, two things are there. I will check at 0 and infinity. At infinity, if I see, what will happen at infinity? This guy will be very large than this one. So this particular part will be gone, and this guy will also be very large. So at infinity, what will be the value of h of z at z tending to infinity? That would come out to be 1. You can see pretty obvious, no? Z minus 2 could be reduced as z only, because z would be much larger than 2. So it would become z to the power 7. Upper side will also become z to the power 7. Both will get cancelled out. At infinity, it will throw the value to be 1. So h of z at z equals to infinity is 1. That means not a pole. What does that mean? Z equals to 0 is a pole. Yes. Put 0 here. 0 minus 2. Minus 2. 0. 0 into anything. 0. 0 minus 2 to the power 7. That would be minus 2 to the power 7. So minus 2 to the power 7 divided by 0. What that would be? Minus infinity. That means there is only one pole, that is z equals to 0. So in this particular system, there is only one pole, that is nothing but z equals to 0. Only one pole is there. So if I draw the pole 0 diagram, sorry, not 0, I only need to care about the poles. So I am having only one pole, that is at z equals to 0. So there is only one ROC that is possible, no? That has to be outer of the z equals to 0 circle. Now just let me know what kind of signal it is. Causal. ROC is entire z plane except z equals to 0. What does that mean? The signal has to be finite duration and finite amplitude. That means finite duration. What is the meaning of finite duration? That means in the impulse response, like when I find out h of n, there will be like signal could be somewhat like this, and it is having some impulses like this. So it will be finite duration. So there will be only finite impulse responses. So it will be a FIR filter, not IIR filter, not non-causal. Only one pole was there. ROC was z greater than 0. ROC is entire z plane. If it is entire z plane, put except z equals to 0 or z equals to infinity, then it has to be a finite duration signal. If it is a finite duration signal, that means it is a FIR filter. Someone would say that, sir, filters are not there in the syllabus. DTFS they have mentioned, DTFT they have mentioned, jet transform they have mentioned everything about the discrete time. Continuously they are asking question on LTI system. Why cannot they ask a question on LTI system in discrete time? Surely digital filter is there in your syllabus. It's just that they are specifically not mentioning it. Surely the question can come. And even if someone doesn't know the meaning of FIR, I have simply put it. What is the meaning of FIR filter? The impulse responses is non-zero only for a finite number of samples. So impulse responses will be non-zero only for a finite number of samples. So if someone doesn't know what is FIR or IIR, still he would be able to solve it. In 2024, the question was asked on minimum phase system, maximum phase system from discrete time. So that's the concept of a digital filter only. So question would come. Okay, even the filter design question can also come, although that is very, very rare. But these kind of questions, that what is FIR filter, IIR filter, when you get into the industry, nothing would work without FIR and IIR. Okay, so these things, basic things you should know from the digital filter, at least very basic. Designing part very difficult, like that is a separate task. If they wanted to ask something from designing part, then they would have mentioned it. But at least these much things you should know. Okay, then like from the how they are interrelated with the concept of ROC, how they are interrelated with jet transform. So all these things you should know. Let's go to the next one. Yeah, so uncorrelated, orthogonal and independent. These are the three different terms. What is the meaning of uncorrelated? Uncorrelated. Uncorrelated means expectation of x dot y would be expectation of x dot expectation of y. What is the meaning of orthogonal? Orthogonal means expectation of xy would be equals to 0. And what is the meaning of independent? Independent means expectation of any function of x dot any function of y dot any function of y. That would be expectation of any function of x dot expectation of any function of y. Like any function of x, gx could be also equals to x, no? And h of y could also be equals to y. So expectation of xy would be equals to expectation of x dot expectation of y. So if it is independent, surely it will be uncorrelated. If x and y are independent, surely it will be uncorrelated. But what if g of x is somewhat like this, 2x plus 3, and h of y is somewhat like this, 2y plus 5. So if they are independent, if they are uncorrelated, then you cannot do this particular thing that, sir, I will write down 2x plus 3 dot 2y plus 5. This will show that they are independent. This will not show that they are uncorrelated. Are you able to understand this point? So if x and y are uncorrelated, then only for xy you can write down. But independent will say that for any kind of function I need to write down. That means if x and y are uncorrelated, they will be surely independent. That is wrong. Is that understandable to you? If they are uncorrelated, they will be surely independent. That is wrong. Why is that so? Because uncorrelated will say only for xy, but independent will say for any function of x and y. Is that understandable to you? Now what is this function? Z equals to ax plus by. Can you write down the variance of z? So that would be a square variance of x, b square variance of y plus 2ab sigma xy. What is the sigma xy? Sigma xy is known as covariance of x and y. What is this covariance? Covariance is nothing but expectation of xy minus expectation of x dot expectation of y. There you go. This is the thing, you should know these many things, you will be able to solve this particular question. So will you be able to solve it now? Surely you will be able to solve it. You know the value of expectation of x, expectation of y, sigma x square value also you know, sigma y square value you also know. You can find out the value of sigma xy. How will you find out the value of sigma xy? For this uncorrelated case, value of sigma xy will be, for this uncorrelated case, this would be 0. Expectation of xy would be equal to expectation of x dot expectation of y. That would be equal to 0. For orthogonal case, sigma xy would be nothing but expectation of x dot expectation of y. That would be minus mu x minus mu y. What is the value of a? Value of a is 2. What is the value of b? Value of b is minus 3. Okay, so do we have the page? Yes, we have the page. So z equals to 2x minus 3y. 2x minus 3y. So sigma z square would come out to be 4x square plus 9y square, 9 sigma y square (12 sigma xy). For orthogonal, not for orthogonal, for uncorrelated, sigma z square would come out to be 4 into sigma x square, 16 plus 9 into 6, that would be 54. That is coming out to be 70. So if they are uncorrelated, then it is 70. If they are orthogonal, then for orthogonal, so this much would be same, till 70 it would be same, minus 12 sigma xy. What will be sigma xy? That would be minus mu x mu y. So 2 into 1, that would be 2 only. So plus 2. Some people would forget this 12. That's why I put the option to be 72, which will be wrong. Answer would be 24. That means it would be 94. Okay, so answer would be 94. Here it would be 70. Well and good. Let's go to the next one. So A and D are the correct answer.
Given below is a unity negative feedback control system with open loop transfer function as this. It is a unity negative feedback control system with OLTF this. Determine whether the statements are true or not. S equals to this value is a valid breakpoint. S equal to value of k is 4 at breakpoint. Value of k marginal. K marginal basically when the system is marginally stable. They should have mentioned when the system is marginally stable, then the value of k is 70. The natural frequency of oscillation, that is omega n, right, is 3.61 radian per second, 3.16 radian per second. So how can I calculate all these values? Natural frequency of oscillation. So this is a third order system. How can I find out the natural frequency of oscillation? Okay. Okay. Basically, the natural frequency of oscillation will be when my system is undamped. Okay. So if I plot the root locus of this particular system, right? So s equal to 0, we have a pole. S equal to minus 2, we have a pole. S equal to minus 5, we have a pole. Correct? So then if I plot the root locus, right? So these two will combine with each other, then there will be breakaway point. Here I will have a virtual 0 basically. Correct? I have a virtual 0. And yeah, here they will again break away. So is my system ever getting to natural frequency of oscillation? So if I plot the root locus, I'm not observing that my system is ever crossing, basically it is ever cutting the j omega axis, right? My system is never cutting the j omega axis if I see here. Okay, So now there, so it is a unity negative feedback transfer function. Yeah, s equal to -2 -5. Now they're telling that s equal to -3.8 is a valid breakpoint. So at s equal to -3.8, right, s equal to -3.8 would be somewhere here. So it does not even lie in the root locus. How can it be a valid breakaway point or breakpoint? Basically, it does not even lie in the root locus, so it cannot be a valid breakpoint. Okay, so that is gone. So this option is automatically gone. Now the value of k is 4 at breakpoint. Okay, so actually it should have mentioned whether it is talking about the break. Like we can discuss, we can see, we can take both breakaway and break-in point, right? So what will be the value of k at this particular point at breakaway? So do you remember what used to happen in breakaway? Either the value of k would have been maxima or minima, right? So basically, what is the value of k? So I can write 1 plus g of s, right? 1 plus g of s equal to 0. So from this I can write the value expression for k. Expression for k would be minus s into s plus 2 into s plus 5. Okay, so dk upon ds, like either maxima or minima of k will happen, right? That would be, so let me first like solve this. This will be minus s into s square plus 7s plus 10. Okay, this would be equals to minus of s cube minus of 7s square minus of 10s. So if I differentiate k with respect to s, I will get my breakaway and break-in points. So this will be minus, I can take common, this will be 3s square plus 14s plus 10. Okay, so yeah, I will equate this equal to 0, right? So from this I can get the value of s. S will be equals to minus of b minus of 14 plus minus b square, that is 256. Sorry, it will be 196 minus 4ac, right? 4ac would be 14 to, that is 120 upon 2a, that is 6. So this would be 196 minus 120 under root. So this would be 8.71. So this plus minus 14 upon 6, this would be equals to minus 0.88, and the other value would be 8.71 minus 14 upon 6, that would be, yeah, minus 3.8, and minus 3.8 is not even a breakaway point. So yeah, at s equal to minus 0.88 there is a break point, correct? One more break point should be there actually. Okay, why I'm not able to find out this break point? Minus 3.8, this should also be break point, right? Break-in point, or it is never breaking in, because here I have 3 odd modules, so it will, no, it will break in here. So it is, okay, sorry, okay, I've made a mistake in making the uh, root locus, right? Because what used to happen is, how many number of virtual zeros we'll have? We'll actually have 3 virtual zeros, correct? Yeah, sorry, this will not terminate here, right? Okay, sorry, I made a very small, like huge error. So always from the root locus, right? Always from the root locus, what used to happen? My root locus starts from the from basically the root locus starts from the, what do you call, the poles, and it ends at the zeros. So I have to actually find out the asymptotes. So as there are 3 poles, right? So there will be 3 virtual zeros. I also have forgotten number of z is 0. So there are 3 virtual zeros. Okay, what will be the asymptotes? Asymptotes angle, right, would be basically 180 divided by p minus z into 2n plus 1. So one of the asymptote will be where n is equals to 1, 2, 3, 4. So one of the asymptote would be 60 degrees when n is 0. Other asymptote would be when n is 1, it will be 180 degrees. And the third asymptote would be at when n is 2, that is 5 into 60, that is 300 degrees. Okay. So I was wrong actually. We'll have, so I also have like I also have make bit of mistake because I also have not revised control much. So so one of the asymptote is at 60 from the positive x-axis, so that would be somewhere here. Okay, other one would be at 180, that is here. This was correct actually. There is no breakaway breaking point, it will directly terminate, right? And the final one would be at 300 degrees, that is basically somewhere here. 300 degrees will be somewhere here. So basically my root locus will break away. There is only one break point, that is this one, right? And then it will end in the asymptote. So I was wrong there. Initially I had drawn the root locus wrong. Okay, so now I have it is clear. Now it cuts. Okay, now it cuts the j omega axis. So what we can do, we can take the dominant pole assumption and we can neglect the pole that is further away from the origin, so that my system will behave as a second order system, and due to that we can actually calculate the marginal value. So we got our breakaway point. Yes, this is a breakaway point, that is minus 0.88. So what is the value of k at minus 0.88? So I will put the value of s, that is 0.88, 2 plus 2 minus 0.88 into 5 minus 0.88. Okay, so this would be equals to 2 minus 0.88 into 5 minus 0.88 into 0.88. So that is minus 4.06. Okay, so k value is minus 4. Okay, should it be minus 4 or plus 4? Just hold on. S plus this, both of them are plus only. How can it cannot come negative, right? There is no possible. Sorry, s here already a negative sign was there, and this is minus 0.88, so this will be plus 4.06. So this is correct. So k equals to 4. The value of k is 4 at breakpoint because there is a single breakpoint, so this option is correct. Okay, the marginal value of k, basically marginal basically means where my system is marginally stable. So at this particular point my system is marginally stable. So how can I find out the value of k when my system is marginally stable? So in this particular case my two roots will be purely imaginary, right? So if I write down the characteristics equation, that is equals to 1 plus gs, right? 1 plus gs, hold on, 1 plus gs would be my characteristics equation, that is equals to this, right? This whole thing. So k upon 3a square plus 14a plus 10 plus 1 equal to 0. So I can replace, this will be 3a square plus 14a. So cube also is there, right? Don't forget. Sorry. This is the value, right? Sorry. It is basically s square plus 7s plus 10s. Sorry, that was the differentiation. S cube plus 7s plus 10s. So this will be s cube plus 7s plus 10s plus k equal to 0. Okay, so when my system is marginally stable, when basically the inner product is equals to the outer product, right? This is also a shortcut. So 70 equals to k. So k is basically 70. Okay, we get the value of k when it is marginally stable when k is 70. So yeah, this option is correct. The value of k marginal is 70. This option is absolutely correct. The natural frequency of oscillation is 3.16. So we can replace it, right? We can replace the value of k here, right, with 70. And if I know that like at marginally stable, the roots are basically purely imaginary. Two roots are purely imaginary. So I can replace my s with j omega. So if I replace my s with j omega, this will become minus j omega cube. This will be, this is square actually. So this is square, right? Don't forget this square. Okay. This will be 7 minus omega square plus 10 j omega plus 70 equal to 0. Okay, just give me 1 second. So I can equate the real and imaginary terms basically. So we know that the real part and the imaginary part both should be 0, right? So if I equate the real part is basically minus 7 omega square plus 70 has to be 0. So basically I can say omega square has to be equals to 10. So from that I can directly say that omega will be under root of 10. I will ignore the negative solution, that is under root 10 is somewhat like this, that is 3.162 radian per second. Okay, that is what my omega is. So this is correct. Natural frequency of oscillation is 3.16 radian per second. That is correct. So option 2, 3 and 4 will be the correct answer for this question. A control system is given with a block diagram like this. The system exhibits a steady state error of 0.4 for a unit ramp input. Okay, based on this information, so we have a steady state error of 0.4 for a ramp input. Okay, so we are getting a finite error, non-zero error for a unit ramp input when my input R of S equals to a ramp signal R of t, right? Unit ramp, this will be basically the Laplace transform would be 1 upon S square. Based on this information, determine which of the following options is correct. The system gain k is this, the time constant of the system is this, the decay ratio is this, the settling time is this. Okay, so first of all let me define the OLTF, because this all these things are will be defined by the OLTF. So what is the OLTF? Let me simplify this block diagram. This will be 2 by g this g upon 1 plus g is, right? That is 1 plus 2 into 2 by s into s plus 1 into 2s, right? That would be my transfer function basically. Okay, so my transfer function would be OLTF would be 2 upon, this will be s square plus s plus 4s, that is s square plus 5s, right? So this would be basically, so this is the this block diagram. Now I will multiply k, so overall it will be k into 2 upon s into s plus 5 basically, right? S into s plus 5. Now the steady state error is 0.4. What is the definition of error? Do you remember what was the definition of error? Basically the error was here, right? For a unity feedback system, my E of s was equals to R of s minus C of s, right? Or if I take common my R of s, right? R of s, if I take common, this will be 1 minus C of s upon R of s, which is nothing but the transfer function of the system. Now what is my transfer function? Because this is my OLTF, G of s. What is my transfer function? It is g of s upon 1 plus g of h of s, that is 1 plus g, right? Because it is a unity feedback system. So this would be 2 upon s square, so 2k upon s square plus 5s plus 2k. Okay, so I will put that here. So R of s is 1 by s square 1 minus 2k upon s square plus 5s plus 2k. Okay, that is equals to my error function. So the steady state error would be, I have to apply the final value theorem, ES of s, right? That is limit as s tends to 0 s into e of s, that will be the steady state error. So this will be 1 by s into this will be s square plus 5s. So I can again take s common, that is 1s plus 5 upon s square plus 5s plus 2k. Okay, that is equals to 0.4. Okay, so this would be 5. So SS will be cancelled. 5 upon 2k is equals to 0.4. So from this I can say what is the value of k. 0.4 is nothing but 2 upon 5, right? So this will be 25 upon 4. 25 upon 4 would be 6.25. So value of k would be 6.25. 25 upon 4, yes, 6.25. 5.25, hold on a second, 25, no, 5.25 is incorrect, right? It will be 6.25. So value of k is 6.25. So this is incorrect. The time constant of the system is 0.4 seconds. Okay, they are asking me the time constant. Time constant would be basically for a second order system, right? It is basically zeta into omega n. That is the time constant, okay, of a system. So okay, they're asking me time constant. So yeah, time constant would be sorry sorry, zeta, one inverse of this, right? 1 by inverse. Why, how? So we remember basically, if first of all I will check like if it's an underdamped system or not. For underdamped system only this is the value. So I'll quickly tell you how is the time constant defined. So let me first plot the transfer function, right? Transfer function. So transfer function would be 2k. Remember there was a 2k here. This was 2k. Transfer function was 2k upon s square plus 5s plus 2k. So 2 into 6.25 would be 12.5. So 12.5 upon s square plus 5s plus 12.5. Now is the system overdamped, underdamped or critical damped? So we can check that by seeing the observing the roots. So if I find out the roots, this will be minus 5 plus minus b square minus 4ac. So your b square minus 4ac, right, would come out to be b square minus 4ac negative. B square minus 4ac is coming out to be negative. That means of course your system has to be underdamped. For in underdamped system only my roots are complex conjugates. Okay, so it's an underdamped system. For underdamped system we know that the poles will be lying somewhere here, and the time constant is defined basically the negative of the real part, negative of inverse of the real part of the pole. Okay, so my real part of the pole is lying at zeta omega n. Time constant would be inverse of this, right? So inverse of this, that is 1 by zeta omega n. So what is my zeta and omega n? Omega n is basically omega n whole square will be 12.5. Omega n would be under root of 12.5. What is my zeta? Zeta would be 2 zeta omega n. I can compare with the normal equation equals to 5, right? So from this I can easily find out the value of zeta. Zeta would be, so omega n is 12.5 under root this into 2 into 5. So this will be 0.707. Okay, so your time constant tau would be zeta into omega n, that is 12.5 under root inverse, that is 0.4 seconds, which is correct actually. So time constant equals to 4. This is correct. The decay ratio is e raised to power minus 2 pi. What is the decay ratio? So decay ratio, right, if you remember that my maximum peak overshoot MPO, it is equals to e raised to power minus pi cot theta. Now this is the first peak, right? So this is the first peak. When does the second peak happen? After a period of 2 pi. So the second peak, right, maximum peak overshoot, second peak overshoot would be after a 2 pi period, that is e raised to power minus 3 pi cos theta. Now the decay ratio is the by how much the peak decays, right? Because the peak would be somewhat like this, by how much the peak will decay, that is the decay ratio. So this will be the second peak overshoot upon the first peak overshoot. Okay, that will be equals to e raised to power minus 3 pi cos theta upon e raised to power minus pi cos theta, that will be equals to e raised to power minus 2 pi cos theta. That is my decay ratio, and this value actually is the maximum peak undershoot. Okay, for your information. So what is theta? Basically theta is basically cos theta is zeta, right? So cos inverse of zeta would be my theta, that is zeta is 0.707, so theta would be 45 degree. So cos theta also will be 1. So basically my decay ratio would be e raised to power minus 2 pi. Okay, so what is e raised to power minus 2 pi? So 2 into pi exponential would be 0.001, which is yeah, e raised to power minus 2 pi, this is correct, right? Decay ratio is e raised to power minus 2 pi, this is correct. The settling time of the system is 1.61. Settling time is nothing but 4 tau, right? 4 tau, which is 4 upon zeta omega n. So I already know what is tau, so 4 tau would be 1.61 approximately. So this option is again correct. So option A, B, C, all of them are correct answers for this question. So not A, B, C, sorry, B, C, D are correct answers for this question.
Yeah, so the bandwidth according to the Carson's rules, what that would be 2 into delta F plus Fm, right? What is the meaning of delta F? So it is frequency modulated, so you can say that sir frequency would be Fc plus KFMT. So sir KFMT, this is my delta Ft. If I need to find out delta F, that means maximum value of this Kf into maximum value of Mt. What will be the maximum value of Mt? Sink will have maximum value to be 1. So delta F would come out to be 10 to the power 3. What does that mean? It is 1 kilohertz. So delta F is nothing but 1 kilohertz. That is your delta F. Okay. Now what about Fm? Fm is 10 kilohertz. You can see this is sine 2 pi into 10 to the power 4. If you divide by 2 pi, you will get 10 to the power 4. That means frequency is 10 to the power 4. That means it is 10 kilohertz. So frequency is 10 kilohertz. So what will be the bandwidth? Bandwidth will be twice of Fm is 10 kilo, delta F is 1 kilo. So 10 kilo plus 1 kilo. So that would be 22 kilohertz. So bandwidth is 22 kilohertz. Okay, well and good. Let's go to the next one. Again, for which value of beta transistor will be in the saturation? Sorry, transistor will be in the active region. Okay, so this is your transistor. Current is flowing from P to N, P to N. So this will be NPN. This is your emitter junction. This is your collector junction. And this is your emitter junction, right? P is at 5 volt. Now VB value would be given. Okay, VB value I forgot to mention. Should have been mentioned, no? So I will mention it. VB is 0.7. Okay, here it is not mentioned. So VB is 0.7. So what does that mean? What will be this potential? This potential will be 4.3. So P is connected to positive, N is connected to less positive. What does that mean? It is in forward bias. You want it to be in active region. That means you want it to be reverse bias. That means you want this node. Let's just say this node is, let's call this node as VA and this node as VB. So you would want VA to be greater than 5 volt. This is your target. That's it. Okay. So will you be able to achieve it? So this is 5. This is 0.7. So this will be 0.3. So if it is 0.3, then this will drive a current of 1 milliampere. If this is driving a current of 1 milliampere, then how much current this would drive? This is the emitter current, this is the collector current. So this will drive beta upon beta plus 1 into 1 milliampere. Right? So how much will be the drop? So into 1 milliampere multiply with 2 kilo. So drop will be beta upon beta plus 1 into 2. So what will be the VA potential? VA potential will come out to be 10 minus 2 beta upon beta plus 1. That would be VA, should be greater than 5 volt. So 2 beta upon beta plus 1 should be less than 5 volt. What does that mean? 2 beta should be less than 5 beta plus 5. Isn't it always necessary? Now here it will go 3 beta. So beta value should be greater than minus 5 by 3, which is pretty obvious. Beta will always be greater than minus 5 by 3, right? Beta will always be greater than minus 5 by 3 because beta has to be positive. That means for all the options it is correct. There you. Okay. So just that I need to mention that VB value should be 0.7. I will modify the question and then all 4 options are correct. Okay. Very straightforward it was. Yeah. What about this question? Is it Mealy machine or Moore machine? It is Mealy machine, right? Because in Moore machine you write down state divided by the output. This kind of a state you represent. So it is surely your Mealy machine, right? Not a Moore machine. How many flops will be required? How many number of states are there? States are 4. 4 states are there. So how many bits will be required? 2 bits will be required. 2 bits means how many bits will be required? Bits required would be 2. And one flop can give 1 bit. So what does that mean? How many flops will be required? Flip flops will also be required. That would be 2, not 4. So this is also wrong, right? Now, is it what sequence it is detecting? Just see the forward path. When it is getting 0, it is moving forward. When it is getting 1, moving forward. When it is getting 0, moving forward. And when it is getting 1, again it is going back to C. It is not starting right from the beginning. If it was starting right from the beginning, then what would have happened? That means it would have been a what it would have been. It would have been non-overlapping. But it is starting from C. From the best case, it is starting. What does that mean? It is overlapping. So it is detecting 0 1 0 0 1 0 1 for the overlapping case. Let's see what is the input. 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1. So if someone has said that's a 0 1 0 1, answer is 2. No. 0 1 0 1, then 0 1 0 1, then 0 1 0 1. So it is detecting 3 times. So output will be 3. Okay, complete FSM has been uploaded on YouTube itself. You can check it out. Again from FSM as well, this year I am expecting a question from FSM. Okay, this is actually a very easy question, but we have solved a lot of tough concept regarding finite state machine. So that is there in your syllabus as well, and it is uploaded on YouTube itself. You can check it out. Let's go to the next one.
Consider the function this. Which of the following statements are true? The total number of extrema of f of x is 3. The total number of extrema of f of x is 5. The point at which f of x attains a minimum value is this. The point of inflection of f of x occurs at x equal to 0. Now there are multiple ways of solving this single question, right? So first I will solve using graphical method, then I will solve using analytical method where I will only use equations, no graphs, because sometimes you will not be able to draw the graphs. So in this case the function is pretty simple, right? This is my f of x. So if this is your f of x, I can obviously integrate this, right? Simply we have to integrate t dt. So that would, the integration would be t square by 2. So if the integration is t square by 2, then you will do what? You will put the limits, upper and the lower limits. Upper limit is x cube, lower limit is x square. So this will come out to be 1 by 2 x raised to the power of 6 minus x raised to the power of 4. X raised to the power of 4, right? So this, right, this we will try to plot in the graph. So plotting this is pretty difficult, but let me simplify it. Let me take x raised to the power 4 common by 2 into x square minus 1. So now let me plot the two functions. One function would be x raised to the power of 4 by 2, another one would be x square minus 1. So that is very simple for us to plot. So x raised to the power of 4 by 2 would be this, right? It's very simple. It is just like a quadratic only, but like this will increase more faster. So slope will be higher. That's all. That is the only difference. Now, what about x square minus 1? So x square minus 1 would be this, right? So at x equal to 0, the value would be minus 1, and it will be concave up because it will behave like a quadratic, positive quadratic, right? So x square minus 1. So what I'm doing, I'm essentially multiplying these two functions, right? I'm multiplying these two functions. So if I'm multiplying these two functions, what will happen? If I'm multiplying these two functions, what will happen is that there is a zero crossing point over here. So the let me first of all compute that zero crossing points, right? So 0 is here. If I multiply at any point, if I'm multiplying two numbers, right? Let's say x1 and x2, and one of them is 0, and if the other one is a finite value, then certainly the multiplication will be 0, right? So let me identify the 0 crossing points, right? So here at x equal to 0 there is a 0 crossing point, here at x equal to 0 this is -1, so 0 into -1 0, so this will be 0. Then at x equal to, what is this point? This point would be, just give me 1 second, when will it cross 0? So at x equal to 1 plus minus 1, right? X equal to plus minus 1, my second function will have 0 crossing points, and obviously at plus minus 1 this is some finite value, finite value. So multiplication again would be 0 at x equal to 1, again will be 0 at x equal to -1, right? Now let us decide on the sign. So here right hand side of, so you can simply use the wavy curve method, right? That also you can use actually to plot, but without wavy curve method also you can solve, but with wavy curve method actually it becomes easier if you break it down into factors, right? So essentially what is this? This is nothing but x minus 1 into x plus 1 into x raised to the power of 4, right? So when x is greater than 1, right, this function is always positive. So when x is greater than 1, this function is always positive, right? When x is less than -1, right? Or sorry, when x is between 1 to -1, right, this function is always positive. X raised to the power of 4 is always positive, right? So when x is between 1 to -1, so the sign will be according to this one, right? Because if you see in this whole duration, this function is always positive, so only the sign will be decided upon this, so it will be negative somewhat between 1 to -1, and then again at x beyond x equal to -1, less than x equal to -1, right, the function, this function is also positive, this function is also positive, as can be proved by the wavy curve method as well. I hope you know what is wavy curve method. So this function is positive, right? So it will increase basically. So this will be the graph of my function. Okay. Now, sorry, I just discussed about the sign actually. Sorry. Uh, Beyond this point, my function will be positive. X greater than 1, my function will be positive. X less than 1, my function will be positive. Between x -1 to +1, the function will be negative. But actually, what will be the plot of the function? If you notice one thing, that here the function is negative, and let's say this is between -1 to 0, right? The value of the function is -1 to 0, and between -1 to 0, this will be also somewhere here only, right? So my function will be limited. So at this point, the value of the function is 0. Okay. Now let's say I'm somewhere here, right? Where the value of the function is 0.5, and here the value of the function will be something else, right? I will take a very basic example. Let's say I'm at x equal to 0.5. So at x equal to 0.5, what is happening? This is 0.5 raised to the power of 4, right? 0.5 raised to the power of 4, and this would be 0.5 square minus 1, right? Whatever be the value. Now if you multiply these two, what will happen? It will be something less than -1, right? So the value of the function would be somewhat like this. Why it will be somewhat like this? Between -1 to 0, because if you see, when I'm at this point, right, this function is very close to 0, right? This function is very close to 0, but this function is very far away from 0. But as my x approaches towards the origin, as my x is approaching towards the origin, the value of the other function is increasing, right? It is -1, very close to -1, but the value of this function is again approaching 0. So I'm always, what is happening here, I'm multiplying it by a small number and a large number, so essentially the overall product is a small number. Again near here as well, I'm multiplying by a small number and a large number, so the product is essentially negative, and somewhere here it will have some maxima, somewhere in the middle, right? When both of them are at optimum values, the multiplication will be highest. Okay, and similar will be followed in the other side. Like this you can do intuitively, or if you are not able to understand graphically, I have the analytical solution as well. So now this will increase, and here again what will happen? I know in between these -1 to 1, the function is negative, and after this it will always be positive. So here if you see, the value of the function is increasing, it is very close to 0. That's why I will also start very close to 0, because the multiplication factor is very small, and once both of them increase, so it will be very high, and here also it will be very high. Okay, this will be the proper graph of the function. So of course we can see that the function has 3 extrema points or critical points, as we say. Extrema points means wherever we see local maxima, local minima, and global maxima, global minima, those all will be counted on extremas. So I can see from the graph it has 3 extrema points. So first option is certainly correct, right? What about the other option? The function attains a minimum value at x equal to under root 2 by 3. So for this, certainly you can derive this, right? You can derive this. I will differentiate the function, don't worry. But you can see somewhere between 0 to minus 1, the function will attain a minima value. But exactly at what, that we will have to do by the first derivative test, right? By the first derivative test. So what is the first derivative test? F dash of x. That will be equals to 6x raised to the power of 4 minus 4x cube into 2. Yeah, and this will be equals to 3x raised to the power of 5 minus 2x cube, right? So yeah, so this is the value, right? Where is this going to 0? So if I take x cube common, this will be 3x square minus 2 equal to 0. So we see certainly at x equal to 0 there is extrema point, and we can see that, right? Certainly it is attaining a global maxima here. So not global, sorry, local maxima. We are getting a local maxima somewhere here, right? X equal to 0, and at x equal to plus minus root 2 by 3 will get local minimas. You can do the derivative test as well, but yeah, you can do the derivative test. I will do the derivative test, don't worry about it. But you will see that, yeah, these are the points of local minima and not maxima. Okay, and these are certainly not points of inflection. So x equal to 0, so this option is correct, right? We attain a minimum at x equal to root 2 by 3, that is correct. What about inflection point? So it does not have 5 extrema points, that is certain. Now what about the point of inflection? So the point of inflection of f of x occurs at x equal to 0. So it occurs at x equal to 0, right? Does it really? What does inflection means? Inflection basically means the curvature of the graph changes, right? Or we can say, just give me a second, yeah, or we can say, yeah, curvature of the graph changes, right? So if you see, sorry, curvature of the graph changes, or you can say that the slope remains constant. Slope does not change. So I can take the example of a cubic function. If you take an example of a cubic function, so if you see around origin, right, just after origin and just before origin, the slope does not change. Slope is same. So this actually point is a point of inflection. This particular point is a point of inflection, right? Where the nature of the graph changes, right? This is concave up and this is convex, right? From convex we go to concave, something like that. But here the curvature is same actually. The slope does change. Okay, it will not be sharp change, it will be like a smooth change only. So slope will change actually. After it and before it, slope does change. Okay, so certainly it is not an inflection point, but if you want to totally understand it mathematically how you can do it. So before that I want to say this function is very easy to integrate, but what if this function was a bit difficult to integrate? Then first of all, how will you compute f of x? So you will use something called as Leibniz theorem, right? This has been taught to you and I think you already know. If I have a function that is a getting integrated with a dummy variable, let's say t, right, and the limits are h of x and l of x, so how will I get my derivative? So you can actually compute the derivative without even actually calculating the actual function, right? You can directly compute the derivative. So this comes from a derivation that I have taught in my full course, so you can go over there, but that is anyways not required. You just need to remember this thing. Okay, this is very important. This can be asked in examination. So okay, so if I see what are my limits in this case, one of the limits was x raised to the power of 6, another limit was x raised to the power of 4, and my f of t is t, right? So this will be h dash of x, that is 6x raised to the power of 5 into f of h of x, right? So f of h of x would be f of h of x, that is x raised to the power 6. So this will be t raised to the power 6. Hold on, f of h of x, right? Yeah, t will be replaced with, sorry, t will be replaced, just give me a second, x dash of x, f of h of x, right? So what is h of x? H of x is, sorry, it is x cube, right? Sorry, it is x cube. That is what I was confused about. Sorry. It is x cube. This is x square, right? Sorry. So this will be 3x square into, now my f of t is t, right? So t will be replaced with x cube, because like f of t is t. So f of x cube, I will just have to replace t with x cube, right? That will be x cube only, right? And yeah, minus okay, this will be L dash of x, that will be 2x, and multiply by f of L of x, this will be simply x square, and this will be 3 into x raised to the power of 5 minus 2 into x cube. So 3x raised to the power of 5 minus 2 into x cube. So yeah, okay. So and you can see like that is what we have derived here as well, if you see, right? So I'm just like, although in this case you will use this approach much easier, but in a certain point you will see that the integration is not that simple. When the integration is not that simple, then you will use Leibniz theorem. So you will obviously get the derivative. Now, of course, again we will do the same thing. We will equate this equal to 0. We will get the points x equal to 0, x equal to plus minus root 2 by 3. So to check whether it is a minimum or maximum, we do the double differentiation. If you do the double differentiation, what will you get? Now I am telling you the analytical approach. So if you do the double differentiation, this will be 15x raised to the power of 4 minus 6x square. Okay. Now, if I put the values over here, right? Okay, so I certainly know if I put plus minus root 3, plus minus 2 by root 2 here, this will be 15 into 2 by 3 square minus 6 into 2 by 3, right? This will be 15 by 9, 15 into 4 by 9 minus 4. So 60 is 20 by 3 minus 4. So which is actually, this is something 6.66, which is positive. So this is greater than 0, right? So at plus minus 2 by root 3, the double derivative is positive, and we know if the double derivative, so at x equal to plus minus 2 by root 3, f double dash of x is positive. That means we will certainly get a minima. Now this can be a local minima or a global minima. It depends, right? That we can be found out from graph only. Okay. Now certainly we know it will be local minima only, because the function sorry, it will be global minima, right? It will be global minima because the function is always positive. Mostly it is positive. It can go unbounded for positive values, but it will never go unbounded in the negative side. So these will be global minima also, right? Great. What about x equal to 0? So if I put here 0 in the double derivative, right? The double derivative goes to 0. Now many students, if they only do by analytical method, they will say this is a point of inflection, but they will be wrong. This is not a point of inflection. Why? Because if your double derivative is 0, right, then you will have to check the triple derivative whether it is 0 or not. So you will have to continue till the point where the derivative will not equal to 0. Then you can certainly say that you will get an inflection point. Correct? Okay, so but if you did not understand this, how did this rule came, all this has been explained in the, so in the full course, of course it is explained. If you want to quickly see it, go into the RPY key video, the differential calculus part, where I was discussing maxima minima, right? Differential calculus, I think it's the second marathon, and maxima minima, right? Just see the portion maxima minima there. I have discussed. Okay, there I have discussed. Right, there I have discussed. So yeah, now I will just come to the point that we will take the derivative till the point it is non-zero. Okay, I will come to the conclusion, don't worry. So I'll just show you one small example. So x cube, right? If I take the derivative x 2x, sorry 3x square. So what are my points of extrema? X equal to 0. So what is the double derivative? It is 6x. So its double derivative is also 0. Its double derivative is also 0, right? Now you will say, will you say it is inflection? Yes, it is inflection. But how can you say mathematically? So if you take the next derivative, right? Next derivative that is derivative order to the power of 3, right? That is non-zero, right? At x equal to 0, that is non-zero. At my critical point, it is non-zero, right? Because it will be simply 6, right? Differentiation of this will be 6. So it is non-zero. So if the derivative of odd order is not equal to 0 and all the previous derivatives are equal to 0, then that point is a point of inflection. This is the mathematical proof I have explained there in the RPA video as well, in the full video as well. Then that critical point will be point of inflection. But in this case, is that happening? And if derivative of even order, right, is not 0, that means your function will be even, sorry, this will be even order. This is the derivative, right, not the power. The derivative is not equal to 0. That means the function has either a maxima or a minima. Okay, it will depend on the sign of the previous derivative. So it will depend on the sign of this derivative, right? Depend on the sign of this derivative, maxima or minima. Okay, so yeah, this you can, like this we can confirm here itself. So let's differentiate this function again, right? This is the double derivative. So the double derivative is this, right? Let me differentiate it again. So this will be 60 into x cube minus 12x, right? And at x equal to 0, again your triple derivative is 0. So let me take the derivative again once more. So this will be 120 into x, sorry, this will be 3 multiplied, right? So 180 into x cube minus 12, right? So now at x equal to 0, the value of the function is negative. So fourth order derivative is non-zero, and I have told you it will be either maxima or minima, not inflection point. So if it is negative, what it will be? So if the derivative is like, if the what is to happen if the double derivative was negative? What is to happen? We used to get a maxima, right? So if it is negative, what should we get? We will get a maxima. Are we getting a maxima? Are we getting a maxima, local maxima? Yes, we are getting a local maxima. So all the concepts are correct. So everything are interlinked. Okay, you can understand with the graph as well. So don't worry about it. So this is the like summary. If you want to solve it analytically, of course graphically it will not take you much time. But once a good question comes where the like you cannot draw the graph, right? Then you will have to solve with equations. So that's how you will solve with equations. So x equal to 0 is not an inflection point. So this is not correct. So option C and A are the correct answers of this question. For the function f of this value is harmonic for this, has conjugate harmonic function this. So what does harmonic mean? Harmonic basically means when function is harmonic, that means its del square f, right, is 0. That is what harmonic means. So basically uh, we will differentiate this function twice with respect to x, plus differentiate this function twice with respect to y, and if it was a function of z as well, then we would have differentiated this function with respect to z, and that would have been equals to 0. So for it to be harmonic, that means if I differentiate this twice with respect to x, first time this will be 2 kxy, then this will be 2ky 2ky plus this would be minus 6y square minus 6y square minus 12y square. Okay, minus 12y square, this is equals to 0. So from this, right, if I'm differentiating, sorry, minus 2y minus 12y basically, sorry, minus 12y. So from this, assuming y is not 0, my k would be 6. So for k equal to 6, the function will be definitely harmonic. So option B is definitely correct. Now what about conjugate harmonic? So when is like the function conjugate harmonic? So if I say I have a let's say some r of z which consists of real and imaginary part, we say that u and v are conjugate harmonic if it is if it follows the CR equation. If it follows the CR equation, Cauchy-Riemann equation. So what is the Cauchy-Riemann equation? Basically, u and v, if u and v are conjugate harmonic, that means your r of z function will be analytic. So what was the Cauchy-Riemann equation? Ux equals to vy and your uy was equals to minus of vx, right? So this is the real part. Let me assume this to be u. Okay, you can assume this to be v as well, no problem. Okay, you can assume this to be v as well, no problem. I am assuming it u. So what is u of x? U of x would be differentiating this with respect to x, that will be 2kxy. K is basically k is 6 because it is, we have assumed this to be already harmonic. Okay, so if k is 6, this would be 2 into 6, that is 12xy equals to v of y, that is del v upon del y, because I have to find out this function v, right? I have to find out this function v. So v is equals to 6 x, hold on a second, v is equals to 6 because I'm integrating with respect to y, 6x y square plus some constant function of y. I don't know, let me write this as some c1 constant function of y. Okay, now what about this equation? So this equation, right, u of y, what would be u of y? U of y would be differentiating this with respect to y, this would be 6x square minus 6y square equals to del v minus of del v upon del x. Okay, so if I integrate this, this would be x cube by 3, that is 2x cube, and this would be minus 6xy square plus some c2 function of x, right? And I have to include the negative sign as well. This will be plus, this will be, oh, this can be anything, I don't care. So that is what my v is equals to. Okay, so here I see obviously 6xy square is common and I have this additional minus 2x square. So your whole function, right, whole function would be like, I can combine these two constants to be some function of x and y. So your v function would be 6y square minus 2x cube plus some constant that is present in the option C. So option, sorry, not C, option D. So option D is correct because conjugate harmonic has to this, assuming that the function f is already harmonic. Okay, so option 2 and 4, that is B and D, are correct for this question. The parabola x equal to y square that varies from 0 to 1, x equal to 0 to 1, is shown in the figure. The shaded region bounded by the curve is rotated 360 degrees about the x-axis. Okay, if the volume of the resulting solid of the revolution is alpha times pi, what is the value of alpha? So what we are doing essentially, we are revolving this about the x-axis, right? So let's take a very small point. So I'm revolving this about the x-axis. So what is this distance? That is simply y, the y value here, whatever is the distance, and I'm revolving it, right? So if I just consider this point, how much area is it covering? right? It is actually pi y square, right? Pi y square. They are asking me volume. So actually not this point. If I consider this line, if I consider this particular line, right, it is covering pi y square. Now what will be the volume? Volume would be, I'm going from, let's say, x equals to x1 to x equal to x2. All this has been taught in our RPYQ, everything has been taught there. So I'm not explaining you the things here, just giving you bit of intuition how to solve this. So essentially what we're doing is essentially integrating this each areas, right, small areas together to create a volume about the x-axis. So it will be pi y square dx, where x will go from x equal to x1 to x equal to x2. This is the volume formed by the revolution. Okay, I hope that part is clear, because this is just a circle, right? I'm adding up all the circles. So what is y square? So y square is nothing but x according to the curve, right? So this will be pi x dx. X is going from 0 to 1. So this will be pi x square by 2, that is pi by 2. So your answer would be 0.5, because they have asked alpha into pi. So your alpha is simply 0.5. This is your answer of the question.
Yeah, before starting this question, first you let me know if you are having n bits. Forget about n bits. Let's just say if you are having 3 bits. If you are having 3 bits, then what whole number you can represent in 2's complement form? In 2's complement form, which whole number you can represent? Sir, the formula was somewhat 2 to the power n minus 1, sir, minus 1 plus 1. I don't remember. Don't remember the formula. I am simply telling you a trick. 3 bits are there. Using 3 bits, what number you can make? 100 you can make. In 2's complement form, if you know this particular concept, how many zeros are there? 2 zeros are there. So this number is nothing but minus 4. Right? What will be this number? Minus 2 to the power, 3 zeros are there, minus 8. So using 3 bits, I can make this 100, right? That means I can represent minus 4. So this is the lower limit in the negative hand side, or maximum limit in the negative hand side, whatever you want to call it. In the positive side, what will be there? Minus 4, not plus 4, plus 3 would be there. That's it. Let's just say they are talking about 5 bits. Using 5 bits, how many 2's complement number you can represent? So what you would do, using 5 bits, sir, I can make this particular thing. So minus 2 to the power 4, that means I will be getting minus 16. So minus 16 to plus 15, that's it. Is that understandable? Will you be able to remember it? Say yes or no. Okay. So using 2's complement number. So from here you can get the formula as well, but forget about the formula. We don't care about the formula. So how many bits we are using in all the options? 4 bits we are using. So using 4 bits, which whole number I can represent? Using 4 bits in 2's complement form, I can represent, sir, 1000, what that would be? Minus 2 to the power 3, that would be minus 8. So I can represent all the numbers from minus 8 to plus 7. So now whatever the operation that I am doing, if the final answer of this operation is coming in this range, then there is no overflow, otherwise there is a overflow. So what is this? 1101, 1101. It is written in 2's complement form. Now you know one thing, that if there is a number n, I take its 2's complement and then again I take its 2's complement, what I will get? The same number n, right? So what I would do, this is already written in 2's complement. So again if I take the 2's complement, what I will be getting? 1 here, then I will start from here, this would be 100. This is representing the negative sign, 1, 2. So this number is nothing but minus 3. What will be this number? 1011. So what you need to do? 2's complement. This is 1, this 0, 1. I hope you know this particular method, that first bit as it is, starting from here, just as you see 1, then after all the bits will be inverted. So 1 will become 0, 0 will become 1. So this bit is nothing but minus 5. So minus 3 added with minus 5, what you are getting? Minus 8. Is it lying in this range? Yes, sir. There is no overflow. No overflow. No overflow. Okay. What about the next one? They are already positive number because starting bit is 0. So nothing you need to do. 1, 2, 2 plus, what is this? 3, 5. Is it lying in this range? Yes, sir. There is no overflow. Here also there is no overflow. What about this one? 0, 1, 0, 0. This is nothing but 4. This is already a positive number. So first one is 4. Right. What about the next one? 1, 0, 1, 0. So what you would do? Sir, first one as it is, then 0 as it is, 1 as it is. Just as you have detected 1, next bit will be inverted. So this will be inverted. So what is this number? Minus 1, 2, 4. Minus 6. So 4 minus 6. What you are getting? Minus 2. Minus 2 lying in this range? No overflow. What about 0, 1, 0, 1, 0, 1, 0, 0? So 0, 1, 0, 1 is nothing but 1 to 4, that is 5. Plus this is 1 to 4, that is 9. That means yes. Is it lying in this range? No. What does that mean? Yes, there is overflow. So this is how you solve these kind of problems. It could be asked in one's complement as well. Although one's complement is not asked in the examination, they will ask most probably 2's complement only. Okay. So these kind of questions should be solved like this, like 2's complement addition, 2's complement subtraction. Don't go for those particular things. Whatever the number is given, convert it into decimal, perform the operation. Then you see that using 4 bits, this much I can represent, but they are expecting me to represent it a number 9. The number 9 cannot be represented using 4 bits. That means yes, there will be overflow. That's it. Okay. So option 1, 2, 3 will be correct, which are having no overflow. Well and good. Let's go to the next. Yeah. So this is the question based on short channel effect. Now, if you know it, then you know it. If you don't know it, then you don't know it. Look, whatever the MOSFET that we study, whatever the MOSFET that we studied, that is by default a long channel MOSFET. Okay, we always studied long channel MOSFET, but nowadays in the industry, short channel MOSFETs are used. So in industry is highly using short channel MOSFET. Even in your MTech projects as well, you will use short channel MOSFET as well. So short channel MOSFET are like very, very, very important topic, especially for the interview purpose. So even the professors are also expecting that you should know the concept of short channel MOSFET as well. If you go to IITs or ISC after your gate examination and then you say that sir, I am comfortable with EDC, the question would be coming from short channel MOSFET for sure. Okay, they can ask about DIBL and all these kind of things are there. So everything they can ask. So for that I have made this particular video in our EDC playlist. All complete EDC is available on YouTube. Complete EDC is there on YouTube. You can follow the complete course if you haven't covered. But please cover this particular video. Whatever the short channel effects are there, you will be able to understand. Along with that, you will be able to understand body effect as well, and you will be able to draw the energy band diagram of MOSFET, and you will be able to understand the working of MOSFET using the energy band diagram. Okay, so please watch this particular video. This is like highly hot topic. Surely it could be coming in near future. Okay, so if you know it, then you know it. Otherwise, you don't know it. So let's see. The drain current in the short channel MOSFET scales linearly. Yes, the relation is VGS minus VT for short channel MOSFET. For long channel MOSFET, it is VGS minus VT whole square. So this is correct. The magnitude of drain current in short channel MOSFET is comparable or larger than the long channel MOSFET. No, in short channel MOSFET you get lesser current because you can see that this relation is VGS minus VT, not square. So you will get lesser current. A short channel MOSFET reaches the critical electric field at a smaller applied VDS. Yes, because the channel length is small. No, this is n plus, this is n plus. This length is small. So that means the effect of this particular field will be much more on this particular area. What does that mean? More electric field, that means saturation will be reached early on. You remember this graph, no? VD versus E graph. So everything I have explained in this video. So you require, how much you require? 10 to the power 4. But the length is small here. What is electric field? Voltage applied by the length. Lesser length is there, that means electric field will be more. For the less applied VDS voltage. In the long channel, I was applying VDS to be 5 volt, then I was reaching critical electric field. But here I need to apply only 3 volt, I will reach the critical electric field and the current would saturate. So this is correct. Typically, the channel length of short channel MOSFET are much smaller than the depletion width of the source and drain junction. Yeah, this is the meaning of short channel MOSFET. So this is the basic definition of short channel MOSFET. So 1, 3 and 4, they are correct. Okay, let's go to the next one and do watch this particular video. Yeah, so this is also an interesting question. A lot of people would have reached till this point, 4 by 3 Q of 0.5. If you say that, sir, this I have marked out, then you have done one mistake. What you have done? You forgot to multiply with 1 by 3. Like basically, when you solve later, you will get this answer. Then you would know that all the symbols are equiprobable. You found out with respect to one symbol. 1 by 3 probability of error of one symbol plus 1 by 3 probability of error of other symbol plus 1 by 3 probability of error of other symbol. So 4Q.05, that will be multiplied with 1 by 3, no? Right? So 4 by 3 Q of 0.5, this answer you would have got. If you have clicked on this one, absolutely wrong. Then you so that, sir, yes, this is the probability of symbol error we are getting. So you clicked on this particular answer, which was this one. This is also wrong. Then someone was very smart. He saw that they are asking probability of bit error. So sir, in one symbol we are using 2 bits. That means, sir, for 1 bit, what will be the error? Half of this. So 2 by 3 Q of 0.5. Then you would have clicked on this answer. This is also wrong. The correct answer is this. Okay. Why it is wrong? First, let's reach here. So if you already reached here, then you can skip this particular video and come to the last part of this particular video. Then I will explain that this formula is also wrong. You cannot say that probability of a bit error would be probability of symbol error divided by 2. No. You cannot say that. This relation is wrong. This is approximately true, but it is completely wrong. Okay. First, reach till this point because a lot of people were not able to reach till this point. So first, let's reach here. Then we will see probability of bit error. They are asking probability of bit error, not the probability of symbol error. And each symbol is represented by 2 bits. You need to find out the probability of bit error, not the symbol error. So this was the probability of symbol error. Someone's thought that this is the probability of bit error. That is also wrong. So first let's find out probability of symbol error. So what we are finding out, probability of symbol error. So what will be your received symbol? Received symbol is nothing but s plus n. So it could be three kind of symbols: -1 plus n, 0 plus n, and 1 plus n. So can you make its PDF? Yes sir, I can make its PDF. How would the PDF look like? What is our noise? Noise is nothing but having zero mean. Although it is not written, but you can check that. What is your Gaussian random variable? Gaussian random variable is nothing but 1 upon 2 under root sigma x minus mu x whole square divided by 2 sigma x square. So from here I can simply compare that my variance is 1 and mean is 0. So can you make the PDF now? What will be n? Mean 0, variance 1. This kind of PDF you will be getting. What will be the PDF of -1 plus n? The center will be moved to -1. That means mean will become -1 here. Let's make this one also properly. Here the mean was 0, and for the next one the mean would become +1. The mean would become +1. Okay, so this will be the scenario: -1, 0 mean, and +1. -1, 0, +1. Okay, so what will be this point where they will be cutting? Symmetric it is, no? All are equiprobable, so everything will be multiplied with 1 by 3 as well. Although magnitude is 1 by under root 2 pi, at the mean magnitude will be 1 by under root 2 pi, but everything will be multiplied with 1 by 3. So magnitude would become 1 by 3 multiply with 1 by under root 2 pi. 1 by 3 multiply with 1 by under root 2 pi. 1 by 3 multiply with 1 by under root 2 pi. So 1 by under root 2 pi I am not writing it down. Okay, so this is the scenario, and this particular point will be 0.5 and this particular point will be -0.5. Now it is working on map criteria, right? Since it is working on map criteria, what I would do, I would work on a particular graph. I would see that here there will be error. Why is that so? Because if I am working on this particular graph, this is maximum. So if your input is coming in this range, then output will be given with respect to symbol 0. Here output will be given with respect to symbol 1. Here output will be given with respect to symbol -1. So if you are working on the symbol -1, this much part would be in the error. If you are working in the on the symbol of 0, then this much part would be in error. Here this much part would also be in error, and if I am working on the symbol 1, then this much part would be in error. All these things I have clearly explained. Okay, here I cannot give the full concept, otherwise it would take 1 hour. So these many parts would be in error. One thing also I can notice that they are symmetric. That means if I am able to find out this particular error, then simply multiply with 4, your job would be done. So what will be this error if I talk about this particular guy? Probability of x taking value greater than 0.5. What that would be? Sir, q of 0.5 minus mean divided by sigma, that is 1. So q of 0.5 you are getting. Similarly, you can find out for other things as well. Probability of x taking value less than 0.5 for this particular graph. Probability of x taking value less than 0.5 for this particular graph. What that would be? Q of less than 0.5. That means first I will write down the mean. What is the mean? 1 minus what is this value? 0.5. What is the variance? That is 1. So again q of 0.5. So this value will also come out to be q of 0.5. This is also q of 0.5. This is also q of 0.5, and this is also q of 0.5. So what will be the probability of error? Q of 0.5. Is that true? No. Multiply with 1 by 3 as well, because I need to multiply that with the corresponding probabilities as well. So 4 by 3 q of 0.5. But this is the probability of symbol error. Probability of symbol error. Now each symbol is represented by 2 bits. There are 3 kind of symbols: S1, S2, S3. Probability of symbol error has come out to be, let's just say probability of symbol error, okay, let's put it 4 by 3 q of 0.5. So this is your probability of symbol error. Let's just say S1 is represented by 0, 0, S2 is 0, 1, and S3 is 1, 0. Okay. Now when this 0, 0 will be in error, like I am transmitting this is a transmitter block. This is your complete communication system block. I was transmitting 0, 0. If I have received 0, 1, will you say this is an error? Yes, sir. If you received 1, 0, will you say this is an error? Yes, sir. If you say 1, 1, if you receive 1, 1, then also you will say that it is in error. Are you able to understand this point? If 0, 0 is going as 0, 0 only, then you will say that, sir, yes, it is not in error. Are you able to understand this point or not? Again, let me repeat. If 0, 0 is received as 0, 1, error. 0, 0 is received as 1, 0, error. 0, 0 is received as 1, 1, error. 0, 0 is received as 0, 0, no error. Only here there is no error. So if I say probability of bit error is PE, what I am saying, probability of bit error is PE. Okay. Now you are having 2 bits. If this guy is not in error, that means 1 minus PE probability, and if this guy is also not in error, that means 1 minus PE probability. Then this whole symbol will not be in error. Then this whole symbol will not be in error. So if I need to write down probability of symbol error, probability of symbol error, probability of symbol not being in error, not being in error, not being in error, what that would be? So symbol will not be in error if this guy is not in error and if this bit is also not in error. That means the bit 0 should not be in error, 1 minus P, and the other one should also not be in error. So this is the probability of a symbol not being in error, not being in error. So what will be the probability of symbol error? So that would be 1 minus this probability. So there you go. This is the relation. Is that understandable to you? Okay, so if there are n bits, for n bits, for n bits, so you will always remember this relation now. For n bits, if probability of symbol error is PS and probability of bit error is PE, then the relation is probability of symbol error would be 1 minus P to the power n. There you go. Always remember it. So in our problem, probability of symbol error, we have got this to be 0.41. 0.41. 1 minus P to the power 2. Now, like approximately what they do is that they apply the formula of 1 minus x to the power 2 here. So what you will be getting? 1 minus 2x, right? And then one sign is here. So 1 minus 1 plus 2x it would become. So this particular relation could be written as 2PE. So that is equals to PS. So P is coming out to be PS by 2. Again, it is approximated, right? What they have done is that they will say that sir, PE value will come out to be very much lesser than 1. So I can apply this formula 1 minus 2PE. This 2 comes here, 1 minus 2PE. So that would become 2PE only. So they simply divide by PS by 2. But that is approximation, not the exact one. If I see the options, I can sense that sir, closer options are there. So I cannot apply the approximation. I have to do the exact analysis. So when I solve it, what is the value of PE I am getting? 1 minus 0.41, that would be 0.59. And then take the under root, then subtract it from 1. So yeah, you are getting 0.23, roughly around 0.23. That's the answer you are getting. Okay, that's the answer you are getting. Well and good. So this was a good question. Till this point in the examination, they have asked till this particular point. But later on, they will proceed. Okay, and communication system, they can surely build up the level. So this is your level up question. Okay, let's go to the next one. So this question also, I know you are watching the solution and a lot of guys have messed it up, right? What you guys said? Sir, frequency of oscillations would become omega naught. Okay, frequency of oscillations, you can say, I should not say frequency of oscillations, like fundamental frequency is omega naught. Frequency of oscillation also you can say. So x of n is sir coming out to be 3 plus 2 sine omega naught n plus 3 cos 2 omega naught n. This is what you did, but this is wrong. That's why I am telling it. Okay. So what you did is that 2 e to the power j omega naught n minus e to the power minus j omega naught n divided by 2j plus 3 e to the power 2 omega naught n plus e to the power j 2 omega naught n minus 2j omega naught n divided by 2. So sir, from here I know that C naught is coming out to be 3. Sir, C1 is coming out to be 1 by j. C2 is coming out to be minus 1 by j. Sorry, not C2, C of minus 1. C of minus 1. And then sir, C2 is coming out to be 1.5 and C of minus 2 is coming out to be 1.5. You ask the value of C2, sir, answer is 1.5. Wrong. Okay, why wrong? Just notice one particular thing. What is that time period here? 2 pi by n. Sorry, what is the time period? That is n. What is the time period here? 2 pi by omega naught. Omega naught, you are saying that is 2 pi by 3. So your time period is 3. You know one thing, C of k would be equal to C of k plus n. Find out the value of C of minus 1. That should be equal to C of minus 1 plus 3. Value of n is 3. That means according to you, according to the very good property that C of minus 1 should be equal to C of 2. This is what you know, right? But is it equal? C of minus 1, C of 2, are both of them equal? This is minus 1 by j, or you can put it as plus j as well. Let's put it as minus j, this as plus j. This is your minus j, this is your plus j. So are they equal? No. So are we doing something wrong? Yes, we are doing something wrong. What we are doing wrong, that I will tell you. But how to write down the answer? You would see that, sir, C of minus 1 is equal to C of 2. Then actually, yes, they are equal. But they are equal to the summation of whatever that you are getting. That would be equal to 1.5 plus j. So this would be the answer. Now, sir, why they are equal to the summation? Let's check that out. This frequency, 4 pi by 3n. Can I write it down in this manner? 2n pi minus 2 pi by 3n. Basically, this x of n could be written as this x of n could be written as 3 plus 2 sine 2 pi by 3n plus 3 cos 4 pi by 3n. What that is? 2n pi minus 2n pi minus n pi by 3. Or sorry, 2n pi by 3. 2n pi minus 2n pi by 3. Right? Now you put the value of n equals to 1, 2, 3, whatever you put, this value will come out to be cos 2n pi by 3 only. Always. Always. No matter whatever the value of n you put. You put n equals to 0, what you will be getting? 2 pi by 3. Here you put n equals to 0, like better I should say, yeah, whatever you take. You put n equals to 1, what you will say? 2 pi minus 2n pi by 3. 2 pi by 3 again. You put n equals to 2, 4 pi minus 2n pi by 3. Again 2n pi by 3. Are you able to understand this point? 2n pi. It is already periodic with 2 pi, no? Say yes or no? And it is going in the fourth quadrant. In fourth quadrant, cos is positive. So this value will always come out to be cos 2n pi by 3. What does that mean? Your x of n expression, actually it was 3 plus 2 sine 2 pi by 3n plus 3 cos 2 pi by 3n. There you go. This was the scenario actually. So yes, it was omega naught. There is no doubt. This was also omega naught. But they were same frequency. They were of the same frequency. They were having the same frequency. This was the problem. Again, it is very tough to determine. Like, sir, blindly, how would you know that, sir, it is 4 pi by 3n? Sir, you have set up the question, that's why you know. Yes, I have set up the problem, that's why I know. But I will always solve in this manner. Then I will surely check that this is the property, no? This is the property. Then I will check that who knows the frequencies are same. This is not 2 omega naught, this is actually omega naught only. So for checking it up, what I will do? I will do this particular process. That I will see the value C of k would be equal to C of k plus n. I will find out the value. Then I would say that C of k would be equal to C of k plus 3. Then I will go to this guy. C of 0 should be equal to C of 3. C of 3 is not existing here, no issue. Then I will go to this guy. C of 1 should be equal to C of 4. C of 1 is here. C of 4 is here. No. Then I will go to C of minus 1. C of minus 1 would be equal to C of minus 1 plus 3. That means it should be equal to C of minus C of minus 1 should be equal to C of 2. That means, yeah, those guys are same. This is something I will get to know. Is that understandable to you? Then I would go to C of 1 again. C of 1, 1 minus 3 as well, no, because it is plus minus n. It is periodic. Then ahead 3, backward 3 as well. So C of 1 should be equal to C of 1 minus 3. That means C of 1 should be equal to C of minus 2. That means this guy and this guy is also same. That means C of 1 has to be equal to 1.5 minus j. This is the value of C of 1. Now they can ask you the value of C of 4, it would be same. They can ask you the value of 3 more, C of 7, it would be same. They can ask you the value of C of 1 already there, C of minus 2, this would be the same. Is that understandable to you? So C of minus 2 is not 1.5, it is 1.5 minus j. Is that understandable or not? A very good concept. Nowhere I have seen that this concept is taught. Everywhere they mess it up. Even the educators have messed up this particular concept. Okay, so these frequencies are actually same. When you solve it, what you would see? E to the power j omega naught n. From here I am directly writing down the value. C of 0 is coming out to be 3. C of 1 would will come out to be 2 by 2j. And from here as well something would come out to be, that is 3 by 2. What about C of minus 1? From here it will come out to be minus 2 by 2j, and from here it will come out to be 3 by 2. So this is 1.5 plus j, this is 1.5 minus j. This is your C of 1, this is your C of minus 1, and this is your C of 3. There you go. Okay, a very good concept. When you study discrete time, always study in a good manner, because from the discrete time either the question will not come. If it is coming, then it will be a good question. Okay, it will be a rank deciding question. If you are someone targeting under 50 rank, then it will decide your rank. Okay, then let's go to the next one. Yeah, that's also a good question. So here first what we need to do is that we need to talk about xt. So let's draw the xt waveform, then we will talk about yt as well. So this is our xt waveform, which is a triangular signal, which is pretty obvious here as well. I can see that it is nothing but a triangular signal. Starting at t equals to 0, it will throw the value 1. At t equals to t by 4, it will throw the value 0, and here also it will throw the value 0 at minus t by 4. Okay, that's the scenario. This is your xt, right? T equals to 0, throwing the value 1, and then 0, 0. Right. Now what they are saying is that yt is a xt convolution with the delta of t minus kt. What does that mean? This value was minus t by 4, this value was t by 4. That means what you are doing is that you are making this periodic with the time period of t. Basically, how you can write down yt? Yt is nothing but xt convolution with, can you simply open it up? Delta of t minus, put k equals to minus 1, t plus t. Put k equals to 0, delta of t. Put k equals to 1, delta of t minus t, and so on. So what you will be getting, yt is nothing but x of t, like going in this manner. X of t convolves with delta of t plus t. What that would be? T plus t. X of t convolves with delta t. X of t convolves with delta of t minus t, and so on. So x of t is there, then center moved to capital T, and so on, right? So what will be your yt? This is minus t by 4, this is t by 4, center 1, then center moved to t. T minus t by 4, what that would be? 3t by 4, 5t by 4, and so on. Similarly here as well. Center move to minus t. So minus t plus t by 4, that would be minus 3t by 4 minus 5t by 4. Okay, this is your yt. Is that understandable to you? Periodic waveform, nothing else. So this is just another way of representing a periodic waveform. I could have simply given the waveform of yt, right? But what I did is that I gave the waveform of xt, then I asked you to make yt. Now what is the scenario? Average value of xt is 0. Is that so? Yes. What is xt? Xt is an energy signal. If it is an energy signal, that means its average value will be 0 only. So average value of xt is nothing but average of this is 0. So the first statement is correct. Average value of yt is 0.25. Let's calculate the average value of yt. What that would be? I need to calculate its area and divide it by the time period. So what will be the average? What is the area? Area is nothing but 2t by 4 divided, area. First I need to find out the area. Area is, this is triangular, no? So area I need to find out. What that would be? Half into base. What is the base? 2t by 4 into height, that is 1, divided by the time period. What answer you are getting? 0.25. So that is the average value you are getting. So option B is also correct. Both xt and yt are even signal. This is even. Yes sir. This is also even. Yes sir. So both are even signal as well. So this is also correct. Now in the frequency component of yt, all the even harmonics are absent except the DC value. Surely DC value is already non-zero. Even harmonics are absent. When the even harmonics will be absent? If it is half wave symmetry or hidden half wave symmetry. Is it half wave symmetry or hidden half wave symmetry? What do you mean by hidden half wave symmetry? You subtract the DC value. If I subtract the DC value, what I will be getting? This kind of waveform I will be getting. If I subtract the DC value. Basically whole graph will be shifted by 1 by 4. That means this value will become 3 by 4, this value will become minus 1 by 4. The scenario says that whatever the value that you are getting at 0 plus, the same value you need to get at t by 2 plus as well. For half wave symmetry, this is the scenario. So 0 plus I am getting 3 by 4, at t by 2 plus I am getting minus 1 by 4. That means it is not half wave symmetry. If it is not half wave symmetry, what does that mean? So this statement would be wrong, that I know. Sir, what all frequency component would be present, that I don't know, but this particular statement would be wrong for sure, that I am pretty sure. Say yes or no. Now if I need to find out the components, then what I can do? What I can do? What will be your yt? Yt is nothing but xt convolution with the impulse train. Convolution with the impulse train. Impulse train. Do you know what will be? And one thing also, you know that convolution in time domain will result in multiplication in frequency domain. Let's just say this impulse train. What will be the Fourier transform of this impulse train? Do you know? Magnitude of 1. So magnitude will become 1 by t naught, or you can write it down as f naught. What is f naught? F naught is nothing but 1 by t naught. So magnitude would become 1 by t naught, and it will be a impulse train only. The Fourier transform or the frequency spectrum of impulse train is impulse train only. Just the magnitude will be divided by t naught, and the impulses will be there after every 1 by t naught, where n going from minus infinity to infinity. So what will be your y of f? Y of f is multiplied with this particular thing. What you will be getting? X of f. Yt is x of t convolution with this particular thing, right? Now convolution in time domain will result in multiplication in frequency domain. Now whatever the x of f you are getting, that will be multiplied with this particular thing. So what will be the answer? Can you tell what will be the answer? Basically impulses you will be getting, no? The answer would be f naught will be common. X of f multiplied with delta of f minus n f naught. What that would be? Summation n goes from minus infinity to infinity. Now x of f I can take inside, no? Because it is not having a limit of n. So if I am taking it inside, what it would become? X of f dot delta of f minus n f naught. Now I know the property of delta function. What is the property? That this particular thing could be put here, right? So what is the answer you are getting? Y of f is nothing but magnitude, although I don't care about it, summation n going from minus infinity to infinity, x of n f naught delta of n minus n f naught. Is that understandable to you? Now you can put the value of n1, 2, 3, 4 in that manner. Okay, so this will be your frequency spectrum. Now can I find out? First let's find out x of f. Can I find out x of f? Sir, yes sir, I can find out x of omega. Looking at this particular graph, I can surely find out x of omega. What kind of graph it is? Triangular. And although all these things are not required, directly I can find out y of omega. Right, I will just simply pick one period. There I will find out its frequency spectrum, and in place of n I will put n omega naught t naught. My job would be done. I have taken a longer path. Like for this particular signal, how do you find out the frequency spectrum? Have I taught you? Yes, I have already taught. Pick one period. What you do? Find out the Fourier transform of that. In place of omega, you put n omega naught, and then simply divide by t naught. That would be your answer. Right? But although I have taken a longer way. So this is your triangular function. What is this triangular function? This triangular function is nothing but a tri t minus center upon width of one side, t by 4. So what will be its frequency spectrum? A2 sampling of omega 2 by 2. This will be its frequency spectrum. So t by 4 sampling of omega t by 8. So x of omega is coming out to be A2 sampling square, sorry. This will be sampling square because it is triangular, no? So sampling square would come. Okay, so sampling square omega t by 8. Right? Well and good. This is your x of omega. What will be your x of f? X of f will simply be t by 4 sampling square 2 pi f t divided by 8. So this will become pi by 4. This will become pi by 4. This is your x of f you are getting. Now x of f you can put here. So what you will be getting? Summation n goes from minus infinity to infinity. X of n f naught. So what will be x of n f naught? T by 4 sampling square In place of f, you need to put n f naught. So what you will be getting, n pi f naught t divided by 4. What is the value of f naught t? What is the value of f naught t? F naught was nothing but 1 by t. So what is the value of f naught t? F naught into t is nothing but 1. So what you are getting? F naught summation n goes from minus infinity to infinity, t by 4. Now this 1 f naught into t naught, that would also be, this t by 4 can go outside, f naught into t naught, that would be 1. So this is becoming 1 by 4. Sampling square, f naught t is already 1, n pi by 4. And surely here f of n minus f naught is also going on. F minus n f naught is also going on. There you go. Now you put the values of n. When n is equals to 4, this particular part would be 0. When n is equals to 8, this particular part would be 0. Because sampling square, what is sampling square? Sampling square x, that is sin x by x whole square. At x equals to 0, it will throw the value 1. At x equals to pi, it will throw the value 0. At x equals to 2 pi, it will throw the value 0. So if you put n equals to 4, it will throw the value 0. If I put n equals to 8, it will throw the value equals to 0. If I put n equals to 12, it will throw the value to be equals to 0. What does that mean? That means these components, that means 4 f naught, 8 f naught, 12 f naught, they will not be present. Rest all will be present. So f naught would be present. Which all component will not be present? 4 f naught, 8 f naught, 12 f naught, 16 f naught, and so on. What does that mean? Multiple of 4 f naught will not be present. Okay, multiple of 4 f naught will not be present. Is that understandable to you? Except the DC value, because DC value will be surely present here. So that's the answer. Is that understandable or not? Okay, I hope I have done the calculation correctly. If there is some error of the calculation, you may ignore it, but I hope the calculation is fine. If I talk about the DC value here, DC value is not coming out to be correct, 1 by 4. Yeah, it is coming out to be correct only because DC value is 1 by 4 only. Yeah, so this calculation is correct. Basically, if you put n equals to 0 here, what it will throw? Sin square is, sampling square is 1. This will be delta f only. So DC value is coming out to be 1 by 4. Yes, sir. DC value was 1 by 4 only. So from this particular thing, you can get to know that 4 f naught, 8 f naught, 12 f naught, 6 f naught, 16 f naught, those are not present. That means even harmonics are absent. That is absolutely baseless, because even harmonics means 2 f naught will also not be present, but 2 f naught is present. If I put 2 here, then it would become sin pi by 2. That would be 1. So yeah, it would be present. Okay. Yeah, so that's the question. But you don't need to do all this analysis just to get the option 3, because here only you will get to know that it is not half-wave symmetry. It is not hidden half-wave symmetry. It is not half-wave symmetry. That means surely here even component would be present. Okay then. So let's go to the next one. Yeah, so this question is purely based on the properties of G matrix, generator matrix. What is the property? First property and very important property, that D minimum would be equals to W minimum. So you see all the rows. Whatever the minimum weight you are getting, that will be your D minimum. So what is the minimum weight you are getting? Sir, here the weight is 1, 2, 3. Here the weight is 3. Here the weight is 3. And here the weight is 4. So minimum weight is 3. So D minimum is 3. If D minimum is 3, what does that mean? Maximum number of detectable error. What that would be? Maximum number of detectable error. That would be equals to 2. And maximum number of correctable error. What that would be? Correctable error. Maximum number of correctable error would be 1. Detectable will be 2, correctable will be 1. Now another property is there, that all the rows of, listen to me very carefully, all the rows of generator matrix is a valid code word. All the rows of generator matrix is a valid code word. That means 1 0 0 0 1 1 0. That is a valid code word for sure. 0 1 0 0 1 0 1. That is also a valid code word for sure. 0 0 1 0 0 1 1. This is also a valid code word for sure. And the last row 0 0 0 1 1 1 1. That is also a valid code word for sure. It is a linear code. What does that mean? That means if I do the XOR of 2, then I can get the third valid code word. So what they are saying, 1 1 0 0 0 1 1 is a valid code word for the given linear block code. Is it valid or not? So how you can think that, sir, I need to make 1 1 0 0. Like my data word should be 1 1 0 0. Like they will represent the data word and they will represent the parity bit. I hope you are comfortable with this concept. They will be the data word and they will be the parity bit. So your data word is 1 1 0 0. Can you make 1 1 0 from here? Yes, sir. If I do the XOR of these two guys. So if I do the XOR of 1 and 2, 1 1 0 0, 1 XOR 1 will be 0. 1 XOR 0 will be 1. 0 XOR 1 will be 1. So this is the code word I am getting. Is it a valid code word? 1 1 0 0 0 1 1. 110011. Yes, sir. It is a valid code word. Now, what about this one? The code word corresponding to the data word 1101. I need to make 1101. How will I make 1101? 1100 I am already having. If I do 0001, so corresponding to 0001, what I am getting? 1111 I am getting. So this is a valid code word. Let's call it C1, and this is also a valid code word. Let's call it C2. If I do the XOR operation of both of them, what I am getting? 1101. So this would become 100. So this will be your valid code word. What does that mean? That means with respect to your data word 1101, your parity bits would be 100. But here it is saying that parity bits are 101. That means it is wrong. So A, B, and C, they are correct. Okay. Like you can do that particular thing as well. C equals to DG. Code word, if you know the data word, you can generate the code word as well. But that particular thing came from this concept, that all the rows of generator matrix are a valid code word. So if I know these 4 code words, I can get to know all the valid code words. Okay. Well and good. Let's go to the next one. Yeah, now these are also very standard question. What do we know? That frequency deviation will be affected by only the frequency multiplier. Okay, only the multipliers. But carrier frequency will be affected by the multipliers as well, and it will be affected by the local oscillator as well. So local oscillator, and the multiplier, both of the effect would be there. Well and good. So let's get started. So this guy is having FC and delta F. Both it is having. So FC will be multiplied. So here what you will be getting? You will be getting 4 FC and 4 delta F you will be getting. Eventually we are starting with the FC of 80 kilohertz and frequency deviation of 20 hertz. Now this frequency deviation is going to, where this frequency deviation is going? From 20 hertz to it is going 800 hertz. If it is going to 800 hertz, what does that mean? That means it should be multiplied with 40. It should be going through the frequency multiplication of 40, because 20 into 40 will be 800. Right? So if this is 4, this has to be 10. Because frequency deviation will be unaffected by this particular block. Frequency deviation will say that I am not affected by this particular block. He will be affected by this 4 and 10. He needs 40. That means this has to be 10. Now what about the carrier frequency? Carrier frequency will say that first I am affected. Here I have become 4FC. What is the meaning of 4FC? This was 80. 4FC means 320. So here it has become 320. Then there is a local oscillator. Some frequency would be coming here. And then he knows that I will be multiplied with 10. Now let's just say local oscillator is having a frequency of FL. So what this local oscillator would do? Plus minus FL. Then multiply with 10. And finally what he needs? He needs 1600. Right? 1.6 megahertz could be written as 1600 kilohertz. So this is what he requires. That means 320 plus minus FL should be equals to 160. So if you put 160 here, then also your job would be done. But 160 is not in the option. If you put 480 here, if I put 480 here, then what I will get? 320 minus 480. What that would be? 160. Yes, sir. That means this option is correct. Very straightforward questions. These you have seen in PYQs as well. 3 to 4 times these kind of questions have been asked in the previous year question. Okay, so very important concept, but very straightforward as well. Well and good. Let's go to the next one. Yeah, you need to find out the value of current I2. So this input current is given, that is 0.5 ampere, and op-amp is having non-ideal gain of 3. So if this node is V, what this node will be? Minus 3V. Say yes or no? Because this node is V, this node is 0. So 0 minus V multiply with 3 will be equals to V naught. So V naught would come out to be minus 3V. So can I apply nodal at V? Yes, sir. V minus of 3V, that would become plus 3V divided by 4. This current I have written, outward current. Then this current also I can write down. What that would be? V minus 2 divided by 2. V minus 2 divided by 2. This current also I write down. And there is input current as well, that is 0.5 ampere. That should be equal to 0. From here I can get the value of V. So 1.5V would be equal to 0.V. So V would be equal to 1 by 3. So value of V is coming out to be 1 by 3 volt. So what will be the value of current I2? I2 will be 2 minus 1 by 3 divided by 2. So that would be 5 by 6. So 5 by 6 would be what? 0.8 something. Right? 0.8333. Okay, so that's the answer. 0.833. Well and good. Let's go to the next one. Yeah, so here whatever the theory was written, that I did not put here. Theory was that V1, V2, these are the DC bias, VDD is the DC bias. They are operating in a saturation region. Now what they are saying? if V1 increases slightly a bit, if V1 increases, then what will happen to V0? So if this node increases, how much phase shift is there? 0 degree phase shift is there. So this node will increase. From here to here, how much phase shift is there? 0 degree phase shift is there. That means this node will also increase. So 0 degree phase shift, then again 0 degree phase shift. So if this node increases, this node will increase, this node will also increase. So if V1 increases, then V0 increases. What about V2? If this node increases, now I am talking about V2. So if this node increases, then what will happen? This node will decrease because there is 180-degree phase shift from here. So from here there is 180-degree phase shift. So if this node increases, then this node will decrease. So if V2 increases, then V0 decreases. There you go. So on slightly increasing the value of V1, V0 will increase. On slightly increasing the value of V2, the output voltage V0 would decrease. So 1 and 4 are the correct options. Okay, straightforward. Let's go to the next one.
The design specifications for a PD compensated marginally stable system are the following. So the damping ratio of the system must be this, the steady state error for a unit step input must be this, must be less than this. The values of lambda mu that satisfy this requirement, assuming that controller transfer function is this, basically it is a PD controller, and the planned transfer function is this, assuming the system to operate in unity negative feedback. Okay. So for unity negative feedback, what is the OLTF, overall open loop transfer function? That will be GP of S into GC of S, that is basically equals to 4, this will change, basically this will be 4 into lambda plus mu S upon S square plus 4. Okay, I think there is a typo here. This will be not there, right? Yeah. So overall your OLTF would be this. Okay. Now for this particular thing, what is the steady state error? How can I find out the steady state error? So for a so what is the transfer function? T of S. T of S would be G upon 1 plus GS, that is 4 lambda plus mu S upon S square plus 4 plus 4 lambda plus 4 mu S. Yeah, that's it. Right, this is my transfer function basically. Correct. So now what I can do is, what is the error? Do you remember E of S? It is R of S minus T of C of S, right? So if I take R of S common, this will be basically 1 minus T of S. Okay, and then again I can simply find out the steady state error. That will be, for a unit step, it will be S into limit S tending to 0, S into 1 by S into 1 minus this. So that would be basically, this will be cancelled. It will be S square plus 4 upon S square plus 4 plus 4 lambda plus 4 mu S. Okay. So this will be 4 upon 4 lambda, 4 upon 1 plus lambda, okay, equals to, now this has to be less than my 0.1, correct? This has to be less than my 0.1, right? Steady state error must be less than 0.1. So from here I can get lambda has to be greater than or equals to 9. Okay, lambda has to be greater than or equals to 9. So this is like one of the condition, lambda has to be greater than or equals to 9. What about the other condition? That my zeta of the system must be 1 by root 2, less than 1 by root 2. What is zeta? So transfer function is this, right? So from this I can compare the characteristics equation, that is my omega n square would be 4 mu, correct? Omega n square would be 4 mu. Am I correct? No, omega n square would not be 4 mu. Sorry. Hold on a second. So my lambda is this, right? Lambda has to be greater than 9. Actually they are asking like what are the what are the values that satisfy this requirement. So if I choose lambda equals to 9, if I choose lambda equals to 9, right, because lambda equals to 9 will satisfy the requirement. If I choose lambda equals to 9, then my characteristics equation is s square plus 4 mu s plus 40 equal to 0. So from this I can say what is my omega n. Omega n would be under root of 40. So my zeta, 2 zeta omega n would be 4 mu. Okay, 2 zeta omega n would be 4 mu. So my zeta would be 4 mu. Okay, now zeta value is given, the limiting value of zeta is 1 by root 2, right? So this will be 2 into 1 by root 2 into under root 40 equals to 4 mu, correct? So this is 2, this 2 will go away, this will be under root 20 by 2, under root 20 by 2, am I correct? So this will be under root 5, yeah. So your mu will come out to be under root 5. So under root 5 will be your under root 5 will be the value for which both these conditions will be satisfied. So option D will be your correct answer for this question. The OLTF g of h of s from the border plot is this. Okay, there is a OLTF, magnitude plot is given basically. Then like, okay, what will be the, like, basically what will be my g of h of s, right? So I see initially I have a slope of minus 20 dB per decade. So of course it is a type 1 system, right? So I see, yeah, all these are automatically gone. All these are automatically gone, right? So of course option 1 will be correct. Okay, what I will do is I will modify one of the options so that this also is s. Okay, otherwise like this question will be very very simple. At least I want you to do something, right? So I will modify the options. So yeah, let's now do other things. So I see that I have a change in slope at omega equals to 2. So and the change in slope is positive. So I have a 0 at 2. Okay, that is one thing. I have another 0 at 10. So 1 plus s by 10, because the slope is again increasing. And then again finally I have a pole at s equals to 50. So this will be 1 plus s by 50. Okay, into obviously s, because it is a type 1 system. Now what about this gain k? I am interested in this gain k. Yeah, okay. So what I can say is, when it is much smaller, have they provided us, so it is 0 dB, when is it 0 dB? That is what I am interested in. So they have not provided any values, right? Okay, because they need to provide the values, otherwise how will I find it? Okay, so at s equals to very high value, they should have provided something. So I will do one thing, I will provide this value very high, right? Actually your answer would be k will be equals to 1, basically k will be 1. So I will provide this magnitude. Okay, at very high, what is the magnitude? Basically very high value. So this, right, at very high value, so what will happen, the terms with s will dominate, because when s is tending to infinity, this will be very low compared to this. So let's say s is 500, this will be 500 j, like s equals to 500 j omega, sorry, j 500, then this will be very dominating, right? The imaginary part will be very dominating. So approximately all these can be cancelled, all this can like only the terms with coefficient of s will be taken. So this will be k s by 2 into s by 10 by s into s by 50. Okay, and this should come out to be equals to 1. Sorry, this will not come out to be equals to 1. What will be this value? Because ultimately, yeah, at high frequencies, at high frequency the gain should be what? Here what is the gain at high frequency? This will be 0.5 into 0.1 upon 0.02, that is 1 by 50 basically, correct? That is equals to 1. Sorry, it is not equals to 1, it is equals to 1 by 50. So this is 1 by 2, 1 by 10, 1 by 50. So yeah, this 5 will go, this will be 5 by 2. So at high frequency the gain is 2.5 basically. Here if I put the gain to be 2.5, then this k value would be 1 basically. Okay, so I'll change the question. I'll make the gain to be at high frequency 2.5. So if I make the gain at high frequency to be 2.5, then what will happen? Then, like, there was a typo here. This should have been, like, I forgot to put this 2.5 here, like in dBs. I'll put the value in dBs. So what will happen at high frequency? Only these terms will dominate. Why? Because if I assume my S to be, let's say, 500, right? My S to be J500, right? Because it is frequency, we're varying the frequency. Then the imaginary part will be very high. This will be J250 plus 1, which will be very large, right? Okay, all these will be very large compared to this real part. So that's why I can neglect the real part. I can only consider the imaginary part. Okay, so at high frequency the gain will be 2.5. So from this, like, you can again verify what will happen. This will be 1 by 20, 2.5, k will come out to be 1. Okay, so high frequency gain will be 2.5. From that you can get the value of k, like, although I solved. So basically what will happen, the high frequency gain would be this given, right? This will be given. You will compare, these things will cancel, S will be cancelled, this thing will cancel, and ultimately your k value will come out to be 1. So this will be your answer for the question.
Yeah, this is again very straightforward. Stationary and ergodic. Okay, stationary and ergodic random process is there. You need to find out the variance. What is variance? Variance is nothing but expectation of x square minus expectation of x whole square, right? Can you find out this value? Mu x square. That would be nothing but 4. Because in case of ergodic random process, the value at the infinity for autocorrelation function, the value at tau equals to infinity would represent the square of this would represent the DC power. That's it. Unless your autocorrelation function is having some DC offset. Sorry, unless your xt is having some DC offset. But I told you by default we will take xt having DC offset. Although it should have been mentioned that xt is having DC offset, but by default DC offset would be 0. So what is your mu x square you are getting? That would be 4. And what is expectation of x square? That will be this value, 25. So what will be the variance? Variance will be 21. Very straightforward property it is. But again, some people say that it is not necessary that it has to be WWSRP, or it is not necessary that it has to be ergodic. Ergodic and WWSRP both are separate things. If it is ergodic, then it will be WWSRP for sure, right? But ergodic have some different properties. If it is ergodic, then only you can say that at infinity it will be showing the DC power. And what sigma x square is known as? AC power. So they are asking AC power. AC power equals to total power minus the DC power. Total power will be the value at tau equals to 0, and DC power will be the value at tau equals to infinity for WWSRP and ergodic process. So both should have been mentioned. That is the necessary condition. Also, xt should have 0 DC offset, which by default we will take. Okay, well and good. Let's go to the next one. 21 is the answer here. Yeah, so let's see the solution of this one. So we need to find out the maximum and minimum load current. But if you are solving any kind of circuit analysis, if you are solving a question of a circuit analysis and you see this kind of circuitry, like where what I can do between these two nodes, I can replace a equivalent voltage and a equivalent resistance. Basically, I can find out the Thevenin here, no? Like, why would I want to do the calculation? First, I will find out the potential here, then I will go here and all this thing, right? I would find the equivalent. What is the equivalent? Equivalent says that voltage will be 6 by 9 into V in. So voltage will be 2 by 3 V in. So voltage will come out to be 2 V in by 3. What will be the resistance? 3 parallel with 6. What that would be? 3 into 6 divided by 9. 18 divided by 9, that would be 2 kilo. So I have find out the Thevenin equivalent. Now the problem would become easier. After that, this diode is connected, which is connected to ground, and then there is a load. There you go. Like, basically, if you are getting confused, you can make the diagram somewhat like this. Don't get confused with the ground. The battery is of 2 V in by 3. Okay. So previously what I did was that this is the ground. So everywhere I assumed the ground. So this will also be ground, this will also be ground, this will also be ground. Okay, and this is your load current RL. So it is driving a current of IL. It is driving a current of IZ. Look, I don't want to do any calculation here. I don't want to do any calculation here as well. So that's why 6 kilo ohm resistance is of no use for me. So what I did, I calculated the Thevenin. If I wanted to do some calculation here, then I would not do the Thevenin equivalent, but now I can calculate the Thevenin equivalent. Understandable? Okay. Now, do you know one thing? That if your load current would be maximum, sorry, not load current, if your general current is maximum, then your supply will be maximum. And if you want the general current to be minimum, then I would apply the supply to be minimum. I know what a lot of people would have done. What they would have done is that you want the load current to be maximum. If I want load current to be maximum, then that means I will put the maximum supply here. No. If you want this current to be maximum, if IZ is maximum, then supply will be maximum. Like let's just say from the supply IS current is going. So what is your IS? IS is nothing but IZ plus IL. So if IZ is maximum, then IL will be minimum. If IZ is maximum, that means you will put the maximum supply. The rule says, just you remember this particular thing, that these two are the brothers. That if IZ is maximum, then supply will be maximum. Supply will be maximum. If supply is maximum, then surely IS will also be maximum. Now what is your IS? IS is IZ plus IL. Now this is a maximum value. This is also at its maximum. So this will be, it's at minimum, no? Like this will be a constant value. This will be a constant value. If this is at maximum, then this will be at its minimum. Say yes or no? So you will get the minimum load current when supply is maximum. Are you able to understand what I am saying? You want the load current to be minimum, that means you want general current to be maximum. If you want general current to be maximum, that means you will apply the supply to be maximum. What is the range of input voltage? It is going from 9 to 18. That means this value will go from 9 by 3, 6 to 18. If I put 18 here, 6 to 12. So here the applied input will go from 6 volt to 12 volt. When it is 12 volt, load current like general will be turning on only. What is the drop here? That is 3 volt. So this will be giving a drop of 3 volt. When it is 12 volt, how much current it is driving? 12 minus 3, 9 by 2, 4.5 milliampere current it is driving. So when the supply is maximum, this current will also be maximum. What is the maximum general current? Maximum general current is nothing but 4 milliampere. So how much current we are driving here in the load? 0.5 milliampere. That means this is your minimum load current, which is 0.5 milliampere. What about the maximum load current? If you want maximum load current, if you want IL max, what does that mean? You need to keep IZ minimum. What is the meaning of IZ minimum? The supply should be minimum. So if supply is minimum, that means it is 6 volt. So if supply is 6 volt, here 6 volt, again by default I will assume that this has to be on only. So 6 minus 3 divided by 2. So this current would be 1.5 milliampere. Right? You want it to be maximum, that means load will drive the minimum current. How much current it is driving? Minimum current it would drive 0.5 milliampere. So it is driving 0.5 milliampere. That means how much current would be flowing here? 1 milliampere. So maximum current in the load would be 1 milliampere. So in the load you can get the current from 0.5 to 1 milliampere. What a lot of people would have done is that they would have put the maximum supply 4.5 milliampere. So this will drive minimum current, this will drive maximum current. So 4 milliampere they would have put here. The thing is, if you want the maximum current in the genre, then supply would be maximum. And if there is maximum current in the genre, then load will drive the minimum current. So always remember these two guys are brothers. Maximum current here, maximum supply here. Minimum current here, minimum supply here. Now if there is maximum current here, here there will be minimum current. If there is minimum current here, there will be maximum current. That's it. Okay, this kind of question have been asked in PYQs. Once it has been asked, there they asked about the minimum current. Now they can ask about the maximum current as well. So is that concept clear to you? Genre and supply both are friends. Okay, minimum current in genre, minimum supply. Maximum current in genre, maximum supply. Maximum current in genre, minimum current in load. Minimum current in genre, maximum current in load. Okay, let's go to the next. So such a big question, capacitor is given here, also capacitor is given. How would we solve it? Absolutely easy question it is. This was having 2 volt, right? V01 is having these are the steady state value. Initial value of V01 is 2 volt and this was having 4 volt. What kind of MOS it is? It is NMOS. Okay, like on the body the arrow is inward. What does that mean? Here the arrow will be outward. So this is NMOS. This is at higher potential, that means this will be drain. This is at lower potential. What does that mean? It will be source. The supply is 3 volt, 3 UT they are applying, 3 volt. Initially when the supply was 0, there was no current. When we have applied the supply to be 3 volt, then what will happen? Current should start, current flow should take place. What is the value of VT? VT is 1 volt. Let's just say I say that current flow will take place. Current flow will take place from the higher potential to the lower potential. That means this capacitor should charge. If this capacitor charges to 2.1 volt, then what will happen? The VGS value will become 0.9 volt, which is less than VT. That means current flow would stop. So already this circuit is at steady state. Already this circuit is at steady state. No, nothing would happen in the circuit. Steady state is already achieved. What is the VGS value? That is already equals to VT. At t equals to 0, what is the VGS value? VGS value is already equals to VT. 3 minus 2, that is already equals to VT. What does that mean? This is the steady state condition. So at t equals to 0 itself, you are getting the steady state. Nothing would happen in the circuit. If you want some current flow to take place, then you put it to be 4 volt. Then you would know that yes, current flow will take place. So this C, 2C, all these are there just to confuse you. But good question we have framed in our test series, where we have put a Vin equals to 4 volt. Then you would know that yes, current flow would take place, but since this is having 2C capacitance value, so it will lose lesser voltage, it will gain more voltage. So all those concepts we have seen there, right? But this was not that good question. It would simply say that yes, it is at steady state, so 2 volt and 4 volt, that would be the answer. That's it. Nothing would change. Circuit is already at the steady state. Let's go to the next one. Yeah, so there is a system which is having an input of xt and impulse response is also given and output is yt, right? So what will be your output yt? Sir, output yt would be nothing but xt convolved with ht. So xt convolved with, what is ht? Delta of t plus 1 plus delta of t minus 1. So what is your output yt? X of t plus 1 plus x of t minus 1. That is your output yt. Okay, this is your output yt. X of t plus 1 plus x of t minus 1. So can you draw the waveform of x of t plus 1 and x of t minus 1? Yes, sir. And then you simply need to add it up. So what will be the waveform of x of t plus 1? What will be the waveform of x of t minus 1? X of t plus 1. X of t plus 1. X of t plus 1 means it will be shifted backward. So it will be there between minus 3 to 1. Minus 3 to 1. And here you will have the peak value. Arey yaar. Minus 3 to 1. So peak value will be there at minus 1, no? Peak value will be there at minus 1. So this value is 6. And peak value will be there at plus 1 here. So this goes from minus 1 to 3 and peak value will be 6 here, but that would be occurring at, peak value will be 6 here, that would be occurring at plus 1. So you need to add both of them. That means between minus 3 to minus 1, this particular graph is there, but between minus 3 to minus 1, there is nothing. So what will happen? The graph will be followed between minus 3 to minus 1. So if I draw the graph, like here it is non-zero till minus 3, here it is non-zero till 1, non-zero till minus 1 and non-zero till 3. So the graph will be made between minus 3 to 3. And something is going to happen at minus 1 and plus 1 because nature is changing. Okay, so starting like this, this is how the graph should go. And then between minus 1 to 1, here there is a decreasing slope of minus 3, here there is an increasing slope of plus 3. I told you same slope will become 0. What will be the value? Value you can check at any point. At minus 1 it is throwing value 1, sorry, at minus 1 it is throwing value 6, here it is throwing value 0. At 1 this is throwing value 0, it is throwing value 6. So both values will be added 6 and 6. So here you will have 6 value, here also you will have 6 value. So this value will be 6. And then similar kind of graph after 1 to 3, this will decrease down to 0. At any point you can check, at t equals to 0 you can check. This is the slope of decreasing minus 3. So what will be this value? This value will be 3. What will be this value? This value will also be 3. So at 0 if I check the value, 3 plus 3 that would also be 6. So this will be the graph of yt. So within second you should be able to draw this particular graph. Okay, so this value will be nothing but 6. So what they are asking, slope of yt between minus 1 to 1, is it 0? Yes sir. Yt is triangular? No. Yt is trapezoidal? Yes. What is the energy of dyt by dt? So energy you need to find out. So energy of dyt by dt. Can you draw the waveform of dyt by dt? Yes sir. What will be the waveform of dyt by dt? So simply I need to take the slope. What will be the slope? Between minus 3 to minus 1, the slope will be 6 by 2, 3. And then between 1 to 3, then between minus 1 to 1, slope will be 0. And then between 1 to 3, the slope will be minus 3. This will be 6 by 2, that would be 3. This would be minus 3. Between minus 3 to minus 1, between 1 to 3. Okay. So 9 into 2 plus 9 into 2. So what will be the energy? 36 joule. So 36 joule. 134. Very straightforward question. These kind of questions should be solved. If you are aiming for a decent rank as well, then also this kind of question should be solved in the examination hall. Let's go to the next one. Yeah, so here they are saying that x of t is having a Fourier transform of x of omega. Then you need to find out the value of x of 0. So first thing that would click to me that, sir, I can do this particular thing. That x of 0 is equals to, if you know this particular thing, that x of 0 is equals to nothing but the integration of xt dot dt. But integrating this particular graph, very difficult for me. Then what I would think, that xt is the convolution of two particular graphs. x1t convolution with x2t. This is the scenario. And you know that, sorry, not convolution, multiplication. You know that multiplication in time domain will result in convolution in the frequency domain. So if I find out x of omega, that would be x1 omega convolution with x2 of omega. But don't forget one more thing, outward 1 by 2 pi would also come. So can I write down xt in this manner? I know that, sir, it is getting a form of sin 80 by pi t. Sin 80 by pi t. We are getting this form. But here pi square into t square should come. But here pi into t square is given. In our analysis, pi square into t square is coming. That means I need to multiply with pi as well. So I need to find out the Fourier transform of this one. I need to find out the Fourier transform of this one. Then I need to convolve them and then multiply with pi and then divide by 2 pi. So effectively I need to divide by 1 by 2. Multiply with pi, find the Fourier transform of this one, that would be x1 of omega. Then find the Fourier transform of this one, then convolve both of them and then multiply with pi and divide by 2 pi. Multiply with pi, divide by 2 pi. That means effectively I need to divide by 1 by 2. Is that understandable to you? So can you find out their Fourier transforms? Very easy. And can you do the convolution as well? Yes, sir. Again, very easy. So sin 80 by t, it would be there between minus 1 to 1. And the next one would be there between 1 by 2 to, like this would be there between minus 1 by 2 to 1 by 2. x1 of omega, this is x2 of omega. Between minus 1 by 2 to 1 by 2. Both are having amplitude of sin 80 by t, sin 80 by t. Both are having the amplitude of 1, 1 only. So this is having amplitude of 1, this is having amplitude of 1. This is between minus 1 and 1. And I need to convolve both of them. So if I convolve both of them, what I will be getting? Lower limit added. Higher limit added. What is the gap here? 1. Minimum gap is 1. So slope will be changing after a gap of 1. Slope will be changing after a gap of 1. What will be the slope? 1 into 1. Slope has to be 1. Slope has to be 1. So this is the graph you will be getting. The slope has to be 1. What does that mean? This slope has to be 1. So this gap is 1. Right? So this value has to be 1 only. 1 by 1, then only the slope will be 1. No? So this value has to be 1. But it should be multiplied with pi and divided by 2 pi. It should be multiplied with pi and divided by 2 pi. So what value you will be getting? 1 by 2. So this value is nothing but 1 by 2. So what they are asking? X of 0. This is your x of omega that you have drawn. They are asking x of 0. So what is the value of x of 0 you are getting? So that is nothing but 1 by 2. So answer is 0.5. Okay. So answer is 0.5. Well and good. Again, straightforward. It might happen that it would take a bit of time in the calculation, but you should be able to do it. Let's go to the next one. Again, very simple question. You need to find out the frequency of oscillations at node B. Okay. So starting from here, this will be the forward path and this will be the feedback path. So for forward path, what is the forward gain? Forward gain is nothing but this particular block and this particular block. And this is the ideal op amp, that means it is driving 0 ampere current. This is also driving 0 ampere current. Right? So this gain multiply with this particular gain. What will be the first gain? That would be A. And then what is the transfer function here? R upon R plus j omega L. Right? So A into R upon R plus j omega L. This is the scenario. But that will be multiplied with the same block diagram. So this will be a forward gain. What is the feedback gain? Feedback gain. Feedback gain is nothing but again the same thing. A R upon R plus j omega L. Now both, let's just say forward gain is, I cannot represent it by A. So what I will represent it? I will represent it by forward gain A1. Okay. And this is beta. So you know that angle of A1 beta should be 0 degree. right? So what is a1 beta? A1 beta is coming out to be nothing but a cube multiply with r upon r plus j omega l cube. Now what they are saying is that amplifier gives a negative voltage gain. This A is negative voltage gain. So what will, let's just say A is minus 2. So what will be A cube? That will be minus 8. What does that mean? That means that it is providing you a gain of minus 8. What does that mean? How much phase shift it will provide? If value is positive, phase shift is 0. If value is negative, phase shift is 180 degree. So this is already giving you a phase shift of 180 degree. That means from here, how much phase shift do you expect? Minus 180. A cube is already giving you a phase shift of 180. You would expect a minus 180 phase shift from here, so that the total phase shift becomes 0. So you need minus 180 phase shift from here. How much phase shift this is giving you? R upon r plus j omega l whole cube. How much phase shift this is giving you? R upon r plus j omega l will give me the phase shift of tan inverse omega l by r with the negative sign. 3 is there, so this will give me this much of phase shift. I need it to be equals to minus 180. That means I need tan inverse omega l by r to be equals to 60 degree. Now this I would have got in within seconds. How I would have got it within seconds? I know that this is giving me a phase shift of minus 180. This is also minus 180, this is also minus 180. So total phase shift minus 180, minus 180, minus 180. That would be equivalent to minus 180. Now how much is left? Plus 180 is left. That means I need 60 from here, 60 from here, 60 from here. I could have simply write down that the phase shift that I need 60, 60, 60. This will give me a phase shift of tan inverse omega l by r. So tan inverse omega l by r will be equals to 60. That's it. So directly, if I had been a student who has enough practice, who has studied oscillator in a good manner, I would be directly writing down this particular step. Now I know that L by R equals to 1 by under root 3 and tan 60 is under root 3. So L by R is nothing but 1 by under root 3 and tan 60 is 0, 1, 0, 1 by under root 3, 1 under root 3. So frequency of oscillation is coming out to be 3 radian per second. There you go. That's it. Now they could have asked the value of A as well. Mode of A beta, A1 beta should be equals to 1. So this is your A cube and R upon R plus j omega L. R upon R plus j omega L whole cube. This is what you are getting. So this should be equals to 1. So this could be written as 1 upon 1 plus j omega L by R. What is your frequency of oscillation? That is 3. L by R is under root 3. Cube of this. So A cube. This is also cube, this is also cube. So A cube 1 plus j omega L by R. That was coming out to be actually under root 3. Omega L by R was coming out to be under root 3. So A cube, what is the magnitude of this? That is 2. So A cube divided by 2 cube should be equals to 1. That means A value has to be 2 only. But it should give me the phase shift of 180 degree. That means A value has to be minus 2. So they could have asked the value of A as well. If I wanted to make this particular problem in a good manner, I would have said that what is the value of A. So minimum value, or for the sustained oscillation, the value of A is minus 2. For sustained oscillation, or for only for oscillations, A has to be greater than minus 2. Gain should be greater than 2 and phase shift will be minus 2 only. Phase shift will be 180 degree only. So A could be minus 2.5, minus 3, minus 4, everything would be acceptable. Okay, well and good. So you would have studied oscillator in a good manner, then you would be able to solve it. In 2024, 3 questions came from oscillator. Not 3 or 2 questions came. And I have given the complete concept of oscillator on YouTube itself. You can check that out. And whatever the questions of analog I am framing here, 2 or 3 days back I posted a video where I solved 10 PYQs of analog electronics in a good manner. So this is also based on PYQs only. Whichever the previous problem we solved, this problem based on PYQ only. This particular problem based on PYQ only. In 2024, this question have come. Just they connected this feedback. That's it. Okay. This is also based on PYQ. These kind of questions are asked a lot of times. This is also based on PYQ. In 2022, this came. So all the questions are based on PYQ actually in analog electronics. Whatever the questions you see, all are based on PYQs. Let's go to the next one. So you can watch that particular video as well. 10 PYQs I have posted. So those are not easy level questions. Like I have seen people are just bringing some PYQs videos and solving easy and easy questions only. Okay. So people feel that yes, we are confident and they are getting good enough of views as well. But we are hardly getting to 2000 views because we are solving something that is conceptual. And conceptual thing, people don't want to use their brain. So you solve those easy PYQs, in the examination you are not going to get anything. So spend your time in a good manner and on a good content as well, where actual efforts are put, not the longer watch hours. Okay, so if you run behind watch hours and views, then what kind of content you will be getting, and if you want, forget about it. Let's go to the next question. Yeah, sir, you are asking question on parallel plate waveguide, but sir, in our syllabus, rectangular waveguide is given. Rectangular waveguide and parallel plate waveguide both are same only. Just one of the length will be going to infinity. Basically, what is your rectangular waveguide? So rectangular waveguide looks something like this. From here, the wave will get into it, and this is how the wave will propagate. Now, what is parallel plate waveguide? Parallel plate waveguide is this. That's it. So here, this particular length will be infinity. So A will be tending to infinity here, and B will be the gap between both of them, that is equals to 2 centimeter. That's it. So what was the formula that we studied for cutoff frequency? Vp by 2a m by a whole square plus n by b whole square. Now this guy is tending to infinity, so this will be 0. Now under root n by b whole square, what that would become? Vp into n divided by 2b. So this is the value of cutoff frequency we will get. Okay. Mode is given TE1. That means value of n is 1. So what is the cutoff frequency you are getting? Vp by 2b. In GATE 122 as well, in the syllabus, they gave rectangular waveguide, but they asked the question on parallel plate waveguide. Okay. So it's not that, sir, parallel plate waveguide cannot come. You just need to know that one of the length is infinity. That's it. So Vp by 2b. Okay. So what will be the cutoff frequency? That would be, what will be Vp? Vp will be C upon under root of epsilon r. So 3 into under root 8 divided by under root of epsilon r will be 2. Into 2 is already there. What is the value of B? 2 centimeter. Right? So if I solve it, what is the value of Fc we are getting? 30 by 8 gigahertz. 30 by 8 gigahertz. 3.75 gigahertz. Did you understand what did I do it? What did I do here? This is centimeter, no? This will become 10 to the power 10. So 10 to the power 9 I took outside. So this became 30 divided by 8. So 3.75 gigahertz. This is the value of cutoff frequency we are getting. What we need to find out? We need to find out the guided phase constant. That would be 1 minus Fc by f whole square. Right? Your propagating frequency is greater than the cutoff frequency. That means yes, it will propagate. Propagation will be there. So if it will propagate, what is the value of beta? Beta is nothing but omega by c. What is the value of omega? Omega is nothing but 2 pi f. So 2 pi f 20 into 10 to the power 9. 2 pi f 22 pi into 10 to the power 10 and divided by c. Omega by Vp actually, not omega by c. Omega by Vp. What is the value of Vp? That is 1.5 into 10 to the power 8. Right? Because omega by c, sorry, what is Vp? Vp is c upon under root of epsilon r. What is the value of under root of epsilon r? That is 2. So Vp is c by 2. That means 1.5 into 10 to the power 8. What you are getting then? So this will become 10 to the power 10, 200 pi divided by 1.5. So 200 into 3.14 divided by 1.5. So 418.66 under root 1 minus Fc by f, 3.75 divided by 10 whole square. So just we need to solve this particular calculation. So let me do this calculation. 3.75 divided by 10. Again, it was formula based only. If you know the formula, then you will be able to solve it. Otherwise, you will not be able to solve it. That's it. There is nothing more, nothing less. So 388.10. 388.10. Okay, here they did not give the unit. Unit should also be mentioned. Okay, I should have mentioned the unit as well. So that I will mention here. Well and good. Let's go to the next one. So this question is based on electrostats and magnostats. Is that so? So this question is based on electrostats and magnostats. Is that so? Like every year from Maxwell equation questions are coming from Maxwell equations. Okay. And people think that it is from electrostats and magnostats. This question is also from Maxwell equation. Maxwell equation describes about the displacement current. Yes, sir, surely describes about the displacement current. What is that? Del D by del T. Can I write down del D by del T as epsilon naught del E by del T? Because D is epsilon naught E. Epsilon naught, what is the value of E? Like although it is a vector quantity, but we just need to find out the magnitude. So I am just taking the magnitude. What is the value of E? That is 10 cos 10 to the power 12t. Can you differentiate it? Tan epsilon naught can outside. This 10 to the power 12 will come here. 12t. There would be a negative sign as well, but I need to take the magnitude. At t equals to 0, they are asking if I put t equals to 0 here. What is the answer I am getting? 0. There you go. That's it. This is the answer. Displacement current, how it is related with d, del d by del t, epsilon E. This is how it is related with electric field, right? Del d by del t, electric field expression you write down, get the answer. What is the displacement current you are getting? 0. 0 ampere per centimeter square. Okay, let's go to the next one. So solar cell is given, you need to find out all these values. So reverse saturation current is given, that is 1 pico ampere. Okay, well, let's write down 10 to the power minus 12 ampere. Illuminated with the short circuit current is also given, ISC, or you can call it photocurrent as well, that is given as 25 milliampere. Maximum output power, that means VM into IM is also given. What is that? 12 milliwatt. And incident power is also given. What is that? 100 milliwatt per centimeter square. So what is the surface area? 1 centimeter square only. So input power is also given, that is 100 milliwatt. Understandable? Okay. What all things you need to find out? Fill factor you need to find out. What is the fill factor? Sir, fill factor is the maximum power that I can get, Vm into I1, divided by my dream power. What is my dream power? VOC into ISC. ISC value I am already having. From the value of ISC, can I get VOC? Yes, sir. What is the relation? ISC equals to I naught e to the power VOC by eta Vt. Eta value is not given. I will take by default equals to 1. Although it should have been mentioned, but I will take by default equals to 1. So ISC value I already know. 25 into 10 to the power minus 3. I naught 10 to the power minus 12. VOC I need to find out. Vt value should have been mentioned, that I will mention. It would come out to be 0.0259. So from here I will get the value of VOC. So what I would do, 25 into 10 to the power 9. So first I will put 10 to the power 9. So 9 and then take the 10 to the power. Then multiply with 25. Then take the ln. Then multiply with 0.0259. VOC you are getting as 0.62 volt. So Vm into Im is given as 25 milliwatt. ISC is nothing but 25 milliampere. Multiply with 0.62. So what is the value of fill factor you are getting? Into 25. Take the reciprocal, multiply with 12. 0.77. 0.774. Is it 0.6? No. Efficiency. What is the meaning of efficiency? What is efficiency? Efficiency is the maximum power that I can get divided by the input power. So how much power I can get? 12 milliwatt. 12 millivolt. Array yaar, milliwatt. 12 milliwatt divided by the input power, that is 100 milliwatt. So what is the efficiency you are getting? 0.12 or 12%. Is it 15.5? No. All of the above? No. That means this will be the answer. What is the responsivity? IPH by Pin. What is the photocurrent you are generating? 25 milliampere. And what is your Pin? Input current, 100 milliwatt. What is the responsivity you are getting? 0.5 ampere per watt. 0.25 ampere per watt. That means responsivity is correct. That's it. Okay. From solar cell, like hot topic it is. I would say very hot topic it is, that from here questions are going to come in the final examination. Well and good. So yeah, that's the solution of all the questions of BoosterX. Let's give the final words. So I will again record the video for the final words. Well and good, and we will meet at 6:30 p.m. Most probably at 6:30 p.m. or 7 p.m. You can see the scheduled session there. We will meet and we will talk about how much marks the toppers are getting and what you can expect from the marks that you have obtained. Well and good. So yeah, thank you very much.
The rate of change of phi x, y, z equals to, in the direction normal to its surface at the point this equals to what? So they are asking me the rate of change in this direction, in the direction of normal to this surface. Okay. So how do I calculate the rate of change? So basically they should have mentioned the maximum rate of change, because directional derivative gives me the maximum rate of change. Basically they are asking me the maximum rate of change, right, of phi along the normal of the surface. So what is my surface? How do I calculate the normals to a surface? So if I just find out the gradient of my surface, right, that will give me the normal vector of my surface. Okay, what is the gradient of this? Gradient of this would be 2xy plus y square, this is 0, into I cap plus into I cap plus this would be x square plus 2xy plus z square, okay, into j cap, then plus this would be 2zy into k cap. Okay, this is what my normal vector is equals to, right. Now I have to find out the unit vector, right. This is just the normal, I have to make it unit vector. So at point 1 comma 1 comma 1, so 1 comma 1 comma 1, if I put 1 comma 1 comma 1, this will be basically 3i plus this would be 4j plus 2k cap. Okay, 1 comma 1 comma 1. So the unit vector, right, unit normal vector would be simply 3 square plus 4 square plus 2 square. So that is 9 plus 16, 25 plus 2, that is 29. So this will be 3i cap plus 4j cap plus 2k cap upon under root of 29. Okay, that is my an cap vector. And like basically they're asking me the maximum rate of change, right. So I have to find out the directional derivative, right. That would be basically the dot product of my uh, basically I have to do grad of phi and then take the dot product with my normal vector, that is my directional derivative. I hope you remember these things, right. So yeah, what is grad of phi? Grad of phi would be, this will be yx yz. So let me first of all calculate grad of phi. Yz I cap plus yz I cap plus x yz I cap plus xz j cap yz I cap plus xz j cap, right. Yz, yeah, yz I cap plus xz j cap plus xy k cap. So this will be basically I comma I plus I cap plus j cap plus k cap, that's it, right. So this will be my grad of phi I cap plus j cap plus k cap. This I will do dot with 3i plus 4j plus 2k upon root 29. So this will be equals to 3 plus 4 plus 2 upon root 29. So in the options, yeah, this will be 9 upon root 29, that is present in option B. So option B will be your correct answer for this particular question. If there are 5 people in a row, what is the probability that no 2 of them have the same birthday? Okay, so if 5 people are there, what is the probability no 2 of them have the same birthday, right? So if I assume that, let's say the birthday of one of the people is on the date X, right, let's say 19th of October or whatever, then the birthday of the other person, right, cannot lie in this, right. So how many choices I had to choose for the birthday of person X? 365, right? I have, in a year, like assuming normal year, right, I have 365 choices, the 365 dates to choose from for the first person. The birthday can be any 365. As soon as I have chosen a date for the person 1, for the person 2, the number of dates are 364. because let's say I have chosen 19th of October for the first person. For the second person, I cannot choose 19th of October because they have told me that no two of them have the same birthday. So that's why I will have one less number of days. Again, for the third person, I will have 363 days. For the fourth person, I will have 362, and for the fifth person, I will have 361 days. So these are my number of days with which I can choose the birthdays, right? So if I did not had any condition, then in how many ways? So this will be multiplied, right? Because person 1 has a birthday, then I will choose the birthday for the person 2, then I will choose the birthday for the person 3, then I will choose the birthday for the person 4, and finally the person 5. Okay. Now, if let's say I did not had any condition, so what is how many what are the total number of ways that person 1 can have birthday? There are totals 365 days. So any day can be birthday for the person 1. Again, there are 365 days for the person 2. Any day can be birthday. There is no condition. Previously, if I had chosen 19th of October, I cannot choose 19th of October again. But here, if person 1 has birthday 19th of October, no problem. Person 2 can also have 19th of October. Basically, I am calculating the total samples upon the favorable. These are my favorable samples. I am computing the total samples. So for person 3 also 365, person 4 also 365, person 5 also 365. So overall your answer would be this 365, all this multiplied, 365 into 364 into 363 into 362 into 361 upon 365 raised to the power of 5. Okay. So if I solve this, right, you will see that this will be cancelled automatically, and this I can write 365 minus 1, which is this value, divided by 365 with this value. Again, this will be 365 minus 2, which is this value, upon 365. Again, this one and this one. So option D will be your correct answer for this question.
Yeah, so you guys are done with the complete solution. I hope you have understood whatever the new concept that you want to learn, or you would have surely understood something new here. Okay, so now we will come live at 6:30 p.m. Don't forget to join here. We will come live at 6:30 p.m. Whatever the query that you are having, that you can ask, and we will do the complete discussion of the question paper. Whatever the marks topper is getting, and how much marks rank 10 guy is getting, and based on your marks, where do you stand? So whatever the analysis that we did for Killer X, the same kind of analysis we are going to do for Booster X as well. So you can come live at 6:30 p.m. Along with that, one more major announcement, that this is still active. This test is still active. Test is still active. You can attempt the test if you haven't attempted it. But if you are in the end of the video, though, you would have already attempted it. So let's keep it still active. You can attempt it. Okay then. Yeah. Thank you very much. Let's meet at 6:30 p.m. in the live session. Yeah. Thank you.